Hello all, welcome to this session. In this session, I am going to answer software testing interview question 101. That is, what is product vision in Agile Scrum methodology? Let me answer. There are different projects which follow different SDLC models for building and releasing the software into the market. They are waterfall, prototype, V, spiral, iterative incremental, agile SDLC model, RAD, and Big Bang. These are the different SDLC models which will be followed by different projects for building the software and releasing the software into the market, while Agile is one of them. Okay, Agile is one of the SDLC model. Under Agile SDLC model, we have different methodologies or frameworks like Scrum, Kanban, Lean, Extreme Programming, Crystal, FDD, DSDM, and so on. And in this Scrum methodology of Agile, that is in Agile Scrum methodology, okay, in the projects which are following this Agile Scrum methodology, there is something known as product vision, guys. Okay, so there's something known as product vision. What is this product vision? Let me explain. Before I read this all these lines for you, I want to explain. Okay, I want to explain this product vision with a real world example. Okay, instead of explaining this product vision in Agile Scrum methodology terminology, I'm going to explain product vision first in a real world example. Let's say, guys, there is a in the market there are a lot of companies which are selling cars, right? So there came some XYZ company which got a product vision, okay, which got a product vision where they want to manufacture and sell electrical cars in the market. Okay, they want to manufacture and sell the electric cars in the market. That is their product vision, guys. Okay, so here electric cars is the product. Okay, the vision of that particular company is to produce and sell electric cars for less price, which will give more mileage and it can beat the competition. That is their product vision in real world example. The same product vision, okay, can be applied for Agile Scrum methodology projects for building the software and releasing them into the market. Okay, so every software is a product, right? So every company, a company which is trying to produce the software and release the software into the market will have a vision about that particular software. Okay, in the projects which are following this Agile Scrum methodology, we have a concept known as product vision. Okay, so before the project starts, the product owner, okay, before the project starts, the product owner will create this product vision. In this Agile Scrum methodology followed projects, the product owner will create a product vision. Okay, he will prepare a product vision of what the software is going to be achieved after producing and selling in releasing in the market, what the software is going to achieve. All these things is nothing but the product vision. Who will create that? Product owner will create that. As you can see in this diagram, guys, okay, this is Agile Scrum methodology diagram. You see there is a vision here. Okay, the product owner is going to create this vision. Based on this vision only, the work will start. Okay, for example, if you thought about constructing a very beautiful house in your village that no one has the same house, so you'll have a vision about the house, right? You have a vision about that building, how you want to construct that building. So it has to compete with, right, all the houses in the village, and it should be according to the, it should have very good architecture, right? Very, very good looking one that no one can have in the village kind of sort of thing. Okay, it may be in the cities, but in the village, such kind of houses won't be there. So that may be your vision. Okay, to have such kind of house where cities will have such kind of houses in the village is your vision. So to make that vision possible, a lot of things will be there. A lot of requirements are required, right? To reach that product vision, that where you want to build a kind of beautiful house at your village, okay, with all the interiors and all in a village where this kind of things won't be there generally. So your vision will be like that. Your vision is like that. For that, lot of requirements. Okay, you have to bring the construction material. You need to bring very good architects. Okay, who generally don't work in villages, right? You have to bring them from the cities. So all these are your requirements. Okay, before the work starts, before the project starts, you're going to create a product vision. This is what I want. Okay, so that this is a benefit I'll get. That is what is product vision, guys. Coming to the software, guys, in projects which are following this Agile Scrum methodology for building and releasing the software into the market, in such kind of Agile Scrum methodology followed projects, the product owner will create a product vision. Okay, and he that is nothing but a goal, right? What you want to achieve with by producing the software and releasing that into the market. What you want to achieve? That is nothing but the product vision in simple words. Okay, here the product owner will create the product vision before this project starts. Fine, in this Agile Scrum methodology followed project, this is Agile Scrum methodology. So product owner will create this product vision before the project work starts. Okay, before the work starts. So here if I have to explain it theoretically now, you understood, right, what is a product vision, right? Now you can understand more from these lines, okay? So product vision in simple words is nothing but the goal to be achieved by building the product, okay? So what is the goal that the company behind this particular software want to achieve by building that software, okay? So everyone want to build a software, but there is a goal behind that, right? Why? You see, why Amazon.in? For example, if you talk about Amazon.in software, okay, what is the goal behind this software? Okay, so the product owner, if the product owner has to create a vision, product vision for this particular Amazon.com, what may be the product vision for that, guys? Okay, to sell, okay, to sell, to create a platform where the people can buy and sell products in the market, okay? That's what is a online, via online, okay? On online, via online, the people should be able to buy and sell the products. That is the product vision of Amazon.in application. That's what is that is a goal, guys, okay? Goal to be achieved by building the product, okay? The Amazon company is achieving a goal here, that is creating a platform where the sellers can sell their products, buyers can buy the products online, okay? That's what is a goal achieved by the Amazon company. How it is achieved? By building the product, okay? So that is what is product vision in simple words, okay? So what is the purpose? So if you create this, if the product owner creates this kind of product vision in the agile scrum methodology followed projects, beforehand the project starts, the what is the advantage or what is the purpose? It guides the scrum team, the who are the people who are going to work on this project or product, okay, building the product as part of the project, okay. uh, it guides the team, okay, who are working on the project with the long term direction of a product. They know where they are heading to, okay. So they know that whatever the product they are trying to build, they have the idea, okay. With the product vision, they will have an idea that, okay, this is what we are trying to achieve, okay, by building the software over a period of time. This is the benefit we are going to get. This is what we are trying to achieve. This is what is the value we are going to get, that the scrum team will know in advance. So guides the scrum team with the long term direction of a product, because building such kind of Amazon in kind of softwares will take a lot of time. So without having a product vision, the team will not understand what they are working on, okay. They should have an idea, basic idea of what exactly they are trying to build, and whatever the value that they are going to achieve by building this kind of software, they should have the idea in advance. And that's possible with the help of product vision. And who will create this product vision? Before the work starts in the project, product vision in this agile scrum methodology followed projects will be created by product owner, okay. Product owner will create this product vision. What does this product vision contain? You see a lot of things it will contain, guys, okay. Which market segment that the product address, okay. By producing and selling this product in the market, okay, which market segment, e-commerce segment, or what area that the product address, okay. Who are the target customers or end users, okay, who are going to use this particular software, okay. This product vision will have all this information, guys, okay. Product owner will create this product vision with all these details. What problem does this product solve? Okay, for example, if you take Amazon.in, what problem does the Amazon.in solve? It will create a platform for the sellers to sell their products and buyers to buy the products, okay, online. That's what is the problem there, the Amazon.in solving. All this information will be there in the product vision created by the product owner. How does this product stand out in the market, okay? How does this particular product that you are trying to build will stand out in the market and beat the competition? So what are the business goals? What is that company is going to get, like which how much money it's going to generate, any profit will come for the company? What are the business goals because of which the company has decided to produce or sell this product in the market? All these kind of things will be there in the product vision document, and this particular product vision will be created by product owner, and whose goal is to whose whose purpose is to guide the scrum team with the long term direction of a product, okay. Before the work in the project starts, okay, if the product vision is created, the team who is going to work on this knows that what they are trying to work on, okay. They have a long term view of what they are trying to build in advance. The developers will know what they are trying to build, testers will know what they are testing in advance, okay, before the entire product is visible for them. So in simple words, product vision is nothing but the goal to be achieved by building the product. Who will achieve this goal? The company who is trying to produce the software and release in the market, right? The company will achieve this goal by building this product, okay. By making this product, by creating this product and selling in the market, the company will achieve this goal. That is nothing but product vision. So hope guys you got the answer for what is product vision in agile scrum methodology. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 102. That is, what is sprint zero? Let me answer. Whenever you get this question in the interviews, you have to be careful and answer this question in a diplomatic manner. Why you have to answer this question in a diplomatic manner? I'll explain now. So what is sprint zero? As per Scrum, that is as per Agile Scrum methodology, there is no term like sprint zero. You may be surprised. They are asking you a question, what is sprint zero? But here I am saying that as per Scrum methodology, as per Agile Scrum methodology, there is nothing like sprint zero. There is no term like sprint zero. Then why these interviewers are asking you this question when there is no term like sprint zero in the Agile Scrum methodology? I'll explain. So you already know in agile projects how the work will be done. In agile scrum methodology following projects, how the work will be done in the form of sprints. Okay, every sprint is an iteration. Okay, a time bound iteration. You see, this is the sprint one. Let's say this is sprint one. The work will be done in the agile scrum methodology projects in the form of sprints. So here sprint one is nothing but an iteration, you can say. So in this iteration, some portion of the work will be done. The duration of this iteration will be from 1 week to 4 weeks. Okay, duration of this iteration will be from 1 week to 4 weeks. After this sprint one is completed, then sprint two will start. The next iteration will start, that is sprint two. This also will have the same duration of the sprint one. Okay, so if the sprint one is of 2 weeks, the sprint two also will be 2 weeks. Okay, the second iteration. Then next iteration. Then next iteration, that sprint three, sprint four, sprint five, like this, the work will continue. The actual work is happening in the form of sprints. But what happens in some projects is, before this actual work, which is done in this sprints, okay, starts, okay, before this actual work that has to be done in the sprint starts, what the project team will do is, here, the project team will, before the actual sprint start, the project team will spend some time here on getting some things ready, guys. Okay, the project team may spend some time in something like setting up the environments, getting the required number of people who need to work on the projects, conducting trainings so that they can if the people who are assigned to the project doesn't have the necessary skills to work on the project, they have to provide the trainings. And they have to figure out the tools, they have to investigate and figure out the tools and many other stuff, this kind of prerequisite stuff. Okay, the project team, before actually starting the work in the form of sprints here, okay, before starting their work in the form of sprints here, they may have to spend some time in advance. Okay, before the actual work starts, they have to spend some time doing all this kind of stuff like setting up the environments, getting the people for the project, conducting trainings and figuring out tools and all those stuff. Okay, so these activities, this I can call them as prerequisite activities or initial phase activities, whatever you call, they will take some time. Okay, they take some time, so they have spent some time. So so this project team, okay, before starting their actual work in the form of sprints, have spent some time on getting these things ready. So you see, in agile, we have to name it something, right? So these project team who are actually spending this time before actually starting working, right, they are giving a name for this particular time spent as sprint zero. They are giving it as sprint zero. But as per agile scrum methodology, there is no term like sprint zero. But still, the agile project team, before starting their actual work in the form of sprints, they are spending some time, and this time they are giving the name as sprint zero. But this is not official. They are unofficially giving it, even though there is nothing like sprint zero in agile scrum. But this project team is unofficially, okay, there are some projects out there, they call sprint zero. Okay, but in reality sprint zero doesn't exist. Okay, they are unofficially naming it, guys. Okay, so it's an unofficial word followed in the industry. Okay, so but as per the agile scrum methodology, there is no term like sprint zero. But still, the project team who are spending some prerequisite stuff on getting things ready, right, before the actual work starts in the form of sprints, right, they are giving this particular phase of the time that they are spending in getting the things ready as sprint zero. Okay, but again, as per the agile, sprint has to produce some work. Okay, the sprint has to produce some work. Where the work will be produced from the sprint one onwards, here the work will be by the end of the sprint one, some work will be done. Okay, some portion of the software will be ready. And after the end of the sprint two, some other portion. Okay, it will keep on incrementing, like the software will keep on incrementing. But here, so after the sprint zero, will there any product available here? Will there be any software ready here? No. So as per agile, sprint has to produce some work. Here there is no work produced. These are all getting things ready things. This is not the actual work. So there is no work produced. That's why Agile is strictly stating that there is nothing like sprint zero. Okay. If you have to name that as sprint, it has to produce some work, which sprint zero is not actually producing. And hence sprint zero is an unofficial term given by some projects. Okay. Just for their satisfaction, they are giving this kind of term known as sprint zero. But in reality, as per the Agile Scrum methodology, there is no term like sprint zero, guys. Okay. As no work can be produced in sprint zero, there is no term like sprint zero. And instead, guys, if you have to officially give some name to this particular thing that you are doing before starting your actual work in the form of sprints, right? If you want to give some name to this time, instead of calling that as sprint zero, you can call that as discovery phase or inception phase or initialization phase. But sprint zero is not a good thing. Okay, though some projects are calling it, it's better to call that as inception phase or discovery phase and initialization phase. Okay, instead of calling that as sprint zero. So you got the clarity, right? Why you have to answer this question in a diplomatic manner when you get this question in the interviews now, right? There is no term like sprint zero in Agile Scrum dictionary. So this unofficially called term. So if you want to officially mention this particular thing, right, then you have to instead call that as discovery phase or inception phase or initialization phase instead of calling that as sprint zero. If you still want to unofficially do it, you have to call that as sprint zero, but it is an unofficial term, guys. Okay. So this how, guys, you have to diplomatically answer this question when you get this in the interview. What is sprint zero? You have to diplomatically answer, and you should be very careful while answering. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 103. That is, what is spike in Agile Scrum? Before I explain what is spike, let me explain a problem that you may face in Agile Scrum due to which spike is required. Okay. So let me explain you about the problem in Agile Scrum due to which the spike is required. Okay. So what is that problem in Agile Scrum? As you already know, in Agile SDLC model, we have Scrum methodology. In the Scrum methodology, the development will happen in the form of sprints. Sprint 1, Sprint 2, Sprint 3, Sprint 4, Sprint 5, and so on. Right? Every sprint is an iteration here, which will have a duration of 1 to 4 weeks. Okay. Depending on the project, the sprint duration will have 1 to 4 weeks of duration. Okay. So in that particular sprint, some stories will be assigned. Okay, some user stories will be assigned. User stories are nothing but the requirements. These requirements will be assigned to each and every sprint. If before the sprint starts, these user stories will be assigned to the sprint, and by the end of the sprint, the development team, that is developers and testers who are working in this project, okay, have to complete these user stories. They have to develop it and test it by the end of the sprint. That's what we generally do in the Agile Scrum. Okay, so we work in the form of sprints, where in each and every sprint, some user stories will be assigned, and these user stories need to be completed by the development and testing team by the end of the sprint. But there may come a situation where one of the user story is kind of very typical user story. Okay, it's not a easy user story. Maybe it's a technical challengeable user story, or it's a complex user story whose requirement is not clear. Okay, it will take some time to understand the actual requirement. Okay, so it may be the complexity level of this particular user story may be high. Okay, it's a user story which can be assigned to a sprint, but this user story has a technical challenge. So developers have to think about different ways in which they can solve this problem. Okay, to in order to develop this particular requirement, okay, as part of building the software, in order to develop this particular requirement related functionality, developer may have to think. Okay, they have to create something, or it has a technical challenge in place, so they have to do some investigation here. Or there may be some situation where this user story may be complex. Okay, business wise, understanding this user story with the given details is not so easy. It's a complex one. So that kind of situation may come, guys. Okay, not all user stories will have this kind of approach. Okay, so maybe somewhere here and there you may come across a user story which has very high technical challenge and high complexity levels to understand. Okay, these are this. In such kind of cases, in such kind of cases, what will happen is, we'll create, okay, the product owner will create something known as a spike, guys. Okay, so the spike will be created. So along with this user stories, a spike will be created. Spike is also user story, guys. Okay, spike is also a, what is spike? Spike is also a let's say this is a spike. Okay, remaining all are normal user stories, whereas this red color one user story which I represented here, let's say it is a spike. Why spike is created here? Why spike is created here? So as you know, this particular user story is kind of having technical challenges, or it may be having some complexity levels in understanding the user story. So if the team has to directly work on this user story, okay, there is a possibility of failure, guys. Okay, if the team is assigned this user story directly, then what happens? Because of the technical challenges or because of the complexity levels of the story, the development team, that is developers and testers, will not be able to develop this particular user story. Okay, there is a cause of failure here. Okay, they may end up in a failure. Okay, they may not be able to complete this story by the end of the sprint because of the technical challenges or complexities in this particular user story. In that case, for example, guys, uh, this is a user story. Okay, let's assume that this is a user story which has technical. Remaining all user stories are kind of easy, and there's no worry regarding these three user stories that are assigned to this sprint. But this green color user story, let's assume that it has very good technical challenge. Okay, it has a technical challenges, or it may have some complexity levels in understanding the story. Okay, this green color one. So if the development team is assigned with this particular green color user story directly, they have to work, there is a possibility of failure. Okay, they may not be able to complete this user story by the end of the sprint because of the technical challenges, or they don't know what to do. Okay, so they don't know what to do, or it has a complexity levels, guys. Because of that, they are unable to understand the user story. So here what is required? What is required, guys? Okay, to solve this problem, what is required? Investigation is required, right? To work, to before working on this user story, what is required? Before working on this green color user story, what is required? Some investigation need to be done. Okay, investigation. The development team, that is agile team, has to do some investigation on this user story before actually working on this user story. For that reason, this particular sprint, along with this complex or technical challenge user story, okay, this sprint will be assigned with something known as a spike. Okay, this red color thing is nothing but a spike. Spike is also user story. Okay, spike is also user story, but this user story is created with an intention of doing an investigation on this green color user story, the user story which is having the complexity or technical challenge, right? Okay, to do the investigation on this user story which is having the technical challenge or complexity levels, a spike user story will be created and assigned to the sprint. So before you work, okay, before the agile team works on this technical challenge or complexity level user story, the development team, that is developers and testers, have to work on this spike. As part of, they have to do the investigation. Here, by doing the investigation, you are not producing any you are not building any software or functionality of the software here. Okay, the output of this spike is not about the producing any functionality. They are not developing or testing any functionality of the software. The output of the spike is investigation, finding out figure outing a solution. Okay, in case of the user story having a technical challenge, that the team has to come up with a solution to solve this technical challenge. In case this particular user story is having a complexity level in understanding, okay, so here investigation need to be done to understand the user story. Okay, with the help of other meetings and all, this user story need to be investigated. So to perform the investigation, to understand this user story having the technical challenge or complexity, the spike will be created, which will be time boxed, guys. Spike will be time boxed. Okay, some 2 hours or 3 hours of time will be decided for this spike. But here the output is only investigation. The output is not building any software functionality. Okay, so this is what is spike, guys. This is why spike will be created. As you can see now, it will be more clear for you. What is spike? Spike is a time boxed user story which is created with an intention of doing investigation. Okay, here you are not building any software functionality. Here, the agile team is going to use this time boxed user story, that is spike, to do the investigation. Okay, so what will happen if you investigate with the outcome of this user story, where you are doing investigation? This gives a possible solutions. Okay, if there is a technical challenge user story, right? For the technical challenge user story, this particular spike user story investigation will give you the possible solutions and also estimations. Okay, so now the agile team can estimate, because now complexity in understanding the user story. Okay, this particular actual user story, there is a complexity in understanding it. That's why a spike is created with the investigation. Okay, the now the agile team can understand this actual user story and they can estimate it properly. Okay, this is what is this is what is spike is. It's a time boxed user story created for the purpose of investigation whose outcome gives possible solution estimations for the actual user story. Okay, this spike user story is created for doing investigation on the actual user story. That's what is spike is. So not every time spike will be created, only when there is some user story which has some technical challenges or complexity in understanding the user story, then only a spike user story will be created with an intention of doing investigation on the actual user story. So that we can find out the possible solutions and the agile team can do the estimations for the actual user story. That's what is spike is. So what are the different reasons why spike will be created for the actual user stories? Okay, spike will be created for for investigating on unknown things. Okay, if there is a user story in which some things are not clear or unknown, okay, in that case a spike user story will be created. With the help of that spike user story, which is a time box user story, that a given time, that is 2 or 3 hours, investigation will be done, and whatever the unknown things are there in the actual user story, right, that will be cleared. Okay, so before the actual user story starts, before the agile team starts working on the actual user story, they will do the investigation on this story with the help of this user story known as spike, okay, which has a time box. Okay, then risks of failures. Okay, so if the actual user story has some technical challenges and multiple solutions are there, okay, here there is a possibility of failure if the story is actually worked directly by the team, and there is a possibility that the story results in a failure. Okay, the agile team may not be able to develop the story well. Okay, there is a risk of failure. But if a spy kind of user story which is time boxed is created for investigating the actual user story in case of technical challenges, right, in that investigation time, the multiple out of multiple directions of solving the technical challenge, okay, the investigation will result in a possible solution that development team can implement as part of the actual user story. Feasibility of solution. Okay, as I told you, right, there may be multiple solutions possible in which we have to choose the best solution for solving implementing this actual story, and that investigation for finding out the feasibility of the proper solution will be done in the form of a spike user story. Okay, then estimation and re-estimation of stories. Okay, if the story is not clear, if the actual user story is not clear, if the agile team is asked to estimate without creating the spike, they will randomly estimate, that estimations will go wrong. So here, so even though the actual story is estimated or it's not estimated, guys, if a spike kind of time boxed user story is created for investigation, after the investigation, now the agile team will get a clarity on how much it has to estimate. Okay, if it's already estimated and is wrongly estimated, then there is a possibility of re-estimation also. Okay, with the help of the investigation, we can re-estimate the actual story points for this actual story. That's what is the benefit of the spike, guys. Okay, so hope guys you understood what exactly is spike. Spike is a time boxed user story which is created for investigation purpose, whose outcome will give possible solutions and estimations for the actual user story. For the purpose of the actual user story, we are creating this spike user story, whose purpose is only investigation, guys, which not result in any building of any software functionality, is not part of the spike, guys. Okay, so only when required we generally create spike. So hope guys you understood what exactly is spike in agile scrum. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 104. That is, what is velocity in agile scrum? Let me answer. So what is sprint velocity in agile scrum methodology following projects? It is nothing but the average amount of work. Okay, velocity is nothing but the average amount of work the agile team has completed in the previous sprints, and using that estimate, we can estimate how much work the agile team can do in the future sprints. Let me explain this line a bit. Okay, so you already know the projects where agile scrum methodology is followed, the development and testing, the work will happen in the form of sprints, right? So here sprint 1, sprint 2, sprint 3. In agile scrum methodology following projects, the work will happen. Okay, in that kind of projects, the work will happen in the form of sprints. Sprint 1, sprint 2, sprint 3, sprint 4, and so on. Let's say this is sprint 1. After sprint 1 is completed, some amount of work will be delivered here. Okay, after the sprint 1, let's say this amount of software functionality will be ready at the end of the sprint 1. After that, sprint 2 will start. Okay, this is sprint 2. Sprint 2. After sprint 2, some more work will be delivered. Okay, along with the previous work, some more work. So it will increase. The amount of work that will be delivered after the end of the sprint 2 will be increased. Okay, after sprint 2. Then sprint 3 will start. In Agile Scrum methodology for projects, the work will happen in the form of sprints where the work will be delivered like this. Okay, so more work will be delivered here. Okay, along with the previous work, some more work will be added and more work will be delivered. Then sprint 4. Sprint 4. And after the sprint 4, even more work. Okay, along with the previous work, more work will be delivered and the process will go on. The process will go on. So it will, the sprints will continue. Here, each and every sprint is nothing but an iteration. Okay, each and every sprint is nothing but an iteration having some duration. So general duration that sprints will have depending on the projects, guys. Okay, different projects will have different sprint iteration duration. It can be from 1 to 4 weeks. Okay, it can be 1 week or 2 week or 3 week or 4 weeks. Okay, different projects will follow different sprint durations. Most of the projects will follow 2 weeks duration. Okay, 2 weeks. 2 weeks means 10 working days. Assume that this sprint is taking 10 working days. That is 2 weeks duration of sprint. That is 10 working days. And here sprint to also 10 working days. Every 10 days and 10 working days, some some sort of functionality is being delivered. Okay, and in the next sprint, more functionality will be in the third sprint. Even more functionality will be delivered and so on. Okay, so work will be done in the iteration fashion in Agile Scrum. Okay, this is a process followed in Agile Scrum methodology projects. Agile is an SDLC model. Under Agile, we have the Scrum methodology. The projects which are following the Agile Scrum methodology, okay, will work in the form of sprints like this. Okay, they will work iteration by iteration. So for every sprint or iteration, some stories will be assigned. Okay, some user stories will be assigned to the sprint. The product owner will assign some user stories to the sprint. Okay, before the sprint starts, the product owner will assign some work to the sprint, that is in the form of user stories. User stories are nothing but this particular square boxes I am represented here are nothing but the user stories, which are nothing but these user stories are nothing but the small chunks of requirements. These requirements have to be developed and tested by the agile team. By the end of the sprint, all these stories need to be completed. Okay, so you see, the agile team, that is developers and testers, have started working the beginning of the sprint on these user stories. By the end of the sprint, they complete these stories. So how many they completed? How many they completed? And on the top of that, guys, each and every story will have some story points. Okay, each and every story will have some story points. I'm writing SP here in short. Every story will have some story points. Story points. So if the agile team, that is developers and testers, have completed all these user stories by the end of the sprint, now we can calculate, right, how many user stories. Okay, how many story points, total story points, TSP. Okay, the story point plus the story points of each and every story we are calculating, guys. We are adding it here like this, plus, and finally by the end of the sprint, the agile team has completed all these stories. We can know how many story points the agile team has completed in the sprint one, right? So this calculation, this total story points, is nothing but velocity. Okay, the amount of work the agile team has completed by the end of the sprint is velocity. Now again, after sprint 1, sprint 2 will start. In sprint 2 also, again, the product owner will assign some other set of user stories for the agile team to finish by the end of the sprint. And here also these stories will have the story points. So by the end of the sprint 2, if the agile team has completed all these user stories, then we can get the total story points here also, right? For the sprint 2 also we'll get total story points. Here, how do we calculate the velocity here? Here, what we'll do is, after sprint 2, we'll add the total story points 1 with, let's say this is total story points 1. For sprint 1, total story point 1. For sprint 2, total story point 2. Here, how do we calculate the velocity after sprint 2? Here, velocity is equal to this TSP 1 plus TSP, total story points completed in sprint 2, divided by 2 will do. Okay, we'll get the average of the total story points. That will become the velocity in the sprint 2. What about in sprint 3? TSP1 plus TSP2 plus TSP3 divided by 3. Average of the story points that are completed so far in the previous sprints. That is what is velocity. After sprint 4, TSP1 plus TSP2 plus TSP3 plus TSP4 by 4 is nothing but the average velocity that the agile team can deliver the work in the earlier sprints. So here you see, now you can understand guys, okay? With the average amount of work, that is the total story points, average of the total story points of the previous sprints, the agile team has completed in the previous sprints, we can estimate, okay, how much work the agile team can do in the future sprints, okay? So this average amount of work, that is the average user story points the agile team has completed in the previous sprints, is known as sprint velocity. And using the sprint velocity estimate, we can estimate how much work the agile team can do in the future sprints. Now with this average out velocity, we can estimate, right, in sprint 5, okay, before the sprint 5 starts, the we can estimate, okay, with the help of this velocity average story points estimate, we can estimate that how much work the agile team can complete in sprint 5, okay, or sprint 6 or sprint 7 and so on. We can estimate that, okay, with this average velocity points, we can estimate the future sprints how much work the agile team can deliver, we can estimate. So the average estimate rate at which the agile team can deliver a sprint is called sprint velocity in simple words, okay? What is sprint velocity? Average estimate rate, that is average estimate story points at which the agile team can deliver a sprint in, is called sprint velocity. What is the use of sprint velocity? Why we have to calculate the sprint velocity, and what is the purpose of calculating the sprint velocity? What is its use? With the help of the sprint velocity, we can predict, okay? Velocity can be used for making predictions, guys, okay? Future predictions. So what we can predict here, we can predict the time that the team will take to complete the remaining work, okay? So we can predict if there is some pending work in the project, how many sprints the agile team will take to complete that work, okay? How many more sprints the agile team will take to complete the work, we can predict. We can predict what features the team can deliver in the upcoming releases, okay? The future sprints, at which sprint level or at which release level, how many number of features can be delivered, okay? We can predict that, okay? That's what is the use of calculating the sprint velocity, guys. We can use sprint velocity as a as a measurement for prediction, okay? We can predict the future work the team, because we know how the team will work, how much work they can do for every sprint, we know. With that measurement, we can predict the future work, right? How much work the team can deliver in the upcoming sprints, we can estimate properly, okay? And we know how much time will it take to complete the remaining work, we'll come to know. That's what is sprint velocity, guys, okay? So hope guys you understood what is velocity in agile scrum from this session. So that's all for this session. The next session I'm going to answer another software testing interview question for you. Till then, see you, bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 105, that is, what is burn down chart? Let me answer. Burn down chart is used by the projects which follow agile scrum methodology. And the purpose of using this burn down chart in such kind of projects is to track the progress of work being done in the sprints. Okay. So if you know any agile scrum methodology projects, the work will be done in the form of sprints. Sprint 1 work, then sprint 2 work, then sprint 3 work, then sprint 4 work, and so on. Okay. The work will happen in the form of sprints. Here we have multiple sprints. Sprint 1, after sprint 1 is completed, after the work assigned to the sprint 1 is completed, then sprint 2 will start. Sprint 2 will start. After sprint 2, work is also completed, then the work will be assigned to sprint 3 and sprint 3 will start. Once the work assigned to sprint 3 is completed, then sprint 4 will start and the process will continue. Okay, the process will continue. For each and every sprint, some user stories will be assigned. Okay, so work will be assigned in the form of user stories to each and every sprint. And the agile team, the sprint team, that is developers and testers, have to complete this assigned requirements or stories by the end of the sprint. This is what happens. But during the sprint, to track the progress, okay, to track the progress of work being done in the sprint by the Scrum team, we have to use burn down chart. Okay, so how does a burn down chart look like? It looks like this, guys. Okay, burn down chart will look something like this. So on the, you see, on the vertical line, vertical axis, you can say, we mention the story points. Okay, these are the story points of the total number of story points of the user stories that got assigned to a particular sprint. If you talk about one sprint, okay, in this sprint, these are the user stories. Let's say for each and every user story, there will be some story points, estimated story points will be there. If you calculate all the story points of these user stories that got assigned to the sprint, okay, for example, if you got 30 story points, okay, for this particular user stories that got assigned to the sprint, if you total all the estimated story points for these user stories, let's assume that you got 30 points. So in that case, in the this vertical axis of this diagram, okay, this bot is a burn down chart case. Okay, in the vertical axis of this burn down chart, you will mention the total number of story points, that is 5, 10, 15, 20, 25, total 30 points are there on. And on the horizontal axis, okay, on the vertical axis you are mentioning the story points, that is total 30 story points got assigned to this sprint. On the horizontal axis, okay, on the horizontal axis you will mention the number of days that the agile team or scrum team has have to complete this user stories that got assigned. To complete this 30 user story points, how many days are there? Okay, how many days the agile team has in the sprint? Okay, for example, the duration of the sprint is, the duration of the sprint generally is 1 to 4 weeks, guys. But assume that for a particular project, the duration of the sprint is 2 weeks. Okay, for a particular project is following the sprint duration, that is sprint iteration duration as 2 weeks. That is nothing but 10 working days. Okay, 10 working days. As an example, we can take the 2 weeks as the duration of the sprint, and it's 10 working days. That 10 working days we will write down here. You see, on the horizontal axis, we'll mention the 10 working days. First day, second day, third day, fourth day, fifth day, and so on till 10 days. Like this, we'll create this burn down chart. And as you can see, guys, there is a green color line here. In this burn down chart, there is a green color line, which is ideal line. Okay, if the team completes the user story points according to the number of days, ideally it has to complete as per this green line. Okay, you see, uh, by the time it reaches which day, let's say this day, third day, the team has to complete around how many points, guys? 8 points need to be completed by this time. Okay, 8 points need to be completed. Starting from 30 to 22 means 30 to 22 means 8 points. Okay, by this time, by 3 days, it has to complete 8 points ideally, like so on. Okay, by 10 days, all the points has to be completed. You see, by the 10 days, what happened? This green line is coming like this. You see, number of story points are reducing and number of days are increasing. By the time it reaches the 10 working days, that is the end of the sprint, all the story points have to be completed ideally. This is how, the as per the green line, the story points has to be completed over a period of time. Okay, over a period of 10 days in this example. Okay, this 30 user story points need to be completed, that is developed and tested by the agile team by the end of this 10 days according to the green line. But does the work happen ideally as shown in the green line? Does the work happen ideally? No, guys, it will not happen in real time. Okay, so the team will be behind sometimes, the team will be ahead sometimes. Okay, you see this color, this red color thing is the actual work being done. Okay, how the story points are completed by the end of this sprint, that is 10 working days. How actually, okay, how the actual work has been done. This ideal work is green color, red color is the actual work done by the team. Okay, some, you see, by the end of the 3 days, let's say for 3 days, guys. Okay, the team has to complete ideally how many points? 8 points. But here, how many points the team has completed? Only it's around like 26 or something. So 24, only 4 points it has completed. Okay, even though ideally the team has to complete 8 points, here the team by the end of the 3 days has completed only 4 points. Okay, it's lagging behind 4 points. Okay, 8 is the expectation, but 4 is actually completed, like that. And if you take another day, you see, after immediately after 3 days, okay, 3.5 days or something, you see the team has to complete around here 20 to 30 means almost it's 9 points it has to complete. But here the team has completed at 3.5 days, the team has completed around more than 10 points. Okay, even though 9 points are there, here 11 points are completed by the team. Sometimes the team will be ahead in the work, so sometimes the team will be in match with the ideal case. Okay, here you see as the fifth day or something, both are on the same direction. Ideal points and completed points are same. Okay, sometimes lagging, sometimes ahead. Okay, but by the end of the sprint, that is in 10 working days, all these 30 user story points have to be completed. So this green color thing is ideal one, and red color thing is the actual work that is being done, how the actual story points are being completed over the number of days. Okay, so with this kind of burn down chart, okay, scrum master will use this kind of burn down chart. Okay, in the agile team, who will generally is will generally use the burndown chart. Who is the main person who will mostly use the burndown chart? Is none other than the Scrum Master. Okay, the Scrum Master is generally the one who will take care of the burndown chart. Okay, he or she who is the Scrum Master will be taking care of the burndown chart. So for what purpose Scrum Master will be using this burndown chart? To track the progress of the work on a particular day. What is the status of the work? How much work is being completed and how much work is expected to be completed? To track that progress, Scrum Master will use that burndown chart. Not only the Scrum Master will use a burndown chart, guys. He will bring this burndown chart. The Scrum Master will bring this burndown chart to the daily stand-up meeting. Okay, so in daily stand-up meeting, the complete agile team, Scrum Master will go through the meeting. Just in 15 minutes, they will wrap up the meeting. In that 15 minutes, the Scrum Master, along with the agile team members, that is developers and testers, will discuss uh, what is the current work going on, how much work is completed, how much work is pending, are we on track, can we complete the things on time. All these kind of things will be discussed by Scrum Master with the agile team in the daily stand-up meeting. That is daily Scrum meetings or daily stand-up meetings. So as part of that meeting, the Scrum Master will also use this kind of burndown chart, okay, to show everyone like what is the current status of the project, what is the current status of the work being done in the particular sprint, okay, how much work they have to complete the this complete story points by the end of the sprint, okay. So all these things will be discussed by Scrum Master with the help of the burndown chart to track the progress of work being done in the sprint. So hope guys you got the answer for what is burndown chart in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 106. That is, what is the difference between regression testing and retesting? Let me answer. So what is the difference between regression testing and retesting? Coming to regression testing, the testing which is performed to make sure that there are no side effects introduced in other working areas of the application due to code changes. So what does this statement mean? Let me explain. For example, guys, there is a application. Okay, let's say this is application. In this application, there are different functionalities like this. In this application, I'm dividing this entire application into multiple blocks like this. So here, each and every block in this particular entire box is nothing but a functionality. For example, this is a login functionality. Okay, this is a logout functionality. This is register account. This is search functionality. Like that, different application functionalities are there. So in this case, you see all these functionalities are working. Let's say, okay, all these application functionalities are working fine. All these application functionalities are working fine. So whatever the tick marks I'm doing, right, all these application functionalities are working, okay, whether it can be login, whether it can be log out, okay, whether it can be search, all these application functionalities are working. But there is one functionality here, as you can see, I didn't tick mark. Let's assume that this functionality, let's say it's a forgot password functionality. This functionality is not working. Okay, there is a problem. So we have reported the defect here. And what do the developers have to do when you report a defect in this functionality? Developers have to fix the defect. Developers have to fix this defect. So after fixing this defect, in order to fix this defect, okay, in order to fix this particular defect related to the forgot password functionality, the in order to fix this defect related to forgot password functionality, where there is a problem, developers have to change the code or not? Developers have to change the code, okay, to fix the defect. Developers have to touch the code of this application so that the defect related to the forgot password functionality will be fixed. So far so good. Let's assume that developers have fixed this particular defect. Developers have fixed this particular defect and the developers have given you a new version of the application for you for testing. So here guys, here because of the code changes happened at this forgot password functionality level, because of the code changes that happened at this forgot password functionality level, there is a possibility that the earlier working functionality, you see there is no problem with the login functionality earlier. Logout functionality, there is no problem earlier. Only forgot password, we reported the defect and developers have fixed that. For that, they have touched the code of the application. Because of the code change that has been done at the forgot password functionality, there is a possibility of side effects getting introduced in other areas of the application. Earlier, login functionality is working fine, but in the new version of the application, login may or may not work. We don't know. We are not sure because Because to fix this particular defect related to forgot password functionality, developers have to change the code. Okay, change the code of this application. Due to the code changes, there is a possibility that the side effects may get introduced in the earlier working functionalities of the application. For example, guys, if I take a real world example, you go to a doctor. Okay, your actual problem is headache. Okay, you went for a headache. So you mentioned to the doctor that doctor, I got a headache. Then doctor has prescribed a medicine for headache, and he asked you to use this particular tablet for 1 week or so, and come to me again. So you went home and you started the course, medical medicine course for headache, for treating your headache, and you started using it. So after 7 days, what happened was whatever the problem was there, that is headache problem, that's gone. But suddenly you got a new problem. Okay, you got stomachache because of using the tablets. You got a stomachache. The actual problem is solved, that is headache is solved, but as a side effect, what you got? Stomachache. Earlier stomach was good for you. Okay, before you went to the doctor, before you went to the doctor for this treating this headache, right? Your The problem is only with the head, but now, earlier at the time, the stomach was good. Okay, here also same thing, right? The problem is forgot password, but earlier login functionality is working fine, logout is working fine, such functionality is working fine, all other functionalities of the application are working fine, only this forgot password, there is a problem. But because of the developers have fixed this code related to forgot password by changing the code. Okay, then what happened? There is a possibility that you may get side effects in the existing or earlier working functionalities of the application. That's the reason what we have to do as software testers. Even though the code change happened to fix this particular defect, we should not believe this code change, because this code change may result in the side effects in other areas of the application. To overcome that problem, we have to perform what? Regression testing. Testing all the other areas of the application to see if there are any side effects introduced because of any code changes in the application is known as regression testing. Just let me read it again. Testing performed to make sure that there are no side effects introduced in the other working areas of the application. All the areas of the application that are working fine, in that working areas of the application, because of the code changes, there may be some side effects introduced. To find out whether there are any side effects introduced in the other working areas of the application due to the code changes done by the developers is known as regression testing. Okay, it is known as regression testing, guys. The code changes may happen due to different reasons. Okay, in this example, the code change here happened because of the fixing the defect. Developer have fixed the defects. In all cases, defect fixing may not be the case for changing the code. Okay, so in some cases, like a new functionality has been introduced and you have written the code because of the new functionality added to this existing application. You see, a new functionality got added to the existing application because of the new functionality added, and developers have to write the code for this, and they have to modify the code. Okay, to integrate this functionality with these other areas, they have to modify the code. In that case, also you will get, there may be side effects, right? In the existing working areas of the application, earlier working areas of the application, the side effects may be introduced because the code has been changed or touched, or any improvements have been made to the application, or any updations have been made to the existing working areas of the application, or whatever it is, guys. Due to any reasons, if the developers have will touch the code, there's a possibility that other areas which are working fine also may get side effects. Okay, to cross check whether there are no side effects introduced in the other working areas of the application due to the code changes because of the defect fixing or new functionalities or updating functionalities, etc., is known as regression testing. Okay, this is what is regression testing, guys. What is retesting then? Retesting is different, guys. Okay, retesting is simply testing the defects that are stated as fixed by developers is called as retesting. So here in this example, the forgot password functionality got a defect, and developer is saying that they have fixed the defect. So as part of retesting, what you have to perform? You have to check whether this defect is really fixed in this latest version of the software or not. Okay, here your job is not to cross check whether there are no side effects in the earlier working functionalities. Here retesting means testing whether the defects that are stated as fixed by developers are really fixed or not. Okay, you're cross checking, the developer is saying that I have solved the problem. Now we have to check whether the problem is really solved by the developer or not. That process is called as retesting. Let's say, guys, you called a plumber to your home because there is a problem with your tap or something, the water is not coming. Okay, there is a problem in the water is not coming from the tap, that is a problem. Okay, so the plumber came and has fixed the problem. Okay, now the plumber says that sir and madam, I have fixed this problem. Okay, sir or madam, I have fixed this problem. Then what you will do, guys, immediately, you will cross check, right, whether you will again open the tap and see whether the water is coming or not. If the water is coming means you will confirm that the problem that you have reported to the developer, in case this in our real world example, that is plumber, is really fixed or not. Okay, this checking is called as retesting, guys. Okay, because of fixing that problem, the tap problem, okay, because of fixing that tap problem, so maybe while fixing the problem, right, plumber may break your glass which is near to your okay, near to your that wash basin or whatever you call, right? Okay, when he is fixing the tap, there is a possibility that plumber may break the glass, okay, which is near to the tap. So that we have to check as part of regression testing, right? Regression testing is performed to check whether there are no side effects introduced in the other working areas of the application due to the code changes done by the developer because of bug fixes and etc. and etc. But retesting is only straightforwardly testing whether the problem is solved or not is called as retesting. Okay, testing whether the defects have been really fixed by developers is called as retesting. So hope guys you got an idea of what is the difference between the regression testing and retesting in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello, welcome to this session. In this session, I'm going to answer software testing interview question 107. That is, what is the difference between sanity testing and retesting? Let me answer. So, what is the difference between sanity testing and retesting? First, I'll start with the retesting. Retesting is nothing but testing the defects that are stated as fixed by developers. Okay. If the developers are saying that they have fixed the defects, okay, they have fixed the defects, as software testers, we have to confirm by checking whether these defects that are stated as fixed by developers are really fixed by them or not. Okay. For example, guys, there is an application. For example, there is an application. I'll break this application into multiple functionalities. Here, I'm breaking this single application into multiple functionalities. Few examples of the functionalities are login functionality, logout functionality, forgot password, search functionality, and so on. Okay, each and every block is a functionality, let's assume. So here, let's say while testing this, all the functionalities of the application, maybe in one of the functionality, let's say forgot password functionality, you got a defect, okay? The software testers have found the defect and they have reported the defect. Once the software testers have reported this particular defect, what the developers will do? Developers have to fix these defects, okay? Fix these defects. Whatever the defects that are reported by software testers, the developers have to fix them. Okay. So now developers are saying that whatever the defect you have reported as part of the forgot password functionality, we have fixed it. Now developers are saying that we have fixed this particular defect. Now what the software testers have to do? Software testers have to do retesting. Okay. Software testers have to do retesting where software testers have to verify whether these defects which are stated as fixed by developers are really fixed by them or not. We have to check. That process is called as, that testing is called as retesting. Testing whether the defects that are stated as fixed by developers are really fixed or not is known as retesting. So as part of retesting, if the defects stated as fixed by developers are fixed, then we'll close the defects. Okay. The result will be, we'll close the defects. As software testers, as part of retesting, we'll close the defects. The defects that are stated as fixed by developers are really fixed by them. If they are confirmed as fixed, then testers will close the defect. If they are not fixed, then the defects will be still open and reassigned back to the developers. Okay, the defects will be reassigned back to the developers for fixing. Okay, if the defects are partially fixed or not at all fixed, so they will not be closed, rather they will be reassigned back to the developers for fixing them. Okay, so this is what is retesting. Now come to the next one, that is sanity testing. So what is sanity testing? Sanity testing is subset of regression testing, guys. Okay, here it is a subset of regression testing. How do you perform sanity testing? Is you will test the functionalities and related functionalities which got affected due to the code changes. Okay, so here for example, guys, while while the developers are fixing this particular defect related to forgot password functionality, okay, as part of fixing this defect, developers have to do the code changes, right? Without changing the code, can they fix the defects? No, right? The code changes will be done. So for which functionality the developers have done the code changes? For forgot password functionality, the code changes are done. So when the code changes are done in this forgot password functionality, in order to fix this particular defect, what happens is we are not sure whether, okay, because the code is modified, right? In this forgot password functionality area, the code is modified. The code is modified means this defect may be fixed, but this functionality may become unstable. Okay, when the code is touched means the developer has changed the code means that reported defect may be fixed by developer. As part of retesting, we can confirm whether the defect status fixed is really fixed or not. That's okay. So after we confirm that the defect fixing is done properly and we have closed the defect also, still there is a confusion or kind of dilemma for us, whether this forgot password functionality, which used to work earlier, apart from this defect, everything was intact. This forgot password functionality, we are not sure whether this forgot password functionality entirely is good or not. Okay, because it may get affected. It may get affected because of the defect fix, because of this code change. This functionality may get affected. So what is alternative? What we have to do? What as software testers we have to do? Apart from retesting this particular defect and confirming that the defect is really fixed or not, after that, after retesting is done, we have to perform sanity testing on this forgot password functionality. We have to perform sanity testing, that is in-depth testing will perform in-depth regression testing. Okay, it's only on the forgot password functionality we are going to test case. Okay, in-depth all the test cases related to the forgot password functionality from start to end will test as part of sanity testing. Not only this forgot password functionality, there may be some situation where there will be some related functionalities for this forgot password functionality. For example, what will be the related functionalities for the forgot password functionality? Login functionality may be related. So we have to perform in-depth testing on the login functionality also, because it is a related. Because of this code chain, the login functionality may get affected. And also we have to test logout functionality here. Okay, logout functionality also may get affected. Logout functionality may get affected. Register account functionality, all the login, logout, register. Okay, this kind of functionalities will get affected. So here testing the functionalities and its related functionalities in depth because of the code changes in that functionalities is known as sanity testing. It is a subset of regression testing. Here you are not performing the entire regression testing. You are not testing the other unrelated functionalities. You are not testing. In sanity testing, it is a subset of regression testing. In regression testing, you have to test all the unrelated functionality also, whether any side effects are introduced in unrelated or unrelated. Everything you have to test as part of regression testing. But in sanity testing, you have to perform regression testing only in the areas only in the areas that is the code changed functionality and its related functionality we have to test in depth. That's why I'm calling that sanity testing is not regression testing. It is a subset of regression testing. Sanity testing is not regression testing. Okay, sanity testing is a subset of regression testing where you will test the functionalities and related functionalities that got affected due to the code changes. Okay, the immediate functionalities or the actual functionality where code changes happen will be tested to see if they are intact even after this code changes happen. Code changes may happen because of different reasons, guys. Okay, here in this example, I mentioned that the code change happened because of the defect fixing, but not always the code changes will happen in this particular forgot password functionality because of the fixing the defect. Some cases, the developers may update the code in this functionality. Okay, they may modify the code, they may improvise the code, whatever it is. Okay, they may improvise the functionality. For that, they will do code changes in one of the functionality, and because of that, the functionality and its related functionality may get affected. And testing these functionalities whether they are intact after these code changes are done on this functionality is known as sanity testing. So hope guys you got an answer for this question now. That is, what is the difference between sanity testing and retesting? So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 108. That is, what is the difference between debugging and unit testing? Let me answer. So what is the difference between debugging and unit testing? Even though both debugging and unit testing are performed by developers, but they are not same. Okay. Coming to debugging, developers perform debugging to investigate the program when the program they are running is not producing correct results or it is producing some errors. Okay, whenever the developers are running some programs, if that programs are producing incorrect results or they are producing some errors, in that case, developers will perform debugging to investigate the problem in the program. That's what is debugging, guys. So for example for this debugging, when the developers will perform debugging, an example, let's say when the developers are running a program, okay, the program is getting terminated abruptly, and in place of that, an exception is coming. Okay, when the developer is running a program, the program is giving an exception and the program is not running entirely. Okay, because of the exception, the program is failing. Okay, terminating abruptly. In that case, developer may not know in which line of the code, okay, in which line of the code there is a problem and why this exception is coming. Developer is unaware of that. So in such kind of case, what the developer will do, developer will debug the code, okay, with an intention of investigating the program to see which line of the code in the program is causing this exception, and because of which the program is terminating abruptly, the developer will try to investigate, and this process of investigating is known as debugging. In case of debugging, guys, developer may put some breakpoints in the code and try to run to see which line. Okay, he'll try to estimate like, okay, maybe this line is causing the exception. Okay, like that he will try to investigate the problem. Okay, which part of the program is causing this exception. In this example I'm talking about, he'll put some breakpoints. He will run the code line by line and try to figure out or find out the line in which the program is causing the exception, and because of that exception, why the program is terminating abruptly. All these things he will investigate. Okay, this step-by-step process of investigating and identifying the problem in the program which is causing the exception as part of this example is nothing but debugging. Okay, it's only one example, guys. So developers will do debugging to investigate the program which when running is not producing the correct results or producing some errors. Okay, to figure out which line of the code is causing the problem, developers will do debugging. Hope debugging is clear for you now. And coming to unit testing is completely different from debugging, guys. Even though unit testing is also performed by developers, it's a first level of software testing, you can say. Okay, unit testing is done by developers, but it is a first level of software testing performed by developers where the entire application code is broken down into smaller units. Okay, for example, if the developers have written this much of code, okay, for this entire application code, let's say, okay, the developers have written this entire application code. In that case, what the developer will do is this entire application code, they will break the code into smaller units. Okay, smaller units, they will break the code. So till what extent they can break the code, right? They will go to that extent. Okay. So these are nothing but units, guys. Here, each and every box I am representing, like after breaking the code to the extent where it can be broken, right? Such kind of things are nothing but unit. Okay, unit one, unit two, and so on. These are smallest pieces of the code which cannot be broken further. Okay. So after this entire application code is broken down into smallest pieces of the code which cannot be broken further. Here, each and every such kind of piece which cannot be broken further is known as a unit. And if the developer is breaking the code, entire code into the smallest units possible and testing these units individually, okay? So testing this particular units, if the developer is testing this particular, whether this unit is working fine or not, this part of the code, this part of the code, this unit of the code is working fine or not, by passing several varieties of inputs, okay? Different possibilities of inputs and different possibilities of outputs. Developers will check for this single piece of unit which cannot be broken further. Such kind of testing is known as unit testing. Okay, it's the first level of software testing performed by developers where the entire application code is broken down into smaller units possible which cannot be broken further. And such kind of testing, such kind of individual and each and every unit is known as individually their testing is known as unit testing. So hope, guys, you got the answer for what is the difference between debugging and unit testing. Even though both this debugging and unit testing are performed by developers, debugging is not same as unit testing. Both are different as explained in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 109. That is, what are other names for white box testing? Let me answer. In white box testing, we can view and access the code while performing testing. Hence, white box testing is given different names like clear box testing because the code that is there inside the application is visible. That is clear box testing. Open box testing, transparent box testing, glass box testing, code based testing, structural testing, comprehensive testing. These are the different names for white box testing. So whatever the name using which you can call, that is nothing but the white box testing. If you call that with comprehensive testing, it's also white box testing. Both are same, guys. Okay, these are the different names for the white box testing. So hope, guys, you got the answer for what are the other names for white box testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 110. That is, what are the other names for black box testing? Let me answer. Black box testing is performed by software testers where the testers won't be able to view or access the code that is written by developers for building the software. There are different names for this black box testing. That is closed box testing, opaque box testing, and also it is also known as behavioral testing. Okay, so black box testing has different names like closed box testing, opaque box testing, and behavioral testing. So hope guys you got the answer for what are the other names for black box testing. That is nothing but closed box, opaque box, behavioral testing. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer software testing interview question 111. That is, what are the different types of white box testing? Let me answer. White box testing at a high level can be categorized into unit testing and integration testing. As we already know, both this unit testing and integration testing are performed by developers. This unit testing can be further categorized into three types, that is execution testing, operation testing, and mutation testing. And this execution testing under unit testing can be further categorized into statement coverage testing, branch coverage testing, and path coverage testing. Okay, so this is the unit testing side. And on the other side, we have at a high level integration testing. These integration testing can be further categorized, or the different approaches followed for performing the integration testing are this one, that is top down integration testing approach. Okay, for performing the integration testing, we follow any of these approaches. That is, the developers will follow any of these approaches like top down integration testing approach, bottom up integration testing approach, and sandwich integration testing approach. So hope guys you understood what are the different types of white box testing. At a high level, they are categorized into unit and integration. Under unit, they are categorized into execution testing, operation, and mutation testing. Under execution, they are categorized into statement coverage, branch coverage, and path coverage testings. Under integration, they are categorized into top down, bottom up, and sandwich integration testing approaches. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 112. That is, what will happen if a defect is found in production? Let me answer. So what as software testers we have to do if we come across or find a defect in production? So let's get started. First of all, before I give an answer for this question that what software testers have to do if they find a defect or bug in the production, first let's understand what is mean by production. Production is nothing but live environment, okay? Production is nothing but a live environment. So that end users can access, okay? This production in simple words is nothing but a live environment, which is nothing but the end users can access the application because of the production. Okay, because of the live environment only end users can access the application. What does it mean? Clearly means, you see, the developers will be developing the code related to the application. So before this particular application is released into the market, that particular developed code of the application will reside in the pre-production environment. Okay, so once the software gets released into the market, how the software gets released into the market, the developer developed application code will be deployed onto the production environment. Okay, from the pre-production environments it will be moved into the production environments, which is nothing but the live environment. Once this application code developed by developers move to the live environment, the end users can access the application. Okay, so once the code is deployed to this live environment, that is production environment, the end users can access the application. That is what is called as production. Okay, so production. So in such kind of cases, while the end users are using the application which is deployed onto the live environment, that is production environment, if a bug or defect is found in that production environment, okay, and the end users, real customers are able to see the defect. You see how serious it is, right? So what we have to do as software testers, okay, if such kind of situation we came across, so before releasing the software into the market, as software testers we have to find all the defects in the software. Okay, but due to some xyz reasons, after the software gets released into the market, after the application developed code developed by the developers and tested by the testers is deployed onto the live environment like production environment where the end users are actually using the application for their purposes, if the defect comes across, then what will be the situation of the software testers, right? It looks like serious there, right? So but the thing here is, due to some xyz reasons it happened. Okay, it's not intentional, so we should not panic guys. Okay, the first thing we have to take care of is we should not panic. Okay, don't panic. instead be calm. Okay, so in that kind of situation, this happens, guys. This happens for a lot of people. Okay, so during their career, right, they have to work on multiple projects. In one of the projects, this may happen where one bug will be missed. Okay, during the testing, you are unable to find the bug, but that bug occurs in the production. Though it is serious, we should not panic. Okay, so if you keep on panic, right, you cannot do anything else. Okay, in that situations, right, you will be you cannot control your fear, and right, things will go even more wrong. Okay, so instead of doing that, let's not panic. Okay, so let's face the situation instead of being panic. So let's make ourselves calm. Okay, as software testers, we should become more calm than, okay, instead of becoming panic. Okay, so next thing is, so in that panic, what will happen if you don't control the panic, and if you don't be calm, what happens is you will start the blame game automatically, right? So anyone, how people will encounter the fear. So once they get the fear, and they get panic and simply say that, okay, I'm not the one, I am not the one, that person, this person, okay, this is because of him, this is because of her, like that you keep on blaming others out of the panic. So if you don't panic and if you're calm, then you will not play the blame game. Okay, so that's what happens. That's why I'm saying we should not panic, and we should be calm instead, and we should not play the blame game and putting the problem, okay, who caused the problem, on the name of others. Okay, that's not a good thing. Let's not play the blame game. Okay, or don't start the blame game. Be calm, don't panic. This is very important. Now, so if you are calm and if you are not playing the blame game, and you are not in a position of panic, okay, you controlled your panic thing or whatever the fears and all by being calm, and you're not starting any blame game and all. In that situations, what are the steps you have to follow? I'm going to show you. Okay, the different steps that you have to follow to tackle this problem. Okay, by being calm. Thing is, first we have to understand the bug. Okay, so which bug? Okay, which bug is in the production, we have to understand it in and out. Okay, so that's what is the first step as software testers we have to do. Then we have to check whether the bug is reproducing in production environment. Okay, is it really coming or not? Okay, so someone is saying that the bug is there in the production. Okay, some customer has reported that problem or whatever it is. So that information you first understand it. Okay, what the bug they are actually speaking about. Just first try to understand, and then try to reproduce the same bug. Okay, because they are simply stating, but is it really there in the production or not? We as software testers have to find it out. Okay, so we have to check whether the bug is reproducing the production environment or not. We have to check. Okay, that is the second thing. So once we confirm that the bug is once we understand the bug, and once we confirm that the bug is reproducing in the production environment, then if the bug is really reproducing, okay, once we confirm that the bug is reproducing, then we have to report the defect, right? Then we have to report the defect. Okay, so we have to report the defect. Even though it is in a production environment, we have to report the defects in our defect tracking tools or test management tools like Jira or whatever that you are using at your workplace. Okay, you have to report the defect. Okay, that has come in the production environment there. And now next thing is investigation. Okay, so some crime happened. Let's go into the real world, guys. If a crime happens, what the police will do? They will do the investigation, right? How did it happen? Okay, what are the situations that has driven to this kind of crime or whatever? They will start investigating. Similarly, if a bug is found in the production, okay, after you confirm that it is reproducing, really coming in the production, and after you report the defect, you have to identify. Okay, so you have to identify how it is missed. Okay, before identifying how it is missed, guys, after you report the defect, I missed one step here. You have to inform the stakeholders. Okay, stakeholders means what? Nothing but, okay, other people in the team. That's it. Okay, it can be a project manager or anyone who is working on the project that you have to. Okay, so those people will say as stakeholders. We say them as stakeholders. Okay, the required, okay, the required people that we have to showcase this problem to. Okay, once you report the defect, and once you confirm that the bug is reproducing the production, and after you understand, you have to inform the stakeholders about this defect. Okay, the people who don't know about this bug in the production, right, you have to inform them. Okay, so all the people who are working the project, right, whoever has this particular communication has to be communicated to regarding the bug in the production. Those you can call them as stakeholders now. Okay, all those other people who need to be communicated, stakeholders, other people in the project are stakeholders. Okay, so about this particular bug in the production, you have to inform them. Then you have to identify how it is missed. Okay, so parallelly you can identify how it is missed. Okay, so what caused this? What caused the software testers to skip to miss this particular defect? Okay, before the software gets released in the market, that investigation we have to do. Okay, So verify, we have to go through all the test cases that we have executed and see like is because of the ineffective test cases or something. We have to identify the root cause, guys. Okay, what is the actual problem? Why the bug has been missed by software testers, or the test case related to this bug is not there, or maybe the bug is only coming in special conditions. We don't know. Okay, or any other setting changes happened because of which the bug has come. Whatever the case is, guys. Okay, so why that defect or bug has been missed before releasing the software into the market, or before the application became live and accessible to the end users, that we have to identify. Okay, we have to find out, verify the test cases, verify the things and all, and come to a conclusion. Okay, why the defect has been missed. Now, finally, after all these steps, the important step is we have to get the defect fixed, right? So the defect is there in the production, and we don't know like what impact it is doing on the application while the end users are using the application. Okay, so the the thing, that only solution that is left with the software testers is to get this particular defect or bug fixed by the developers. How? How means, for that, guys, the software testers have to first perform root cause analysis along with the developers. Okay, software testers, along with the help of the developers, have to perform root cause analysis. Why the defect has? What is the root cause of the defect? Okay, because of which reason the defect is coming, they have to find. And also, not only that, guys, the software testers have to identify the risks involved. Okay, if the this particular defect is not fixed, what is the possible risk, and what are the impact areas of the bug? Okay, what are the impact areas of the bug? They have to identify. Okay, the risk and impact areas of the bug because of the bug in the production. What are the consequences? We have to identify. Okay, apart from performing the root cause analysis, why the defect has been defect actually occurred. Okay, that is what is what is the reason behind the root defect. Okay, that is the root cause analysis. After that, what will happen if the defect is not fixed, and what are the areas that are going to be impacted? Are we going to lose this business, or whatever it is? We have to identify that. Okay, then based on this root cause analysis and identified risks and impact areas, right, then we have to plan for getting this particular defect fixed by the developers. Okay, the software testers have to work on getting this particular defect fixed by developers, and that too based on the priority and severity of the defect, guys. Okay, because not all defects in the production are serious. Some defects are serious, some defects are minor, you can ignore also. Okay, so it should not be very serious. If a minor defect comes in the production, you should not be taking a very big action there. Okay, so all our work, getting these defects fixed or whatever, should be, all these activities should be based on priority and severity of the defects. Okay, so let's say, guys, let's say take an example where you got a very minor defect, and because you thought that that minor defect also should not be there in the production, that is not causing that much business impact to the users. Okay, it can be ignored and can be fixed later. Okay, even though that minor defect is there, it's not causing much problem. In that cases, if you still try to fix that minor defect, what will happen? Because here the application is live. If the developer touches the code, what will happen? The side effects may come in the other working areas of the application, and more more big or more serious defects may come in the application. Okay, that too in the live. That's the problem, guys. So we have to take our decisions very carefully here based on the priority and severity of the defects only. We have to take a decision of whether to get this particular defect fixed by developers or not. We have to make a decision. Okay, so, and also, if this particular defect that is there in the production, if it has to be really fixed by the developers, we have to make sure that there is less impact to the end users. Okay, the end users should not face any heat because of our fixing of the defect. All these decisions we have to take, guys. Okay, so after fixing the defect and after rolling out the code changes because of the defect fixing onto the production environment. Okay, so because of the defect fix, things should not go wrong. Okay, so we have to make sure that, okay, we have to make sure that there is less impact to the end users. Okay, it should not affect our bug fixes or code changes should not affect the end users. Okay, while using the application. With that note, guys, I'll show you some different types of things that developers will do, okay, to fix the defect when a particular defects comes in production, right? Developers may do any of these three things. Okay, they may fix the defect in the form of a patch, or they may fix the defect in the production environment with the, maybe in the form of a hot fix, or they may fix the defect in the production environment in the form of a cold fix. Okay, it can be anything. Coming to the patch, guys. Okay, what is patch means? You just understand the difference between patch. When the developers will go for a patch fix, when the developers will go for a hard fix of the defect, when the developers will go for a cold fix of the defect in the production. Okay, you have to depending on different circumstances, they will take a decision. Patch means whenever they feel that this particular fix has to be done in a temporary way, just for no purpose, okay, not for long term. Maybe after in the next iteration or next release, right, they'll plan a better fix. But for now, they want to temporarily fix it, okay, just to overcome the problem. They will do some small fix, okay. So these bugs which doesn't need immediate attention, okay, when this kind of situation will be coming, when the developers will go for a patch that is a temporary fix, when the bugs which don't need immediate attention, okay, when the bugs are coming in the production which doesn't need immediate attention, they can be ignored for now and can be rectified later, okay. In such kind of cases, so you can do a temporary fix, okay. Developers can do a temporary fix, and here schedule fixes to avoid the system downtime, okay. So a proper schedule, guys, so it not be done. These fixes will be done on live, okay. So but the thing is, there will be some timeline, okay. At this point of time, I'll schedule maybe in the night when users doesn't use that, I'll fix it, okay. Schedule fixes to avoid the system downtime, because if these fixes are done during the when the end users are using the application, there is a possibility that because of these bug fixes, or because of this patch thing or whatever the temporary fix, the application may go down, okay. So when patches are like schedule fixes, guys, to avoid the system downtime, okay. Their scheduled means time to time, okay. So at a fixed time they will be scheduled, okay. So the fixes will happen. And second one is a hot fix, guys, okay. Hot fix is like immediate urgent fix, okay. So the severity and priority is a showstopper or whatever it is, okay. It's a very important defect, and we have to fix it ASAP, okay. Otherwise we'll get a lot of problem from the end users, okay. Our company will lose a lot of reputation. Such kind of situation occurs, then hot fix will happen, where immediate live fixes, guys, okay. Immediately developers will do the fix there itself, and here without zero or minimum downtime. And while doing this immediate fix, right, urgent fix, right, developers will make sure that there is zero or minimum downtime of the application, okay. So they will try their level best that application system may not go down, okay, should not go down. They'll try their level best. If in rare cases, right, they will make sure that system will be up in just minutes or something, okay. So minimum downtime, they have to do the fix, okay. And that too, the fix will happen on the live environment, okay. While the application is live, while the end users are using, only the fixing will happen, okay. So cold fix, coming to the cold fix, guys, here have to take the system down to fix, okay. So here in the case of hard fix, the system is not gone down, but in the case of cold fix, the system will go down, guys, okay. How in order to fix this, the system has to be restarted or whatever it is, okay. The hardware has to be restarted or system has to be restarted, otherwise the fix will not happen. It's also a live fix, guys, okay. It's also a live fix. While the end users are using the application only, we'll take the system down and fix the problem, fix the defect, okay. Fix the defect that is coming in the production during the live only when the end users are using. And for this fixing, right, in the cold fix, as part of cold fix, the system has to go down. It's a planned fix, guys, okay. It's a planned fix. It's not an urgent fix, but it's a planned fix where users will be informed in advance, okay, about the downtime. So users will be informed that at so and so time we are doing some maintenance of the application, and the system may not be accessible for you for 1 or 2 hours. Like that, they'll put an email to all the end users, and then they'll do the fixing. Okay, these kind of things we generally get right while using different applications in day-to-day life. Okay, same thing. The purpose is cold fix, guys. Okay. So these are the different ways in which, okay, different type for fixes in which the developers will fix the defect based on the priority and severity of that defect, and based on the situations, okay. So fine. So hope, guys, you understood what will happen if a defect is found in the production. This is what happens, okay. This is what happens, guys, as I explained in this mind map. These are the different things that you will come across, okay. So the environment will be like this, okay, at the time when the defect is found in the production, right. Things will be a bit harsh, but still we should be very cool, and we should follow the things that we have to follow, so that we can rectify the defect and go in the direction of patches, hot fixes and cold fixes, okay. Despite of the pressure, we should be calm, and we should not play any blame game, and we should be able to identify the things and then get this particular defects fixed properly, okay. So hope, guys, you got the answer for this question. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 113. That is, what is the difference between integration testing and system testing? Let me answer. So what is the difference between the integration testing and system testing? Both this integration testing and system testing falls into the levels of software testing. While integration testing is the second level of software testing, which comes after unit testing. Unit testing is the first level of software testing. After unit testing is performed, we'll go to the second level of software testing, that is integration testing. And this integration testing is performed by developers. It is performed by developers, and there are different approaches that the developers will follow while performing the integration testing. Okay, that is top-down integration testing approach, bottom-up integration testing approach, sandwich integration testing approach, and big bang integration testing approach. So this is what is the integration testing, which is the second level of software testing, which comes after the unit testing. And in this integration testing, different units, okay, in case of unit testing, individual units are tested, okay, individual units, okay, independently, the different units are tested, unit pieces of the code which cannot be broken further are tested. But here in the integration testing, those individually or independently tested units will be integrated together, that is grouped logically together and tested as a group. Okay, that is what is integration testing. So it falls into the white box testing category. Okay, it falls into the white box testing category where developers can see and access the code, okay, that they are testing. As part of unit testing is also white box testing category, and also integration also same thing. So here different units will be integrated, that is grouped logically together and tested to see whether they are working together properly or not. Okay, whether the communication between the different units is happening properly, and also as a group these units are working properly or not. That is what is integration testing. Just to conclude, now coming to the system testing, guys. System testing is third level of software testing, which comes after the integration testing. Okay, after the second level of software testing, that is integration testing, is performed. Now third level of software testing will be performed, that is system testing. Who will be performing this system testing? Software testers will be performing this system testing. And here application is tested as a whole. Okay, developers will be giving you in case of web applications, developers will be giving you an URL. Using the URL, you can access the entire application. Okay, and you will be testing the entire application as a whole. For example, here once the developers have built an application, web application like tutorialsninja.com/demo, this particular URL, the developers will give to you as part of testing, and the software testers will start the system testing as a third level of software testing, where they will test this entire application using the URL of the application. They will test the entire application, and using the user interface and all, they will perform different types of software testing here. Okay, different type of software testings will be performed as part of system testing. Here application will be tested as a whole. So in case of web application, developers will give you the application URL. In case of desktop application, they'll give you an exe file and so on. Okay, in case of mobile applications, based on the mobile OS, they'll give you different extensions like APK in case of Android and all those stuff. Okay, so this is what is system testing, and it is performed by testers. And simple word, system testing is nothing but testing the application as a whole, as a complete thing. We have to test the application. You see here, entire application is given for testing. As a whole, we have to perform testing. So this is what is system testing. So hope guys you got the difference between, you understood the difference between integration testing and system testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 114. That is, what is hotfix? Let me answer. So hotfix is performed by developers on production, that is the live application which is already released into the market and being used by the end users or real customers for their daily needs. That's what is hotfix. What are the situations which will make or force developers to perform hotfix on this production, that is live application? There may be some situations where while this live application that is already released in the market, when it is being used by the end users, that is real customers, and these real customers or end users are facing major, critical and blocker severity kind of issues which are hindering their usage of the application. Okay, it's causing a lot of problems to the end users or customers while using the application. Okay, this live application, when the end users and real customers are using for their daily needs, they are facing a lot of problems. Okay, are unable to perform whatever they want to perform. Okay, the application is not allowing them to perform whatever they have to perform as per their daily needs. In such kind of cases, the hotfix will be performed on the production, that is live application which is released into the market. Okay, so hotfix will not be performed if the kind of issues that are identified in the application, that is live application, when being used by end user customers, when those kind of issues are low priority and low severity. Okay, low severity, low priority issues will not be rectified. Okay, are fixed by developers as part of hotfix on the live application. But hotfix will be only done by the developers on the production, that is live application, when the type of the defects, okay, are high severity and high priority defects only. So, and in simple words, hotfix is nothing but urgent fix. Okay, quickly the developers have to fix when the end users cannot wait for the next release, because the high priority and high severity defects are hindering the usage of the application, right? The end users are unable to use the application properly because of this high severity and high priority defects, which fall into the major critical and blocker categories. Okay, such kind of defects need to be fixed urgently, quickly, right, by the developers. End users cannot wait for the next major release. In the current release only, on the current release only, this hotfix has to be performed so that the problems will be resolved for the end users. Okay, that's what is the hotfix, guys. So when end users cannot wait for the next release for this particular fixes to happen for the identified defects which is causing the hindering of the usage of the application by them as per their daily needs, then hotfix is done in an urgent fashion, urgent way. Okay, quickly it will be done by developers on the live application. So what are the different steps that are followed while the developers are performing the hotfix on the production is, first, the defect, okay, that is stated by the customers or end users while using the application will be understood properly. Okay, what is the actual problem that the customers are facing while using the this live application? Okay, that's what the team will understand. Okay, the project team will understand. Then that particular defect will be reported into the tool. Whatever the understood defect, right, which is causing the problem to the end users or customers while using the live application, right? That defect will be reported into the tool. It can be any tool, guys. Some projects will be using the defect tracking tools, okay? Specialized defect tracking tools, or some projects will be using the test management tools where defect tracking is also part of that kind of test management tools like Jira and so on, okay? So wherever it is possible, the team will report the defect, okay? Then the defect will be fixed by developers with zero or minimum downtime. Why? Why zero or minimum downtime? Downtime? Because here this particular application is a live application which is being used by end users or customers, right? While the application is being used, if you take the application down, what will happen? It will be a more problematic for the end users, right? The end users are using the application. Application is on live, and if you are taking it down means end users or real customers cannot access the application. So in case of hotfix, the developers will make sure that the fix will happen. Fix of this particular defect, the major or high priority or high severe defect will happen with zero or minimum downtime. Okay, without causing the system to go down, they will do the operation. They will do the fix. And once the hotfix is performed by developers, this particular code change will not be directly released into the market as it is. Okay, software testers have to perform testing and confirm that okay, this particular defect has been really fixed, and also it's not impacting the other areas of the application. Okay, they have to do some regression testing and all to make sure that the fix happened properly and kind of okay. Then finally it the code will be released into the release. Okay, the code will be released into the market. The hotfix will be the code changes happened as part of hotfix will be implemented into the actual code and released into the market, so that the end users or customers will resolve these problems and can use the application for their day-to-day needs without any problems. So this is what is the hotfix, guys. In simple words, just to conclude, hotfix is nothing but the urgent fix or quick fix that has to be done as soon as possible, because end users are facing a lot of problems while using the application. Okay, so unable to use the application properly because of this high severity high priority defect that is identified while using the application by the end users. Okay, so this is what is hotfix. So hope guys you understood what exactly is hotfix in this session. So that's all for this session. The next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 115. That is, what are the various contents of test plan? Let me answer. Test plan contains several contents like overview, scope. Scope can be further classified into inclusions and exclusions. Inclusion stands for in-scope functionalities. Exclusions of scope stands for out of scope functionalities. Okay. Then we have test environments, test strategy, roles and responsibilities, test schedule, test deliverables, pricing which is optional, entry and exit criteria for the different phases of SDLC, that is requirement analysis phase, test planning phase, test designing phase, test execution phase, and test closure phase. Then we have suspension and resumption criteria, then list of tools, risks and mitigations, approvals. Okay, these are the different contents of a test plan. Here we have an example of a test plan which contains all the above listed contents. Okay, that is from overview to approvals. Okay, let me show you this example now. So I'll open this test plan document here, which is a sample test plan document which contains all the just now listed down contents of a test plan. Okay, so here is a sample test plan document, guys, that you can see. So if you download in your machine, it will be good. But at this moment, I am opening in the Google Drive. Okay, so Google Docs, so it may not be visible properly, but that's fine. Okay, here you see, here is mentioned. This is a one sample, guys. Okay, different templates will be there. This is one of the template test plan for this application, sample application. So here, first section we have first content we have as part of the test plan document is overview, okay, which describes about this particular test plan. Then we have scope, which is further classified into in scope and out of scope, okay, inclusions and exclusion functionalities. So after overview and scope, we have test environments, the list of environments in which the testing team is going to perform testing as part of this project. Okay. Third one is test environments. Then we have test strategy. Okay. The strategy you are going to follow for testing. Then after test strategy, you have these roles and responsibilities, different people and what are their roles and regulations in this project. Okay. Responsibilities in this project. Then we have schedule, at what time we are going to do what. Okay. Then we have test deliverables. What are the different things that we are going to deliver as part of this project? Then we have pricing, which is optional, guys. Then we have entry and exit criteria for each and every phase of SDLC, that is requirement analysis phase, entry and exit criteria. Okay, test planning phase, entry and exit criteria. Test designing phase, entry and exit criteria. Test execution, entry and exit criteria. Test closure, entry and exit criteria. Then we have suspension and resumption criteria. Based on the client decision, we will do the suspension and resumption criteria. Then next one is tools, list of tools that we are going to use as part of this project. Then we have risks and mitigations. What are the probable risks and what are the mitigation plans? Okay, that we are going to implement when this kind of risk really occur. Okay, then approvals, the what is approval process between the client and the project team. Okay, so these are the different contents of a test plan document, that is overview, scope, test environments, test strategy, roles and responsibilities, test schedule, test deliverables, pricing, which is optional, entry and exit criteria for each and every phase of SDLC, suspension and resolution criteria, tools, risk and mitigations, and approvals. So hope, guys, you got the answer for this question, that is what are the various contents of a test plan. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 116. That is, what is prototyping? Let me answer. Prototyping is nothing but developing a working replication which mimics the actual software that needs to be engineered. That means the way before the actual software that needs to be developed is really developed, the development team will create a working replication which is not a real one, okay, which is not a real or actual software. It's a dummy software which looks similar to the actual software that need to be developed in the coming days. Okay, so why such kind of prototype is created by or developed by the development team? The advantage of creating a prototype before the actual software is developed is to collect the feedback. Okay, it promotes early feedback. So by creating this kind of prototype, which generally takes very less time, okay, but if you want to create or develop the actual software, it takes a lot of time. Okay, it takes months, years, and all. But to develop a prototype which looks or mimics the actual software that need to be developed, the prototype just take very less amount of time, 1 day or 1 week max. Okay, not more than that. That prototype will be shared with the customers, okay, who can give you the feedback. After using that prototype, the customers can give a feedback. Okay, this is what they want or this is what they don't want. Based on that feedback, received feedback, okay, so the development team will work in the correct direction. Okay, they may not end up in building a wrong product. So by taking the feedback early, the development team will work in the correct direction of building a correct software, right software. Okay, so that's what is the advantage, guys, of prototyping. So this prototyping concept is actually followed in one of the SDLC models. Okay, there are several SDLC models like waterfall model, prototyping model, incremental iterative model, spiral model, V model, agile model, RAD model, Big Bang model. So here is a prototyping model where this concept is followed. The way before the actual software is developed, which generally takes time, the development team inside this prototyping model, okay, if a particular project is following this prototyping model as part of software development and all, okay, so the development team will create a replica which simulates the actual software that needs to be developed way before to collect the early feedback from the customers or clients. Okay. So prototyping model falls into this category of prototyping. So hope guys you got the answer for what is prototyping in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 117. That is, what are the different types of prototypes? Let me answer. Before I explain the different types of prototypes, let's first understand what exactly is prototype. Prototype is nothing but developing a working replication which mimics the actual software that needs to be engineered or developed. Okay, the way before the developers develop this actual software as per the requirements and all, the developers have to create an actual software and release into the market, right? So before that actual software is developed by developers, the development team will develop a working replication, a working simulation, which is not the real one. It's not a real or actual software, it's a dummy one. Okay, it's a dummy one created way before the actual one is created. What is the purpose? Why the developers have to create this working replication or working simulation of a real software before the real software is getting developed, which will take a lot of time? The advantage or purpose here is to create the prototype is to get the early feedback from customers. Okay, customers cannot wait for the complete software to be developed till the end of the SDLC phases or whatever it is, that customers cannot wait. And also by the time the customers wait and give the feedback, that will be too late. So to overcome that problem, developers will create a dummy, okay, dummy replica. It's a replica or simulation kind of the actual software, which will generally take very less time for the developers to create this guys. Okay, for the developers to create a actual software, it will take a lot of time. But for creating a replica or a dummy simulation thing which looks similar to the actual software, it generally takes less time for the developers. So such kind of prototype will be created by the developers and will be shared with the customers in the early stages of the projects, and the customers will give you the feedback. So once the developers will get a early feedback, now based on the feedback, the development team and the project team will go in a proper direction. Okay, they know where they are heading to, whether they are creating a proper software or not, they'll come to know. Okay, so that is what is the advantage of the early feedback is. Okay, that's what is a prototype and the purpose of the prototype and advantage of the prototype. But there are different types of prototypes that are generally created throughout the projects. What are the different type of prototypes available? We have rapid throwaway prototype as one type. Then we have incremental prototype, extreme prototype, and evolutionary prototype. What are these different prototypes? Let me explain. Coming to the rapid throwaway prototype is, so when it will be created and what exactly it means, I'll explain now. So coming to the first type of prototype, that is rapid throwaway prototype. So this prototype is generally created in the projects for exploring the ideas and getting feedback on customers about finalizing the requirements. Okay, it's all about requirements, guys. Okay, so you see in the beginning of the project, the team will the client side people will ideate about the requirements, right? So what requirements need to be finalized for the software and all, but visually they cannot imagine like what the software will be built out of that. Okay, it will be purely in the form of textual representation, mostly in the presentation format or whatever it is, but they cannot visualize the actual software and they cannot derive the proper requirements or they cannot derive the proper ideas for the software. To overcome that problem, okay, to overcome the problem at the initial stage, when the project is they're in the initial stage while they are finalizing the requirements, right? They will create this kind of prototype known as rapid throwaway prototype. So with the help of the prototype, the team will, okay, ideate about the requirements. Okay, ideate about the requirements and get quick feedback on the requirements whatever they have gathered so far. Okay, so that is rapid throwaway prototype. As the name speaks, as the name speaks, these prototypes are not accepted. Okay, the whatever the during this process of finalizing a prototype, the team will create a lot of prototypes, and if the prototype is not accepted, that will be thrown away rapidly, very quickly. They will reject the prototype, and the next prototypes will be evaluated until their prototype is finalized. Quickly they keep on creating the prototypes and kind of thing. Okay, so until the prototypes are accepted, they keep on thrown away. The not accepted prototypes will be thrown away rapidly. Okay, that's why the name is rapid throwaway prototype, and it's all about finalizing the requirements. Okay, it's all about during the ideation phase of the requirements, where quick feedback can be received and by the customers, and they can finalize the requirements. Okay, that's what is the purpose of this prototype. And now we have the second type of prototype, that is incremental prototype. So in this incremental prototype, what strategy will be followed is, so you see, if you talk about a entire application, guys, an entire application will contain a lot of components, right? Different areas of the application will be, different components of the application will be there. So for each and every component, a separate small prototype, instead of creating a large single prototype, what the team will do is, they will, for each and every component of the application, they will create a separate small prototype. Okay, till the end of the project, while the project is going on, they keep on creating small prototypes for smaller sections of the application. And finally, and when time comes, when all the prototypes, smaller prototypes of the application are ready for each and individual components of the application, all the smaller prototypes will be merged into a single prototype, single final prototype at the end. So finally the final prototype will appear at the end, but initially the small prototypes will be created, and finally they will be merged into the final prototype at the end. Okay, so what is the advantage here? Why to follow this kind of incremental prototype approach here, guys? So by creating the small prototypes for individual components of the application, the customers, okay, will get proper feedback from the customers. Okay, customers get an opportunity to provide feedback on individual developed components instead of providing the feedback at a high level. Okay, now customers can look into the smaller prototypes and give the feedback respect to the application functionalities, or respect to the developed components, they can give the feedback. Okay, so that's what is the advantage of incremental prototype, guys. Okay, so instead of giving the feedback at a higher level, the customers can now give the feedback at the component level. Okay, component level, and this collective feedback will be more powerful than the higher level feedback that is given on the higher level prototype. Okay, that's why incremental prototype model is approached, followed in some projects. Okay, for getting this kind of advantages. Now extreme prototype, coming to the extreme prototype, the extreme prototype mainly contain three phases. Okay, when you talk about extreme prototype, this extreme prototype contain three phases. So that is first phase, second phase, and third phase. In the first phase, what will be created is a prototype will be created, but how it will be created, you see. First, in the first phase of this extreme prototype model, prototype using static pages in HTML format is created. Okay, it's not a real application, but static pages, okay, which are not dynamic. Okay, static pages will be created using the HTML pages. Okay, HTML code will be written for creating such kind of static pages, and these static pages, right? This set of static pages will act like a prototype. Okay, which is not real one. Okay, not real working of the application. It's a prototype having the static pages, very static pages, and just having a feel of okay, how the prototype will. That is the first phase only. The second phase, what they will do is, they will simulate the data process. Okay, they will make sure the to this static web pages prototype, they will add they will simulate the data process, so that customers can even use this prototype to enter the credentials. Let's assume earlier in the first phase, they created a static page for login, username, password, and login button is there. The second phase, they will add the data. Okay, so they will append they will simulate the data processing. Like they will give some the team who is creating the prototype will give you some data. So that data, if you enter into the static pages, that will be accepted. Okay, so only that particular data will be accepted. So mimicking some data process will be done at the okay, at the second phase. You see, simulate data process using the above prototype service layer. Okay, the team will use the service layer of the static pages to this earlier prototype, and they'll make that this particular static pages prototype will accept some kind of data. Now coming to the third phase, guys. Okay, coming to the third phase, now they will add all the code. Okay, all the services, real services will be added to this finalized prototype, and this kind of adding will help the developers in going towards the actual web development. Okay, so this is the third phase of prototype. So this is called as extreme prototype, which will go to the extreme levels like this. Okay, first will be very static pages, then data will be accepted, then actual code will be actual service code. Okay, server side services code will be appended to this prototype, so that this will lead to the proper development. Okay, so this is what is extreme prototyping. Now finally we have the last one, evolutionary prototype. You see, the name evolutionary means it will get evolved over a period of time, right? Evolutionary means any in real world, evolutionary means it will evolve over a period of time. So this prototype will evolve over a period of time. Okay, during the project, the beginning of the project, the prototype will be in some state, and while the project continues, it keeps on evolving. Okay, keeps on improving itself. Okay, incrementally it will evolve. Okay, over a period of time, and it will keep on collecting the feedback. This particular prototype will keep on collecting the feedback from customers every time, every increment. Okay, so until it reaches a final stage, it keeps on evolving. Okay, useful when the requirements are not clear or not understood in the initial stages. Okay, the requirements of for developing the software are not clear or not specific in the beginning of the phases. So such kind of teams use this evolving kind of prototype, where they keep on collecting the feedback from the customers, so that they know what exactly need to be developed. Okay, for such kind of cases, evolutionary prototype is required for such kind of projects. So hope guys you understood the different type of prototypes and what exactly is prototype and what are the different type of prototypes, like rapid throwaway prototype, incremental prototype, extreme prototype, and evolutionary prototype in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 118. That is, what are the different SDLC phases? Let me answer. SDLC stands for Software Development Lifecycle, and in this SDLC, there are several phases. So what are the different phases we have in this software development lifecycle, that is SDLC? The different phases we have are requirements gathering and analysis, which is the first phase of SDLC. Okay, the first phase of SDLC is requirements gathering and analysis. Followed by this phase, we have design phase, and followed by that, we have the third phase, that is implementation phase. Then we have the testing phase. Then followed by that, we have deployment, and finally we have the maintenance phase. These are the different phases of SDLC. Coming to the first phase of SDLC, requirements gathering and analysis. In this phase, the requirements will be gathered. Okay, as the name speaks, the required requirements using which the software has to be developed and tested will be gathered in this phase. So requirements will be gathered and also analyzed. Okay, in this phase itself, the gathered requirements are going to be analyzed. As part of requirements gathering, the business analyst will create a BRS document. Okay, a BRS document, business requirement specifications document, will be created by the business analyst as part of requirements gathering. And as part of analysis, the technical team, using this BRS document given by the business analyst, the technical team will prepare something known as SRS, software requirement specifications document, will be created. So the outcome of this requirements gathering and analysis phase is BRS and SRS. Okay, BRS will be created by business analyst, whereas SRS will be created by the technical team. And followed by the requirements gathering and analysis phase, followed by this phase, we have the design phase. Okay, in this design phase, the technical team, okay, that is a development team or technical team, whatever you call, will come up with the low level designs and high level designs. Okay, the technical team will come up with the low level and high level. Low level means architecture kind of designs. Okay, so internally how the system should work, how the things should be integrated, that is low level designs. Okay, high level designs means the look and feel of the application, the design screens. Okay, which look like the real application screens, right? How the application should look like after developing, such kind of high level designs. Okay, internal designs will be low level designs, and the external designs, how the application should look like, which color combination and all, while you are using the application, how should you feel, all those things will be part of the high level designs. Okay, so after the design phase is completed, after this low level and high level designs are ready, then we'll move on to the implementation phase. Implementation phase is nothing but the coding phase, which is generally performed by the developers. Okay, so it's here as part of the implementation phase, the code required for developing the application will be developed by the developers in this phase. Okay, the developers will be developing the code based on these requirements and designs. Okay, developers will be using the requirements and designs, this BRS, SRS, and design documents they will use and write the code for developing the application as part of the implementation phase. Once the development of the application is completed, then testing phase will start. Okay, the next phase we have is the testing phase. In testing phase, the software testers will be performing the testing on the developed application functionalities. Okay, developed application will be tested by the software testers in this phase. So, and once the testing is completed, okay, once the testing, here software testers will use this BRS document to cross check whether the developers have developed the application according to the specified requirements or not, according to the specified low level and high level designs or not. The testing team will actually check here, and if they are satisfied, then they will approve the testing. Okay, they will okay, finalize the build or whatever it is. And finally, the situation comes where the application becomes stable and the application is confirmed as developed according to the requirements and user needs and expectations by the testing team. Then we'll go on to the next phase, that is a deployment phase. Here, as part of the deployment phase, the developed application which is developed by the developers and tested by the testers and approved the quality, right? Such kind of application will be released into the market, okay? Deployed into the market. Developed and tested application will be released into the market in this deployment phase, guys. Okay, so this is what is the deployment phase. And once the application is developed and tested and deployed into the market, that is released into the market, it's not the end of the story of any software. Okay, so if you see any examples like amazon.com or flipkart.com, they keep on evolving. Okay, if you see, go and see like how the flipkart.com or amazon.com looks in 2008 year or 2015 year or whatever it is. Now as per today's date, it is 2022. So the way it looks now is different from the way it looks in the olden days. Okay, so you see the release of that amazon or flipkart.com happened very long back, but still it's not the end of the software, right? So a lot of new features keep on adding to the existing software, and it will run in a maintenance mode. Once the deployment is done, it's not the end of the software, guys. So the software will go into the maintenance phase, and new functionalities will be added to the existing software. Then the existing functionalities of the software will be modified, unnecessary functionalities will be removed, and so on will happen. So all these things will happen as part of the maintenance phase, and the software keeps on evolving over a period of time as part of the maintenance phase. So guys, these are the several phases of SDLC, that is requirements gathering and analysis, design phase, implementation phase, that is coding phase, then testing phase, deployment and maintenance phase. So hope guys you got the answer for what are the different SDLC phases. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 119. That is, what kind of reviews are conducted during SDLC, that is software development lifecycle? Let me answer. First of all, what are reviews? Reviews are performed by developers, testers, and any other members in the team to find mistakes or ambiguities in the documents and code. Okay, without running the code. Okay, without running the code, the reviews will be performed to see if there are any mistakes or ambiguities in the documents and code. Okay, in case of code, we'll find the mistakes. In case of documents, we'll find mistakes or ambiguities. Ambiguities means confusions. Okay, any confusions. For example, if you take any BRS document, okay, so are the all the requirements. Okay, if you are performing the review on that BRS document, okay, which is created by a business analyst, okay. If software testers or development team is performing the reviews on that BRS document, they will check whether there are any mistakes in that BRS document, okay. Example is BRS document. Or are there any confusions in the BRS document, okay, as part of specifying the requirements, okay, in the BRS document, are there any confusions in the requirements in the BRS document, okay. These kind of checks will be done by the team, that is developers and testers, on different documents, okay. And even reviews will be performed on the code, guys, okay. The whatever the developers have developed the code, right, in that code the reviews will be performed on the code to see if any mistakes are done in the code, okay. So all these things are reviews, but there are different type of reviews. What are the different type of reviews we have? We have walkthroughs, inspection, code review, pair programming, and technical reviews. These are the different type of reviews. Coming to the walkthroughs, which is one of the type of reviews, which is an informal one, guys. Okay, it's a very casual one. Okay, when you talk about a walkthrough review, it's a very casual one. Okay, you will simply call the team members into a meeting room and present your document. It can be a BRS document, it can be a test case document, it can be a test plan document. Okay, it can be any code. The developers may conduct some meetings within themselves where one of the developer will call all the people and present the code before everyone. Okay, if the business analyst is presenting, the business analyst may present a BRS document and he will call all the members and present all the requirements before everyone. If a software tester is presenting a document, he'll informally call all the members to come and just review his or her test cases or test plan or whatever the document. It will happen in a very informal way. Okay, so not much process, simply calling the people and making them review the documents for which you are the owner of. Okay, such kind of thing is a walkthrough kind of review. And coming to the second type of review, we have the inspection, which is a formal one. Okay, unlike walkthrough, which is an informal one, very casual one, but inspection is a formal one. So it goes with a process, guys. Okay, so different roles will be assigned, and there will be some moderator who will make sure that emails are sent to the respective people are attending the meeting on time, how the things are going in the meeting, and after post the meeting, what should be done. Everything will be in a formal process. Okay, that is inspection kind of reviews. In walkthroughs, which is an informal review, things will happen in a very casual way. Simply call the people, get it done, and go outside. Okay, but in inspection, everything will happen in a formal way. Okay, so that's what is the difference between walkthrough and inspection kind of reviews. Then coming to the code review, guys, here the developer or any person's developed code, right, will be reviewed by the senior team members. Okay, so the junior team members' written code will be not directly published, rather, okay, not directly finalized or published. Rather, the senior members of the team will have to review and approve the code. Then only it will be approved. Okay, that is what is this process is called as code review, where the junior members, okay, junior developers code will be reviewed by the senior developer, okay, developers kind of thing, in order to approve the code, and getting it approved into the actual channel is called as code reviews. Okay, this is what is code review. Here they will be reviewing the code. Okay, now coming to the other one is, other type of reviews is pair programming. In pair programming, two people will be working simultaneously. Two developers will be sitting before a single laptop or machine, computer machine, while one developer will be writing the code. Other developer will not write the code. Other developer will look carefully into the code being written by the beside person, and immediately review the process. Okay, while one developer is writing the code, other developer is reviewing the code written by the other developer. Okay, so to find the mistakes instantly, in the code, this is what is pair programming, which is another type of review. And finally, we have the technical review, guys. Technical reviews, these technical reviews are again the kind of reviews which are conducted by technical experts. Okay, so not a normal person will be performing this review. In this kind of reviews, a technical expert will be performing the reviews. Okay, it can be any document, or it can be any code, or it can be any technical or non-technical aspect. Okay, some technical expert will be reviewing the things in the project. Okay, such kind of reviews are nothing but technical reviews. So these are the different type of reviews we have during the SDLC, that is walkthroughs, which is informal, inspection, which is formal, code review done by the senior people. Whereas pair programming, two people working together, one developer is writing the code, other developer is actually reviewing the code. Okay, technical review reviewed by the technical expert is technical review. So hope, guys, you got the answer for this question, that is what are the different kind of reviews that are conducted during SDLC. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 120. That is, what is walkthrough? Let me answer. Walkthrough is an informal review. There are different type of reviews like walkthroughs, inspections, code reviews, pair programming, technical reviews. These are the different type of reviews available, and walkthrough is a type of review which falls into the informal category. Okay, it's an informal review. I'll explain more about this walkthrough. Before understanding what exactly walkthrough is, we have to understand what is review. Okay, what are reviews? We have to understand first. So reviews are performed to find mistakes or ambiguities in the documents and code. The code can be reviewed. With the help of this different type of reviews, we can review the code. With the help of the different type of reviews, we can review the documents. And the purpose of reviewing these documents and code is to find mistakes or ambiguities. That is, ambiguities means confusions. Okay, any mistakes or confusions are there in this document or code, we are trying to review with the help of different type of reviews. While walkthrough will fall into the informal review category. So how does this informal review happen in real time? Let me show you. For example, in a project, there will be different people. The business analyst will be there, software testers will be there, developers will be there, managers will be there, a lot of people will be there, right, in a project. So let's say a particular person in the team, it can be a business analyst or it can be a tester or developer, has created one document. Okay, has created some document or written some code or whatever it is. Okay, this particular person can be a developer, tester, or a business analyst. Okay, this particular person has come with something. Okay, it can be a code or document, guys. He has prepared something, and this person want to get this particular document reviewed by the other members of the team. So what this person will do is, this person will casually, okay, it's not a formal way, in a casual manner, he will call all the people into a meeting room. Okay, he will call all the people into the meeting room, and all the people in the meeting room will be sitting here, and this particular person who has created this particular document or who has written this code, right, will showcase this document or code to all the people. And while this person is showcasing this particular document or code to all the other project members, okay, who are being called to this particular meeting, right, these people will review this document, okay, in a casual manner. It's not an official way, guys. In a casual manner, all these people will review this particular document and give their feedback. This person will collect the feedback from all these people so that he can improvise or update this document according to the feedback received from these people by following this informal review process. That is nothing but walkthrough. Okay, this is what is called as a walkthrough, guys. It's an informal meeting conducted by the owner of the document or code, okay, to showcase the document or code to the other people, other members in the team, okay, to get the feedback and to update this document based on the feedback. This is what is a walkthrough is. It's an informal review, guys. If you go for other type of reviews here, inspection is a formal review, okay. So now you understood, right, what is walkthrough. Walkthrough is a type of review which falls into the informal review category. And here the purpose is to find the mistakes and ambiguities in the documents or code, and this will be done in a informal manner as explained in this diagram, okay. So that's all about this walkthrough, guys. So see you in the next session where I'm going to answer another software testing interview question for you. Till then, bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 121. That is, what are inspections? Let me answer. Inspections are formal reviews. There are different type of reviews like walkthroughs, inspections, code reviews, pair programming, and technical reviews. These are the different type of reviews where inspections fall into formal review category, okay. Inspections are simple words, are formal reviews. But what exactly are reviews? What is the purpose of the reviews? The reviews are performed to find mistakes or ambiguities in the documents and code. The code will be reviewed, the documents will be reviewed to see if there are any mistakes or ambiguities, that is confusions in these documents or code. Any mistakes or confusions are there, will be checked as part of these reviews. And there are different type of reviews. Inspections are one of the types which fall into the formal review category. When I compare the walkthroughs with the inspections, walkthroughs are informal reviews, okay. Walkthroughs are informal reviews, whereas inspections are formal reviews, okay. Inspections are formal reviews. So what does this word formal mean? Process, guys, okay. To make this meetings or inspections or these reviews kind of formal, right, a process will be followed, while in walkthroughs no process is followed, okay. It's a walkthroughs are very casual meetings with an intention of reviewing some documents or code. But coming to the inspections, there is a process followed. That's why we call them as, that's why we call inspections as formal reviews. So what is that kind of process? So as part of inspections, that is formal reviews, the process will be followed like the meeting will be scheduled, okay. Here they will directly call in walkthroughs, but here a meeting will be scheduled at particular time and place. The meeting will be scheduled, meeting will be organized properly, email invitations will be sent to the people who need to attend the meeting, and after the meeting is done, a minutes of meeting mail will be sent to all the people who has attended the meeting with all the points that were discussed in the meeting. So such kind of process, formal process is followed in this inspections. That's why we call the inspections as formal reviews. Fine. So in inspections, guys, there are different rules. There are different rules in inspections. While the inspections, that is formal reviews, go on, right, these meetings happen, right, then we have different roles involved during this meeting as part of the review process. That is, we have the moderator role, author role, inspector role, reader role, and scribe role. Okay, let me explain more about these roles and how the inspection formal review meetings happens with this process. Okay, so as you can see here, guys, here in inspections, as I mentioned, there will be different. Let's say this is a meeting room. So all the people who need to attend the meeting, a meeting has been scheduled at proper time and place, and then right, an invitation, email invitation has been sent to the required people who need to attend the meeting. So let's say there are different people who are attending the meeting. That's okay. The complete, let's say most of the project team is attending the meetings. Let's assume. So in this project team, the different roles will be assigned. Okay, one of the member will be assigned one role. Okay, so the role may be a moderator role. Other role will be like author. The who is the author of the document, like the one the whose document, that is, it may be a document or code which is getting reviewed, right? The owner of that, or the person who is responsible for that particular document, that person is like author, okay, the creator of the document or whatever it is. For example, BRS document, if you take business analyst is a responsible person. If you take test cases, test lead will be the responsible person, right? If you take any code or something, the developer will be responsible person. So that we call that as author. Okay, one of the role is author here, and other role I told you, right? We have different roles. One of the other role is moderator role. This particular moderator role person, okay, this particular moderator role person has to take care of the meeting. He need to organize, okay, he or she need to organize the meeting properly. So that is the role of the moderator, starting from scheduling the meeting to the sending the after meeting mail minutes. Moderator is responsible, right? So author is the one who is the owner of that particular document or in charge of that particular document, like business analyst, tester, and developer, okay, respective to the type of the things that are going to show. And we have the inspector. Other role we have as the inspector, guys. We have other role as inspector role. The main person, okay, inspector is the main person who shoots out a lot of questions and finds out the mistakes in the document, okay. So that is the, what is the inspector, okay. So the main person who is going to review. Other people are also going to review, but the inspector is the main one who is going to point out, okay. So like an inspector in real world will chase a case, right? Same here also. The inspector here will find out the mistakes in the documents and all. Okay, that is what is the inspector. Then we have the reader. Another role we have is the reader role. Another role we have is the reader role. Let me explain about the reader role. That is here in this as part of this inspections, as part of this inspections, author is the one who is the owner of the document or responsible person of the document. But coming to the reader, he is the one who is, he or she is the one who is going to present the document, okay. So the author is the responsible one, but author is not going to present in this meeting. The reader is the one who is going to present in the meetings, okay. This the document or any code or whatever it is, right? Reader is going to present before everyone and just go through the document and present this particular document before everyone. So that is what is the role of the reader. And finally, we have another role known as scribe role. Okay, we have another role in this known as scribe role. This scribe will keep aside, okay, just sit aside and keep writing what the minutes of meetings and all. Okay, the scribe is the one who just sits aside in the meeting and whatever the discussions happening between this different people in the meeting, right? In this inspection, right? The scribe will make a note. So at a high level, guys, moderator is the one who will organize the meeting. Inspector is the one who is the main person who is going to inspect the document for which the author is the responsible person, and reader is the one who is going to present. Okay. So what the author will do in this case then, while the inspector is finding out the mistakes or clarifying the doubts or whatever it is, asking the doubts or whatever it is, the reader is only presenting as reader is not going to clarify the doubts or give answers to the inspector or other people in the meeting, but author is the one who is going to give answers and make a note of the different feedback which is received from the inspector and other team members. Okay, so the reader is only, the responsibility of the reader is to only speak. Okay, only just present it or speak before everyone, while the scribe only write. Okay, what's happening during the meeting, the scribe will write, and the author will also make a note of the things. Okay, so while the inspector or other members are giving the feedback as part of this review process, formal review process, author will make a note of the things, and later author can update the things and all. Okay, so these what are the different roles we have. These are the different roles we have in inspections, and it's a very formal process. Along with these meetings, the roles and responsibilities will also be decided, and things will go in a formal way with a process oriented manner. So these what are the inspections, guys. What are the inspections? So hope guys you understood what exactly are inspections from this session. So that's all for this session. The next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 122. That is, what are code reviews? Let me answer. In code reviews, the code written by developers will be reviewed by other developers, that is peers or senior developers. So why the code written by a developer is being reviewed by other peer or senior developers? With an intention of identifying any bugs or mistakes in the code. Okay, to identify the bugs or mistakes in the code that is written by one of the developer, other developers, that is other peer or senior developers, are going to review the code, and this is called as code reviews. Okay, these are called as code reviews. There are different types of reviews. that is walkthroughs, inspections, code reviews, pair programming, and technical reviews. While code reviews are one of the type of reviews. Okay. So, but what exactly are the reviews? Reviews are performed to find mistakes or ambiguities in the documents or code. Okay, as part of the reviews, as part of the different type of reviews, we are going to review the documents or we are going to review the code with an intention of finding the mistakes or ambiguities, that is any confusions in the code or documents. Okay, so this is what the reviews are, and code reviews are one of the type of the reviews where the code that is written by one developer or a set of developers is being reviewed by other developers, that is other peer or senior developers, with an intention of, okay, with an intention of identifying any bugs or mistakes or anything, okay, any deviations in the code from the expectations. So these are called as code reviews. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 123. That is, what is pair programming? Let me answer. In pair programming, two developers, that is two programmers, will sit together and work together on a single computer machine. It can be a laptop or desktop. Okay, these two developers or programmers will work together on a single computer machine while one developer writes the code. Okay, while one developer develops the code, the other developer is going to review the code simultaneously. This is what is called as pair programming. Let me give you more details about this pair programming now. Okay, so this pair programming is a agile software development technique. It's one of the, okay, you can say that pair programming is one of the agile software development techniques. Okay, it has been originated from one of the methodologies of agile. Okay, there are several methodologies of agile like Scrum, Kanban, and so on, Lean, and so on, whereas extreme programming is one of the agile methodologies, and this pair programming agile software development technique has been originated from this methodology of agile known as extreme programming. And as part of this pair programming, equally skilled develop okay, equally skilled developers will be working together. Okay, I told you in the beginning, right, there will be two developers or programmers who will be working together on a single computer machine, while one will be writing, other one will be reviewing the code. So these two developers, the one who is writing and the one who is reviewing the code, will be generally equally skilled. Okay, then here there are terminologies involved in this pair programming, guys, because there are two developers, right? One is writing the code, other one is reviewing the code. The one who is writing the code, okay, in this pair programming is known as driver, is called as driver, while the other one who is reviewing the code while the code has been typed, while the code is getting typed, the other developer is reviewing, right, sitting beside and reviewing the code, right? That particular developer is known as navigator. He is also called as, he or she is also called as observer. Okay, so here, two developers later will exchange their roles. Okay, it's not always the this particular developer will be writing the code. Okay, the one who is in the role of driver will later change his role as navigator, and the one who was actually navigating or observing or reviewing the code will change uh, the role. Okay, the role as driver later. Okay, they will be exchanging the role. Driver and navigator will be exchanging the role. These two programmers or developers will be exchanging their role based on the situations and all. Okay, these what are the more details about pair programming, and this pair programming falls into the reviews. Okay, so it comes under the reviews. Okay, there are different type of reviews, guys. Okay, there are different type of reviews like walkthroughs, inspections, code reviews, pair programming, and technical reviews. As you can see here, pair programming is one of the type of reviews. Okay, one of the type of reviews. But what exactly are the reviews? Generally, this type of reviews, that is walkthroughs, inspections, code reviews, pair programming, technical review, all this type of reviews are performed on documents and code. Okay, so documents will be reviewed using these review types, and code also will be reviewed using these different review types. What is the purpose? To find any mistakes or ambiguities. Ambiguities means confusions. Okay, to find any mistakes or ambiguities or confusions in these documents or code, the different type of reviews will be performed, and pair programming also falls into this review type category, and the purpose is same, to find any mistakes or ambiguities in the documents or code. This, so here in this case code, okay, in this case Pair programming is meant for reviewing the code with an intention of finding any mistakes or ambiguities, that is confusion. Okay. So hope guys you understood what is pair programming in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 124. That is, what are technical reviews? Let me answer. Technical reviews are performed by technical experts, and here are the more details how the technical experts are going to perform the reviews on the documents. So here, technical experts will be chosen generally from the same project team itself. In some cases, technical experts will be external reviewers also, but most of the cases, the technical experts who are going to review the documents in the project will be chosen from the same team itself, but in rare cases, they will be chosen from the external sources. Okay, they will be hired or outsourced or chosen from the external sources as part of reviewing. Okay. So here, what the technical experts will do as part of the technical reviews, they will check whether the documents under review are following the technical standards or guidelines. Okay, whatever the documents these technical experts are reviewing as part of the technical reviews, they will check whether those documents are following the required technical standards or guidelines as per the specifications. Okay, as per the specification means as per the client given requirements or specifications, whether the documents that are being created by the project team are following the technical standards or guidelines as per the given specifications. Okay, this is what the technical experts will do as part of the technical reviews. There are different roles involved in these technical reviews. That is, there are some, these are the roles guys, like decision maker, review leader, recorder, technical member, author, management. As part of these technical reviews, meetings will happen where the different roles will attend the meeting, like decision maker, review leader, recorder, technical members, author, and management. So what are these roles? Okay, coming to the decision maker, they take decision. Okay, so in these meetings, they will finalize the decisions. Okay, the decision makers. This is what their role is. Coming to the review leader, they will lead the review team. Okay, to review the. Okay, these review leaders will lead the review team to review the things properly and go in a proper direction. Then recorder, the role of the recorder is to record the discussions and observations that go in the meeting. Okay, that go in the technical review meetings. Then technical members are the one who are responsible for reviewing the documents technically. Okay, that is nothing but these are the people who are actually performing the technical reviews. Then we have the authors, who is the author or owner of the document which is getting reviewed by these other people. Okay, then finally we have the management members who will manage these review meetings. They will organize and manage the review meetings. Okay, so fine. So these are the different roles who will be involved in this technical review meetings. And finally, guys, technical reviews are one of the type of reviews. Okay, there are different type of reviews like walkthroughs, inspections, code reviews, pair programming, and technical reviews. As you can see here, technical reviews are one of the type of the reviews. And but what exactly are these reviews? So using this different type of reviews, we will review the documents and code. Okay, the project related documents and code will be reviewed using this different type of reviews. So what is the purpose of reviewing this document and code? To find if there are any mistakes or ambiguities, that is confusions in these documents or code. That's the reason this different type of reviews will be performed on the documents and code, while these technical reviews are one of the type of reviews we have. Okay, which will be performed by the technical experts to see whether the required technical standards or guidelines as specified in the requirements or specifications are meeting. Okay, or meeting. So these what are technical reviews. That's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 125. That is, what are software testing metrics? Let me answer. Before understanding what are software testing metrics, let's understand the term metrics. What does the term metrics mean? Metrics means scale of measurement. Okay, you can measure anything in this world. You can measure the weight of the vegetables, you can measure the height of something. Everything is a measurement, guys. Okay, weight, height, and all those stuff are measurements. Similarly, when you are performing different testing activities, you can measure them with the help of software testing metrics. Okay, with the help of software testing metrics, you can measure this different testing activities that you are performing as part of the project. So what are software testing metrics? Software testing metrics are used to measure and monitor different testing activities. Not only about measurement, guys. Why we have to measure? In order to monitor them, we have to track these testing activities, where they are going on. Okay, how much percentage we completed, how much percentage is pending, how much we can, all these things are part of the software testing metrics, guys. Using the software testing metrics, we are going to measure and monitor different testing activities. I'll give you some examples of measuring and monitoring the different testing activities as part of software testing metrics. So here are the examples, guys. Okay, let me show you. How many test cases created is a metric, right? So how many test cases the software testers have created so far? How many test cases are to be created, yet to be created, which are pending? How many are there? How many test cases are executed? Okay, how many test cases you executed? Really run them. Okay, how many test cases are passed as part of the execution? You see, you can also calculate or measure how many test cases got passed in the executed test cases, how many test cases got failed, how many test cases got blocked. Each and everything is a metric here, measurement. We are doing some measurement of the testing activities with an intention of monitoring them, tracking them, where we are standing, what is our progress, we are tracking them. How many test cases are not executed? What is the percentage of the test coverage? Okay, so if 100%, how much percentage of testing you are done with? That is also a metric. How many number of defects you have identified? Okay, the testing team has identified in the project. So how many critical? So it's not only about the how many defects identified, how many critical severity defects identified, how many high severity defects identified, how many medium severity defects identified, how many low severity defects identified, how many defects that are still there in the application or application functionalities and which are not yet fixed by the developers, existing defects in a module or functionality or an application. Okay, and we can also measure the defect density. What is defect density? Number of defects identified for per requirement. Okay, for each and every requirement, how many defects are coming? That is what is defect density. Then defect removal efficiency. That means, so after the testing phase is completed, and the software has been released into the market, okay, if the customers, that is end users, are also finding some defects that testing team has not found, then this can be calculated. Okay, defect removal efficiency can be calculated, which is nothing but number of defects found during testing by the testing team divided by, again, the number of defects found during testing by testing team plus number of defects found by end users. Okay, so if, let's say, assume that the testing team has identified 10 defects, okay, and the end users have identified 2 defects, 10 divided by 10 plus 2, that is 12. Okay, 10 by 12 into 100, that's what is the defect removal efficiency. Okay, that's how we calculate. Then how many, it's ultimately, guys, how many defects that the testing team were able to eliminate before releasing the software into the market is nothing but this measurement or metric. Okay, then we have defect leakage. How many defects got leaked? Okay, so after the testing is done by the testing team, the software will be given to the UAT. Okay, it will be sent to the user acceptance testing. So defects missed by the testing team during their testing time, and if the defects are also found by the in UAT, some defects are found. Number of defects found in UAT, which comes after the system testing phase, by number of defects found during the system testing phase. Okay, into 100, that is defect leakage. How many defects the testing team has not found? That is defect leakage in simple words. Number of defects by priority. So number of urgent priority defects, how many number of high priority, everything is a metric here. You see, measurement. Number of medium priority defects, number of low priority defects, everything can be calculated. Every testing activity can be measured. Okay, with the help of the software testing metrics, different software testing metrics. Number of test cases failed due to a defect. Okay, if there is a defect due to that, how many test cases got impacted? How many test cases are getting failed? That also is a metric. Number of lines of code tested. Okay, number of requirements. How many requirements we have? Average number of requirements written for. Sorry, here average number of test cases. Sorry. Okay, average number of test cases written for given requirement. For each and every requirement, I mean, on an average, if you have 100 requirements and you have 1000 test cases, means on an average, how many you have written? 10 test cases for each and every requirement on an average you have created, right? That is another metric. Total number of test cases written for all requirements. If there are 100 and how many test cases? 1000 test cases, let's say. Okay, so for all the requirements, how many test cases you created, and many more metrics are possible, guys. Okay, these are just an example list only. Whatever I gave here is a example list. Okay, the common example list of software testing metrics that we generally every testing activity can be measured like this, guys. Either it can be test cases, it can be requirements, it can be defects, or anything can be tested, guys. Okay, so what is the advantage of measuring then? Okay, what is the advantage of these metrics, or what is the advantage of measuring something? So let me give you the advantages of measuring something. So what will happen if you measure something? What is the advantage, guys? You will get to know the current status. Okay, you will get to know the project manager, or who is actually running the project, will, or the test lead who is owner, who is taking ownership of the testing activities in the project, will get to know what is the current status of the project, and other stakeholders also will get to know what is the current status of the project. Okay, where the testing team is standing. Okay, how much they completed, how much they are yet to complete. All these things they can understand. They can track the current status of the project, and estimate further things also. Okay, so in the remaining time, okay, in the remaining time, how much they can complete, they can estimate in the next iteration or something, how much work they can complete. And to complete that kind of work in the remaining time, they can plan it effectively, right? This much work is left, this much time is left, so we need to plan like this. Okay, we have to work an extra hour, okay, to complete this task. Like that they can plan something. This is what is the advantage of the metric, guys. By measuring something, we know the current status, and where we are standing, whether we have to improve or whether what we have to do, everything will come to know. We can estimate the further things also. This work will be completed by this time. Okay, so like that we can estimate. So and plan them. Okay, and plan them properly. So these are the advantages, guys. We can track the current progress of the testing with the help of the metrics, software testing metrics. We can track the current progress of the testing, where we are standing in testing, whether we are able to we'll be able to complete in time or not in the given time and estimates. Okay, we can estimate the time and cost, guys. Okay, the how much time it will take more time to complete the remaining task or work as part of testing, and how much cost is involved. Okay, so based on the pending activities to be performed, we can decide that we can estimate the time and cost. Okay, that is extra needed to complete the work. We can know the current quality of the software. Okay, so based on the test coverage or something, we can decide, like based on how many test cases we have executed, we can understand what is the current quality of the software, how much amount of software has been tested. Based on that, we can decide the quality of the software. Okay, so depending on the type of bugs we are getting or defects we are getting, or that pending fixing from the developers, we can measure the quality of the software also. Okay, if the software is having few less pending minor kind of issues, okay, low severity defects, then you can say that quality of the software is high in that case. You see, with the help of metrics, we can decide that. We can know whether we are productive in testing or need to change the things to be on track as part of the test. You see, once we know the current status of the testing and our activities and our work done, okay, till now, then how much remaining time is there? Based on that, anyone can say that. Okay, anyone can say that we are lagging behind or we are on track as per the plan we are testing, or we are lagging somewhere. We need to provide more efforts to complete the things on time, right? So are we going out of track, or we are on the track, or we are ahead of the track? Everything we can come to know with the help of this metrics. Okay, metrics will help us like that, and many other things are possible. Many other advantages are possible with the help of this software testing metrics. So hope, guys, with this with this explanation, hope that you understood what are the software testing metrics and what are their advantages. Okay. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 126. That is, what is defect density? Let me answer. Defect density is one of the software testing metrics using which we can determine the quality of the software. Okay, using this defect density software testing metric, we can determine or measure the quality of the software. And how this defect density is calculated? By dividing the number of defects found in the software by the size of the software. Okay, when you divide the number of defects found in the software by the size of the software, automatically you will get the software testing metric measurement, that is defect density. And here is the formula, guys. Defect density is equal to number of defects found in the software divided by number of lines of code written by developer for developing the software. This is the formula. Okay, so here, as part of this formula, we use some terminologies like LOC and KLOC. This LOC stands for lines of code, whereas KLOC stands for 1000 lines of code. Okay, so let me take an example to make this particular formula clear for you. So for that, I'll go here and I'll just take a new file. Just give me a second. So here I'll explain. So an example for defect density, understanding defect density. For example, guys, there is a software. Let's say this is the software. So this software has different modules or functionalities or modules. Okay, let's divide them into, let's say, some 9 modules. Okay, so in this first module, okay, module can be a login functionality or logout, whatever it you can call. Here, let's say there are 100 defects found, and here how many lines of code are written? Let's say the here some 2000 lines of code are written. Okay, 2000. Whereas here 50 defects, they're like around 1500 lines of code. Here 10 defects. So here say around 1000 lines of code, assume. Now here 500 lines of code. Okay. So let me write the lines of code now. 500, another 500. Okay. And here another 500. And let's say here 1000. I'll write 1000. Here also 1000 lines of code has been written by developer for developing this particular modules of the softwares. Okay. So here 150, here let's say 40 defects have been found. Here let's say here 100 defects. Okay. So here 10 defects. Like that, individual modules have individual defects, like here 10, 40. Okay, then 50, like that some defects have been found. So like this in different modules, different lines of code will be there, and that means different number of defects will be there. If you calculate these defects, okay, you calculate these defects like 100 plus 50. Let's calculate the total number of defects in this case. I randomly written all these numbers, guys. Okay, so 150, 10, it's 160, 200, 300, 310, 310, then 320, 360, and 50. That is 410, right? 410 defects have been found. How many lines of code are written by developers for developing these modules? Total lines of code, okay? Total lines of code, LOC you can say. Lines of code is nothing but total lines of code ultimately, okay? They are like 2000, 3000, 4500, 5000, 5500, 6000, 7000, 8000, 9000. Total 9000. So total lines of code are 9000. Total number of defects found in the software are 410. So how to get this defect density now? We have to divide 410 should be divided by number of lines of code, that is 9000. Whatever the result you will get, that is nothing but the defect density. Let's calculate this, guys. Okay, I'll use some Google or something to calculate. 410 divided by 9000, right? 410 divided by 9000. What is the calculation? 0.04, almost 0.05, guys. Okay, let's take that as 0. Let's round it off. The result is 0.05 is the result. Okay, this is what is the defect density. This is what is the defect density, guys. As an example, number of defects divided by lines of code. Here lines of code is nothing but LOC. Okay, here we have written how many lines of code? 9000. This is nothing but 9000 LOC. Okay, this is 9000 LOC. LOC is a keyword or terminology used, which is short form for lines of code. Okay, 9000 lines of code. So it's simply 410 divided by 9000 LOC. Like this we are writing. Okay, the same thing we can write something like this. Okay, instead of saying 9000 LOC, you can say 9k LOC. Okay, 9000 lines of code. Okay, 9000. Okay, this is short form, but we should not be writing like this. So what we do is, whatever the result you are getting, right, 0.05, you have to multiply that with 1000. Okay, multiply that with 1000, then what you will get? Then when you multiply this particular result of this 410 by 9000 lines of code, whatever you get, if you multiply by 1000, what you will get? Almost 50 you will get. Okay, 50, right? 0050, 0.05 into 1000 is 50. That means for every 1000 lines of code, there are 50 defects. For every 1000 lines of code, for every 1000 lines of code, there are 50 defects. So how this should be represented? 50 divided by KLOC, you have to say. Okay, this is the format of representing 50 by KLOC. 50 defects for every 1000 lines of code. Okay, or you can also say 410 divided by 9000 LOC. Either you can say this one, you can represent this defect density result in the form of LOC, that is 410 number of defects by total number of lines of code developed by the developers for developing the software, that is 9000 LOC, or you can say 50 average defects per 1000 lines of code. For every 1000 of lines of code, there are 50 defects. Is it a good sign? To have 50 defects for every 1000 lines of code is a good sign? No guys, it's bad. What is considered to be good? 1 by KLOC is considered good. Okay, this is a measurement which is considered good. If you want to say that the quality of the software is good, if you want to measure the quality of the software with the help of the defect density, this particular formula should result in 1 by KLOC. That means one defect for every 1000 lines of code. 1 by KLOC means what? One defect is there for every 1000 lines of code, which is a good sign to state that the quality of the software is good and can be released into the market for the end users. Okay, then only you can take a decision about whether to release the software into the market or not based on the defect density. If you want to take a decision based on the defect density to determine the quality of the software to see whether it can be released into the market or not, then for every 1000 lines of code there should be only one defect, average one defect should be there, then only you can plan to release at least. Okay, so hope guys you understood what is defect density in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 127. That is, what is defect leakage? Let me answer. Defect leakage is one of the software testing metrics using which we can identify or measure the efficiency of software testing by checking the number of defects that are not identified or the defects that are missed by the testing team during testing. Okay, so it's a metric, that is measurement to measure the efficiency of software testing. How to measure the efficiency of software testing? By seeing or checking how many number of defects are missed by the testing team during testing. Okay, that's what is defect leakage. So here is the formula guys. Okay, defect leakage is equal to number of defects that are missed by testing. That means number of defects identified later after the testing phase is completed in the next phase, that is UAT phase. Okay, user acceptance testing phase. If the defects are found in the UAT phase, or if the defects are found after releasing the software into the market, all this total number of defects that are identified after the testing phase divided by number of defects that are actually identified by the testing team into 100. For example guys, let's say the testing team during testing a software, okay, testing team while testing a software, let's say they have identified, for example, 100 defects. Okay, 100 defects are identified by the testing team. Now after the testing is completed, once the application went to UAT phase, user acceptance testing phase, so there somewhere around some 20 defects are identified. Again, after releasing the software into the market, another 20 defects got identified. So total how many defects? After the testing phase is completed, 40 defects. These defects are identified after the testing phase. That means these are the number of defects that are missed by the testing team. So actual number of defects that are identified during testing by the testing phase are testing team are 100, but how many are missed? 40. So if I have to calculate this defect leakage, how to calculate this formula? Okay, with this formula I have to calculate like this: 40 divided by 100 into 100, okay, multiplied by 100. This is what is the formula. So let's do that on Google. So 40 divided by 100. First of all, I'll say 40 divided by 100. That is 0.4. 0.4. So 0.4 into 100. What is the result? We got the 40. That means 40 percentage. So what is the defect leakage? Defect leakage is 40 percentage in this case. So this is what is defect leakage, guys. So using this particular metric, we can identify or measure the efficiency of software testing. 40% is bad, right? So 40% of defect leakage kind of thing is bad in terms of efficiency of software testing is very bad. Okay, so that's just an example anyhow. So you are able to correlate. That's enough. So that's all about what is defect leakage. So in the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 128. That is, what is defect removal efficiency? Let me answer. Defect removal efficiency, in short known as DRE, is one of the software testing metrics using which we can determine or measure the efficiency of software testing. So there is a formula for this defect removal efficiency. Here is a formula which can measure the efficiency of software testing. So DRE, which is nothing but defect removal efficiency, is equal to number of defects identified by testers during testing. Okay, while performing the testing, the software testers, whatever the defects they have identified, the total number of defects divided by number of defects identified by testers, and also after testing any other defects are identified, that also need to be calculated. Here total number of defects, here only the number of defects identified by testers, here total number of defects identified during testing and after testing also. Okay, so into 100. Let me give you an example so that this formula will be more clear for you. Let's say that the software testing team has tested this particular software, and as part of testing, the testing team, okay, let's say testing team during testing has identified 100 defects in the software. Okay, let's say the testing team has tested the software during testing phase and identified 100 defects. 100 defects. So later, once the testing team has released the software to the UAT, okay, after system testing is done by the testing team, the software will be moved to the UAT phase, user acceptance testing. In UAT, the UAT team has, let's say, identified 20 defects. And after that, the software has been released into the market. The end users, okay, the end users, while using the application for their real-time purpose, let's say they identify 20 defects, assume that, okay, which will not happen, but let's take a vague example here. After, you see, testing team during the testing has identified 100 defects, but in UAT, 20 more defects came, and users have identified 20 more defects. So that means during testing, 100 defects are identified, but after testing, 40 defects are identified, okay? Simply these 40 defects are missed by the testing team, right? The 40 defects are missed by the testing team. 100 defects are identified by the testing team, but 40 defects are missed by the testing team. So in this case, in this kind of situation where testing team has identified 100 defects in the software and they have missed 40 defects in the software, how to calculate this defect removal efficiency? So here, number of defects identified by testers, that is 100 defects are identified by testers, divided by total number of defects identified by testers and also by the after testing also. That means 100 plus 40, that is 140. That is 140 defects into 100. Into 100, you'll get a percentage, okay? You'll get a percentage if you multiply that by 100, okay? 100 by 140, let's calculate that. What is 100 by 140? 100 divided by 140. If I say 100 divided by 140, you'll get 0.71. So if I multiply that with if I multiply this 0.71 with 100, I'll get the percentage. How much percentage? 71.4 percentage. Okay. So 71.442 percentage. Okay. 42, sorry, percentage. Okay. So this is the result. So what is in this particular example I have taken, what is the defect removal efficiency? In this example, it is 71.42% is a defect removal efficiency. This is how the defect removal efficiency is calculated or measured. Okay, measured to identify the efficiency of software testing. How efficient is the software testing? So this particular formula need to be used to calculate this defect removal efficiency metric, using which we can measure the or determine or identify the efficiency of software testing. How efficient is the software testing? We can identify. So hope guys you got the answer for this question. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 129. That is, do you know the formulas used for calculating the different software testing metrics? Let me answer. First of all, there are different software testing metrics, and each and every metric has a formula associated with it to calculate. Now, let me showcase all the different software testing metrics and their respective formulas for you. So let's start with the first one. First metric is, first software testing metric we have here is percentage of test cases executed. Okay. So how to measure this metric? Okay. For that we have a formula. The formula is this formula. Okay. But what is the purpose of this metric? Why we have to measure this metric? To determine the test cases execution status. How many test cases, like what is the status of your test cases execution? Okay, you have a test case document, and what is the status, what is the current status of the execution of the test cases? Okay, so to figure out that, this particular formula related to this particular metric need to be calculated. That is, percentage of test cases executed is equal to, okay, this particular metric is equal to number of test cases executed divided by total number of test cases. Okay, the number of, very simple formula guys, there is nothing much here. For example, okay, for example here, let's say for testing a particular software, let's say there are 100 test cases. In that, if you have executed 50 test cases, so what is the formula here? Number of test cases that you have executed divided by total number of test cases into 100. Okay, into 100 in percentage you will get the answer. Okay, that is, here in this case how much? 50% you will get definitely. Okay, this is 50%, right? That's the answer. So here also same thing. Percentage of test cases executed is equal to number of test cases executed divided by total number of test cases into 100. So here in this example I showed you 50%, right? So similarly, we have other software testing metric, that is percentage of test cases not executed. Okay, here executed, here not executed. Very simple one. Small difference is there between them. To determine the status of pending execution status of the test cases. Okay, how much pending work is there in terms of executing the test cases? To determine that, we have to calculate the this particular metric using this particular formula. That is, percentage of test cases not executed is equal to total number of test cases not executed divided by total number of test cases. Okay, the number of test cases that you have not executed divided by total number of test cases into 100. Simple. Okay, so let me give another example. Let's say total there are 100 test cases. Out of 100 test cases, you have not executed 20 test cases. Okay, 20 test cases are still pending. Total test cases are 100. In that 80 test cases you executed, but 20 test cases you have not executed it. So 20 divided by 100 into 100, you will get the percentage. That is 20% of test cases are not executed. Okay, it's nothing but 20% of test cases are not executed. Okay, that's the result. Fine. Next metric we have is percentage of test cases passed. Okay, percentage of test cases passed. This is, as you can see, it's very understandable, right? With the name, to determine the, this particular metric is used to measure or determine the pass percentage of executed test cases. Okay, pass percentage is what? Executed test cases. So let's say here is a formula, guys. I'll explain about this formula. Percentage of test cases passed is equal to number of test cases passed divided by number of test cases executed into 100. Okay, I'll explain with an example so that the formula will be more easy to understand. So here is example. Let's say there are total 100 test cases. Okay, let's say there are total 100 test cases. In that 100 test cases, or else let's go with this number. Let's say there are 120 test cases. Total test cases are total test cases are 120. In that 120 test cases, you have executed. Okay, executed test cases are 100. 100 you completed, 20 are pending it. Okay, these are executed test cases. Executed test cases. So in that executed test cases, 80 test cases got passed. 80 test cases passed. Then how to calculate this particular metric that I am talking about here? You see, number of test cases passed is equal to number of test cases passed is equal to number of test cases, percentage of test cases passed is equal to number of test cases passed, that is 80 divided by 80 divided by, it's not total test cases, it's executed test cases. Okay, we should not take the total here. In this formula, we should not take the total test cases. We have to take the total number of executed test cases only, that is 100. Okay, the number of test cases that you executed, and in that executed test case, how many got passed? 80 test cases got passed into 100. That is, percentage of test cases passed in this particular example is 80%. Okay, 80% of test cases passed. Similarly failed. Okay, here it is to determine, here it is, this particular metric is to determine the pass percentage of executed test cases, whereas this one is to determine the fail percentage of executed test cases. So the formula is definitely almost will actually match with the passed one only. So simple, in place of pass, here fail will come. That's it. Okay. Percent of test cases failed is called number of test cases, here pass, here failed, divided by number of total executed test cases. Okay. Number of test cases executed. So in this case, you see 80 test cases passed mean 20 test cases got failed, right? 20 test cases failed, let's assume. Okay. 20 test cases failed. So that means what will be the result? 20 divided by total number of executed test cases into 100. That is 20 percentage. 20 percentage. Similarly, we have one more thing, that is percentage of test cases blocked. Similar to passed fail, blocked also is there. So simply replace the passed word with passed failed word with blocked here. Okay. To determine the blocked percentage of executed test cases out of the total number of executed test cases, how many test cases got blocked into 100. Okay, which is very simple, and you can correlate. Okay, don't have to explain more about this. Okay, it's very similar to the passed and failed percentage of test cases. Okay, then we have the next software testing metric, that is defect density. Okay, so to determine the this particular defect density is generally measured to determine the quality of the software. Okay, what is the quality of the software? And here, how do we? What is the metric here? How do we measure that? Here, guys, number of defects per lines of code. Okay, so in a particular software, okay, how many defects are there per lines of code? That is what is the calculation to be done. Okay, here is a formula, guys. You can understand this statement more with this formula. Defect density is equal to number of defects by lines of code. Okay, which is same na, number of defects per lines of code. So lines of code means developer will be developing the software. For that, he cannot finish up the entire software development in a single line of code, right? He has to develop lot of lines of code to develop a software. So if you take an entire software, let's say this entire software, the developer has to write lot of lines of code, right? Lot of lines of code the developer has to write. But let's say there are thousand lines of code. Assume that there are 1,000 lines of code. For that, if you have 50 defects, okay, you got 50 defects for this 1,000 lines of code. Generally, it will not be 1,000, guys. It will be like 10,000 or something. Okay, so here 50, let's say 1,000. Okay, 50 defects you got for 1,000 lines of code. Okay, if the application is very small application, it has 1,000 lines of code developed by the developer to build this application, and in that particular application there are 50 defects. Means what is the defect density? What is the defect density? 50 divided by 1,000 is the defect density. So what is the result? Let's see the defect density here. 50 divided by 1,000, that is 0.005. Okay, 0.05 is the defect density. This is a defect density, guys, nothing much. Okay, so this is the result of this formula. Now let me give a proper example. So here there are terminologies, guys. Okay, in case of this defect density, there are two terminologies. That is nothing but LOC. LOC stands for lines of code. KLOC is there. Okay, sometimes you will represent the result of this defect density in the form of LOC. Sometimes you will represent the defect density in the form of KLOC. Okay, 1,000 for 1,000 lines of code, what is the average defect density, like that. Okay, so here in this example, what we got, for assume that let's say here, assume that there are 1,000 lines of code for this particular software developed by the developers. This many lines are written by developers who are developing the software, and there are 1,000 lines of code. We got 50 defects. 50 divided by 1,000 is nothing but 0.05. Okay, this for LOC. Okay, here you have to say 50 divided by LOC. What is the result? 0.05 is the result. Okay, 50 defects divided by 1,000 LOC, you have to say. Okay, 1,000 lines of code. Result is 0.05 is the defect density. Okay, now if I have to calculate the KLOC, how to do that? KLOC means for every 1,000 lines of code, how many defects are there, like that. Okay, here same thing is 50 per KLOC. Okay, 50 per KLOC, like this you have to write. Okay, 1,000 lines of code can be represented in short as KLOC. If you have to take a proper example, guys, let's say there is a software. In the software we got total defects we got as let's say 50 defects, and let's say 500 defects otherwise. Okay, 500 defects we got, and the size of the software is let's say 10,000 lines of code are there. Okay, 10,000 lines of code, but 500. So what is the defect density? 500 divided by 10,000. So let's see, 500 defects divided by 10,000 lines of code. Okay, that is nothing but again 0.05 only we are getting. That's fine. So 0.05. So this part if I have to represent, right, I have to represent like this: 500 divided by 10,000 LOC I have to say. Okay, the result of this is 0.05. 0.05 is the defect density. Now same thing can be represented like this. Okay, so for total 10,000 lines you have got how many lines? 500. You have got how many defects? 500 defects. But for every 1,000, what is the average number of defects we got? Okay, if for that guys you have to remove one zero here, one zero here. Okay, right? So that means for every 1,000 lines of code you got 50 defects. How to represent that? 50 divided by 10 KLOC. Okay, 10,000. 10K means 10,000 LOC. Okay, 10 KLOC. 50 divided by 50 by 10 KLOC. You have to represent the same thing. And for every 10,000 lines of code, you got 50 defects. Okay, and the answer definitely the answer will be 0.05 only. But the terminology you have to understand. Okay, so this is what is the defect density with the examples I provided. Now let's go with the next software testing metric, that is defect leakage. So how to measure this defect leakage and what is the purpose of measuring this defect leakage software testing metric? The purpose is to determine or measure the efficiency of software testing. How efficient, okay, how efficient is software testing? How can we check the efficiency of software testing? By checking how many number of defects are missed by the testing team during testing. Okay, you see the software testing team will perform the testing, and as part of the testing they have identified some defects. Okay, let's say the software team, that is testing team, has tested a software. Let's say the software testing team has tested a software. Let's assume that is the software. In this particular software the testing team has identified 100 defects. Okay, and they have hand over this particular software that has been tested, and where they identify 100 defects, right? After fixing these defects, they have hand over this particular software for the next levels, that is UAT. UAT, and after that software will be released into the market, right? After this, after UAT, software will be released into the market. User acceptance testing. This is released into the market. So during software testing, before UAT and you see, before UAT or before the software gets released into the market, the software testing team has identified 100 defects during the software testing process. Okay, 100 defects got identified by the testing team. But after the testing is completed, once the UAT is started and then the software got released into the market, let's say UAT team has reported something around like they reported 20 defects. Okay, 20 defects got identified. Okay, despite of testing team has tested, the testing team has missed 20 defects. That 20 defects got identified by UAT team. And apart from that, after releasing the software into the market, 5 more defects got identified. Okay, by the end users or real customers who are actually using the live application, right? After the software is released into the market, 5 defects got identified by the real customers. Okay, and real end users. So how many total defects got missed here by the software testing team, were not identified or missed by the software testing team? 100 defects they identified, but 25 defects they missed. Then in this case, if you have to calculate this particular defect leakage metric, the formula is like this: defect leakage is equal to number of defects identified later. That is, how many defects they have missed? 25. Okay, 25 defects are missed by software testing team, divided by number of defects identified by testing team. That is 100 into 100. So how much? This is 25 percentage. Nothing but 25 percentage is a defect leakage. So for every 100 defects, 25 defects got missed by the software testing team. So, so with that we can know, right? The software testing has done the work efficiently or not. We can know. Okay, for every 100 defects, 25 defects got missed by the software testing team, which is a poor thing anyhow. Okay, so then we have the next next software testing metric, that is defect removal efficiency. Okay, which is shortly known as DRE, defect removal efficiency. And this is also similar to defect leakage. The purpose of the defect leakage is also same, and the purpose of the defect removal efficiency is also same. Here also the purpose is to determine or measure the efficiency of software testing. Here also efficiency of software testing, but here how the efficiency is measured, how many defects were eliminated by the testing team. Here we are thinking in a negative direction, where we are talking about how many defects got missed by the software testing team. Here in a positive way we are talking how many defects are, okay, are eliminated, okay, eliminated by the, removed by the software testing team because of their testing, okay, because of the software testing efforts, how many defects got eliminated. Here positive side, but here defect leakage negative side, how many missed. Here how many got removed, okay, in a positive direction. This is a negative direction. That's the only difference, guys, and formula is very simple. Dr is equal to number of defects identified by testers. How many defects in this example, how many defects got identified by testers? 100 defects. 100 divided by number of defects identified by tester, that is 100, again 100 divided by 100 plus and end users and UAT. Remaining defects which got missed by software testers, okay, that is identified by UAT team or after releasing in the market, end users have, and total 25, right? 25. That is 100 divided by 125 into 100. Okay, so what 100 by 125 is how much? Let's see. 100 divided by 125. That is 0.8. 0.8 into 100. You'll get the percentage. How much? 80 percentage is the answer is 80 percentage. Okay. So in this example, 80 percentage is in this particular example, 80 percentage is the defect removal efficiency. Okay. So this is what, guys. Now let's move on to the next software testing metric, which is very simple. That is defects by severity. Okay. So you already know about the defect severity, right? Based on the severity, we have to, okay, do some measurements. That is the purpose of the defects by severity software testing metric is to determine the number of defects identified based on the severity. Okay, based on the defect severity, how many defects are identified? If you want to measure that, you have to go with this software testing metric. The formulas, multiple things are there. For example, here different levels of severity are there, like critical, okay, the top one. Then next level is high severity defects, then medium severity defects and low severity defects. If you understand one of the software testing metric type for, like, say, percentage of critical defects, remaining all very simple. Okay, just a replica of the same. Percentage of critical defects is equal to number of critical defects identified by the software testing team divided by total number of defects identified by the testing team into 100. That's it. Okay, very simple formula, guys. Okay, so if you have to understand this, let's say the testing team has identified 100 defects. Assume that the testing team has identified 100 defects. In that, 10 defects are critical defects. Okay, critical severity defects. Then how to calculate this formula? Percentage of critical defects is equal to 10 critical severity defects divided by total number of defects identified into 100. That is 10 percentage. Simple, right? The next one, high severity, is also same. Number of high severity defects identified by total number of defects identified into 100. For example, the testing team has identified total 100 defects. In that, okay, 20 defects are high severity defects. In that, so into 100, what is the percentage? 20 percentage. Okay, percentage is 20 percentage, like that. Then medium severity, let's say the testing team has identified 100 defects. In that 100 defects, 30 defects. Okay, 30 defects 30 defects are medium severity defects. Okay, so into 100, so 30%. Next, low severity defects, let's say in the 100, 40 defects are, in the 100 identified defects, 40 defects are low severity defects identified. So into 100, that is 40 percentage. Okay, so it's clear, right? Very simple formulas, okay, for defect by severity software testing metric. So these are few software testing metrics, guys. I didn't cover everything. So if you keep on covering everything, right, there will be a lot of formulas coming. Okay, it's a very big topic, guys. Software testing metric is a very big topic, and these are the generally used ones, which you can understand. Okay, if in the interview you will get the kind of question where they'll ask you, do you know the formulas used for calculating different software testing metrics? Have you ever calculated software testing? Such kind of questions may arise, guys. Okay, in real time, when during the interviews. In that case, you can answer these questions. Okay, whatever you remember from this list of examples I gave, right? Just give these examples. With examples, if you can explain this any number of things that you can remember from this list, then you are good to go. Okay, but there are a lot of things. Okay, I didn't cover everything for you. This much will be enough for answering this software testing interview question if you come across in the interviews. Okay. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 130. That is, what is the role of metrics in software testing? Let me answer. The role or purpose of metrics in software testing is to measure and monitor different testing activities. By measuring and monitoring different testing activities, there are a lot of advantages we get. That is, we can know the current status. Okay, we can know how much work is completed, how much work is pending as part of the project, and how much of things are completed. Let's say, for example, if you take test cases, okay, how many test cases got executed in that, how many test cases got passed, how many test cases got failed, all this current status, what is the current quality status of the software that you are testing, all this current status you will get to know. And also, based on the tracking of the current status, we can estimate further things. Okay, based on whatever the work we are doing from the days, okay, by tracking that, we can estimate the future work. Okay, whether we can complete the work on time or not, whether we can complete the work within the budget or not. Okay, all these things we can estimate. And also, by tracking this and by estimating this, we can, if you are not on track, let's say, okay, if the project team is not on track, by tracking the current status and estimating the future work, if it's kind of clear that we are not on track, we are behind the timelines. Okay, so we have to do more work so that we have to be on track. Okay, so we can plan that. We can plan that if the things are not going as per the plan and we are not on track, in that case we can plan our work in such a way that we can control the things in such a way that we can be on track again, and we can plan to complete the things on time and within the budget. All these are possible with the help of metrics. Okay, by measuring and monitoring the different testing activities, all these are the advantages, guys. We can know the current status, we can estimate, and accordingly we can plan if you are not on track, or to do the work in a better way, we can plan the things. All these are possible, guys. So so these are the advantages. We can track the, as I already mentioned, we can track the current progress of testing, where we are standing, how much work is pending, how much work has to be completed, and all those stuff we can track. And we can estimate the time and cost. Okay, estimation, I told you, right? We can estimate. So by tracking, we can estimate the, by measuring and monitoring the different testing activities, we can estimate the time and cost. So based on how much work is pending and how much time it is required to complete that pending work, how much within the budget can we do or not, all those things we can plan. Okay, we can know the current quality status of the software. As I already mentioned, we can know the current quality status of the software, and also we can know whether we are productive in testing or not. Okay, are we doing work in a proper way? Are the things happening as per the plan? Have we completed whatever the work that we have to actually complete in time and within the budget? All these things we can find it out. And if not, we can change things. Okay, we can control the things, and we can modify the process or something, so that we can be back to track. Okay, as part of this. Okay, if the things are not going well, then you can plan in such a way that you can control the things and work accordingly, so that you can be on track again. Okay, as part of this working on different testing activities. And many more advantages are possible, guys, by measuring and monitoring different testing activities. That is the role and purpose of metrics, is to measure and monitor different testing activities. With that, you'll get a lot of advantages like this. So hope, guys, you got the answer for this question. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 131. That is, what is manual testing? Let me answer. Manual testing is performed by a person, that is tester, without using any test automation tools. That means without using any test automation tools, if a person, that is a tester, is performing the testing on an application, that testing is called as manual testing, where test automation tools are not used. Instead, a person is performing the testing here. Let me give an example for this. I'll take a sample application. So let's say we are testing this application, that is tutorialsninja.com/demo application. Okay. So if manual testing has to be performed on this particular application without using any automation tools, how the tester will be performing the testing? Tester will be sitting before the computer machine or any device where the application is running, and the tester using his eyes, hands, and all, he or she will, okay, perform testing like this. Okay, using the eyes and hands, the tester by sitting himself or herself before the computer machine or device where the application is running will perform the testing like this. Okay, let's say I'm testing the search functionality. I'm manually typing. Okay, I'm manually typing HP text into the search box field. I'm manually clicking using my hands. I'm moving my mouse and clicking on the search button. And in the search results, by using my eyes, I'm verifying whether, okay, here we got the required product in the search results or not. Okay, I'm manually testing the search functionality of this application for now. Okay, so this is an example for manual testing and how manual testing will be performed by a person that is tester without using any test automation tools. Okay, so what is the difference between manual testing and automation testing? So coming to manual testing, as I already mentioned, the tester, that is person who will be sitting before the computer or device where the application is running, will be performing the testing by using eyes or hands. Okay, eyes and hands. That is manual testing. But coming to the automation testing, here automation tools like Selenium, UFT, Test Complete. These are few examples, guys. There are a lot of automation tools available in the market. Okay, coming to automation testing, an automation tool will be performing the testing. Automation tools like Selenium, UFT, Test Complete, Cypress, etc., and so on will be performing the testing on behalf of the tester. Here, a real person is not performing the testing on behalf of the tester. That is a real person. An automation tool is performing the testing. That is automation testing. So this is what is the difference between manual testing and automation testing. In manual testing, a person will be performing the testing. In automation testing, automation tool on behalf of the person will be performing the testing. So hope guys, you got the answer for this interview question. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 132. That is, what are the key challenges that you have faced while testing a software application? Let me answer. So there are different challenges that the software testing team will face while testing a software. I'll give you the list of the items that general in real world, right? While the real software testers are testing the real-time applications during their projects, they may come across these challenges. Okay, if you can mention few of these challenges. Okay, if you are getting this particular question in the interview, if you can mention the few of the items from this list, whatever I'm giving in this session, then that will be more than enough. Okay, so let me give the list of key challenges that software testing team may face while testing a software. Okay, so here are the list. First challenge is about the environments, guys. Okay, so test environments, challenges regarding the test environment. So what will happen with the test environments is, you see, setting up this test environments is a big challenge for the testing team. Okay, one of the challenges, the software testing team, you see, we have to test the application. Where we have to test the application? We have to test the application on a supported test environment. You see, there is an application like a web application, like for example, you have to test Amazon.com. Okay, you have to test that website. That Amazon.com supports Chrome browser, Firefox browser, IE browser. It supports different operating systems, different devices, and so on, right? A lot of environments are required for testing that. That's okay. But the problem is setting up that environments is a big deal, okay? Because every environment has a different browser, different operating system, different versions and all. So setting up such kind of test environments for testing purpose is a big challenge for the testing team, okay? So that's a major challenge. Okay, whenever it will take a lot of time, guys. Sometimes because I have worked in real time and I faced this problem while you see, while performing testing. I'm ready to test, but the problem is environment is not easily available. It's wasting a lot of time. Whatever the time I have, right, I can easily complete my testing work. But the problem is half of the day is going for setting up the environment, and that too sometimes to get an environment I have to wait till the end of the day, and still some problems are there. Okay, environment mismatch will happen where, you know, right, the required environment where you have to perform testing, or there may be some configurations that you have to follow some step by step configurations to actually prepare the environment. If you do a single mistake while preparing that environment, right, you are gone. Okay, your environment is not ready. So setting up test environments is a big challenge. Okay, anyone can test, but the problem is getting the test environment ready for testing the application. Proper test environment ready for testing the application is a big challenge. Okay, so this is one of the challenge that software testers face. Not only that, guys, you see, single application has to be tested across multiple environments. Okay, you see, Amazon.com has to be tested on Chrome browser, Firefox browser, IE browser, Edge browser, Opera browser, Safari browser, and any other browsers. Okay, so whatever the browsers that are popular, non-popular in the market, Amazon.com should work their proper way. Okay, if not, there is a defect in that, right? So, but testing in so many number of environments is not a simple thing, right? A lot of planning is required, a lot of things are required, a lot of resources are required. You see, single environment only will take a lot of time for the software testers to complete their testing work. But if you talk about multiple environments, it's only possible by scaling up the resources. Okay, we need more resources to test the software in different test environments, which is a challenging thing. Okay, not always the client will give you the enough number of resources to test, right? So a kind of challenges you may face where, right, you have limited time, and you have big list of environments, and resources are limited, and how do you plan that? That is a challenge. Okay, that's a kind of challenge you may come across. Fine. Next one is, as I already mentioned, less time for testing. Okay, in case of test environments, also if you have multiple test environments and if you have limited time, can you complete the testing? No, right? That's one of the challenge. So similarly, there are many reasons. Okay, there's only one reason for the less time for testing. Environments is only the one reason for less time for testing. There are many other reasons for less time. That is, sometimes what happens is the application build. Okay, the testers have to test an application build given by the developers, right? Without the developers giving us an application build for testing, we cannot proceed further. But what if, okay, the let's say there is 10 working days. In the 10 working days, the developers themselves have taken 7 to 8 days, and the last 1 or 2 days they are giving the application build for testing. Is it possible for the software tester to complete testing in time? No, right? That's another challenge that I have also faced. Like developers will give the build late and they expect us to complete the testing. Okay, so because some projects follow the process, some projects don't follow the process. Okay, things will go like that in the project. So that kind of challenges we may face in real time, where developers will give the build late, and the testing team is pressurized to complete the testing on time. Okay, so you have to work overtime and all, and the process problem with the process and all. Okay, that kind of challenges software testers may face in real time. And as I already mentioned, testing in all test environments need multiple resources, right? Because why multiple resources are required? Time is limited, right? To complete the testing in time, in that specified time, more resources are required so that they can share their test environments and parallelly work. But what happens in real time? There may be some project teams where there is no proper process, and resources are pressurized. They are expected to complete testing in multiple environments in less time. Okay, so ultimately the resources will get pressurized, right? Less time for testing. Then tight deadlines and work overload. Same thing as tight deadline. Okay, you have to complete in the build is given in late, or environments are more and less resources are there. What happens? Tight deadlines, you have to complete by today, you have to complete by tomorrow, and you have to work overtime and you have to overload yourself. Okay, so that's the problem. This kind of challenges software testers or face, guys. Okay, in most of the projects. So regression testing is not always possible to finish in time. Why regression testing is not always possible? Before you complete the testing, guys, they will give you another build. Okay, you see, you tested one, you are testing one build, and for that you reported some defects immediately. Before you completed the entire testing before you perform regression testing, that is by executing all the test cases of that particular application from start to end, right? Before that process completes, developers will come the next day and say that, okay, yeah, another version is ready, just switch to another version. What happens in that case? Again, you have to start from the beginning, right? First test case you have to start, and regression testing will go on, and before that completes again another, again the developers will give you another version. So this process repeats. So is it possible for completing the regression testing in time when the developers are keeping on giving new build for you for testing and all? That's not possible. So what is the solution then? The solution is, if the project is a long term project, okay, if in case the project is a long term project, we can go for a one solution, that is automation. Okay, automation can be one solution, where, right, if that is a long term project, and then parallelly while we are testing, we'll automate some scenarios, the regression testing scenarios will be automated, and we'll focus on the important works. Okay, what need to be tested, we have to test. What are the stories we have to perform testing? That stories will focus on testing, but we cannot test the entire regression suite, right? So automation will cover us in terms of day-to-day same to same testing that we generally do as part of regression testing. That will be taken care by automation, while you focus on the important things or new requirements, new functionalities that are added, or new changes happen to the application. That functionalities you can test. That is one solution. And other solution is, if less time is there and more test cases are there, we generally follow a risk based approach. Okay, still the challenge is there because you will not be able to test the entire regression suite, right? For every build you cannot test it. That's the problem. Only the way is to solve it by automation, or you have to and also along with that you have to follow risk based testing, where high priority test cases you have to test first, and then low priority test cases. Okay, fine. Then we have other thing, guys. Okay, less time for testing is a major challenge. Test environments is a challenge. Setting up and testing across multiple test environments is a challenge, and less time for testing due to several reasons. The testing team will not get time for testing that. Okay, testing the entire application, or giving confidence in that they have tested the application properly. These are the challenges. Okay, these high level things. These are the reasons, and these are the high level things that you can state in the interviews, like challenges faced with test environment, challenges with less amount of time given for testing team, how do we resolve, and all we have to explain. And another main challenge that software testing team may face is lack of communication from the client side. You see, you'll be testing, but on what basis you will be testing? Whatever the requirements the client is specifying or giving, right? Based on that, you are testing. But what happened is, you have some doubts about the requirements, or the requirements are not clear. The client team has not communicated the things well without giving the demo or something they are asking you to test. You are in trouble, right? Lack of communication is a problem, guys. Requirements are not shared to you. Okay, they are expecting you to decide something by yourself and perform testing. That's a bad thing. Ambiguities in requirements. Okay, confusions, lot of doubts are there, and on the top of that, there's no proper point of contact for clearing the doubts. No one is clearing your doubts. What happens then in this case of lack of communication? What happens is, testing team, including the development team, okay, will assume few things. Okay, because the client is not communicating well, so you have to assume something, and think that this is right. Okay, this is right or this is wrong. You will think by yourself and perform testing. That may not be correct always. Whatever the decisions you have taken may not be correct. Lack of communication is a another challenge that software testing team will face, because the project all depends on client to client. If the client is not responding to you properly, or not clearing your doubts, or is slow in responding, right, or not giving a proper requirements for testing or something, then in that case, that is a challenge for testing team, because they may, even testing team will assume something and make mistakes. Okay, that will result in a wrong product getting developed and tested. Okay, testing will happen in a wrong way in that case because of lack of communication. That is another challenge the software testing team will face while testing a software, okay, application. Lack of domain knowledge. Okay, so not always the testing team will have the enough knowledge for testing the application or understanding the application, right? For example, you are testing an e-commerce application so far, but suddenly the next project you got a banking application, banking domain application, but you are new to banking domain. Okay, you don't know the much terminologies of banking, and you are not able to understand the functionality of the banking software application. So what happens? That will become a challenge. Okay, in testing, testers will not be able to test the application because they don't have a proper domain knowledge of the application. Okay, so lack of domain knowledge also. Okay, so sometimes the training is required, or we have to do our own R&D and do that to overcome that problem. But a lack of domain knowledge is always a challenge for software testers while performing the testing. Then lack of skills. Okay, not only domain knowledge but lack of skills. So if you are asked to perform different types of testing, okay, let's say you are only into UI testing, suddenly the client side they are asking you to perform API testing. You are new to API testing. Okay, lack of skills will be a challenge for because without having the knowledge of API testing or prior knowledge of doing the API testing, you're directly doing the API testing or performance or security testing or whatever the different type of testing asked by the client. Suddenly it will be a bit challenging for the testing team for sure. Okay, either they have to be trained, or right, it will take time for to get adjusted. Then automation tools, there are several automation tools available in the market, and let's say you are not skillful in that automation area, and if you are asked to perform automation testing, it will not be possible, right? You cannot write automation scripts directly. You have to learn it. You have to, okay, you should have some experience and all to do that. So lack of skills is always a challenge for the, because every project, right, you will get a different requirement most of the times, right? And one time you will get one domain in one project, you will give You have to work on different tool, different programming language. Okay, so skills matter here. Lack of skills and lack of domain knowledge, lack of communication is always a challenge for the software testers. Okay, then another last one, guys, last one I'm going to explain is, though there is very big list I can create out of this. Okay, whatever the important one, what are the whatever the key challenges that I really face, because whenever you get an interview question, right, you should not answer in a theoretical way. So whatever the answers I prepared here are my own. Okay, I felt like this will be these answers will be better for you to answer in the interviews. Okay, because this I have really faced it. Okay, I have really faced these challenges. That's why I prepared this. Okay, your version may be different, but there may be a lot of challenges that software testers may face apart from this that I mentioned here. So, but I'm not providing the complete list here. So, whatever the challenges I feel are critical by myself, I am giving the answer. So, assuming that you're also on the same track. So, complete testing is not possible, guys. Okay. So, sometimes what happens is 100% testing is expected by the managers, okay, or the clients. Are you sure that you have tested the application completely? Okay, the manager will push you to test the application. Is it possible really to do the complete testing, or exhaustive testing is possible? Not at all. Our job as software testers is only to identify the defects. Okay, identify the defects and get them eliminated from the application by getting this particular defects fixed by the developers. We'll try our level best. Okay, we'll try our level best in finding most of the defects and getting them eliminated. But no one can 100% say that the application is 100% defect free or 100% tested. No one can say. Even though your manager pushes you, okay, or your client pushes you, you cannot do that actually. So the challenge here for the software testers is to educate this, okay, to educate the managers or the client, saying that 100% testing is not possible. Okay, so they may feel that, okay, you are arguing with them, right? The moment you say, they ask you 100% testing should be completed. Okay, so you have to test it completely, I should not see any defect. If they say, it will be a bit challenge because different clients will behave differently with the teams and all, and it's not every client will understand you. Okay, they have their own version, their own way of dealing the stuff, so it may not be possible always. Okay, but our side, this is a challenge, right? There is a challenge that we cannot communicate properly to the client, saying that or the managers saying that complete testing is not possible to them. Okay, that's a big challenge for every software tester face this challenge. Okay, but to ourselves at least we have to understand that 100% testing is not possible, and identifying each and every defect in the software is not at all possible. Okay, we'll try our level best in reducing the risk of software after it gets released into the market by identifying most of the defects that can be identified by the testing team before the releasing the software into the market. Okay, that we can assure, but we cannot 100% say that you cannot find a single bug after this release. Like that, you cannot say, anyone cannot say, and we cannot educate the managers or clients because they are at a higher level than the testing team at that point of time. So that is one another challenge we can say. Okay, so hope guys you got a different list of okay, key challenges that a testing team may encounter while testing a software. So with this note, hope you got the answer for this question, and you now know how to answer that if you get this particular question in the interviews. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 133. That is, what is automation testing? Let me answer. Testing performed by automation testing tools on behalf of a tester is known as automation testing. To understand this automation testing in a better way, let's compare manual testing with automation testing. In case of manual testing, the software tester will be performing the testing. Okay, a real person, a human being will be performing the testing without using any automation testing tools. That's what is called as manual testing. But coming to automation testing, here automation tool will be performing the testing on behalf of a tester. That is called as automation testing. But how can an automation tool perform testing? Can automation tool perform testing by itself? Not possible, guys. Without the help of software tester, automation tool cannot perform testing. Behind this automation testing tool, there will be a software tester who will be writing the automation code, who will be developing or writing the automation code. After the software tester develops this automation code, this automation code will be passed to the automation testing tool. And automation testing tool will run this automation code developed by the software tester in order to perform automation testing. Okay, in order to perform testing, automation testing tool will run the code developed by the software tester. This is how the software tester is required. Okay, for an automation testing tool. Automation testing tool cannot work by itself. Okay, behind this we need a software tester who need to write the automation code, and automation tool will use this automation code to perform software testing, that is automation testing. Let me give a small demo of this, how automation testing is performed. Okay, using automation tools and how the software tester will develop the code and all. Let me give a small demo. So here we have this Visual Studio ID, and inside this is an ID, guys. It is an editor kind of thing. Like we have Notepad, Notepad plus plus, or whatever, WordPad or whatever it is, right? Where we can write something, right? Similarly, we have an advanced editor like Visual Studio ID. So only one of the example, guys. Okay, we have, if you're working on different things, we have other IDs like Eclipse, IntelliJ. Many platforms are there. Okay, many types of IDs are there. In whatever the example I'm trying to give you, I'm using the Visual Studio ID. So inside this Visual Studio ID, I have written some code. Okay, using this editor, I have written some code in Selenium C Sharp. Okay, for this example, I am writing Selenium C Sharp. You can write in Selenium Java, Selenium Python, and so on. But here in this example, I have written the Selenium automation code using C Sharp programming. And this automation code is written by me as a software tester. Without software tester, this code cannot be developed, right? I have to write the code. After I write the code, what I will do, I have to pass this automation code to the Selenium automation tool. But where is the Selenium automation tool? Selenium automation tool is configured with this Visual Studio ID only. Okay. So in this Visual Studio ID, I configured I don't have to show you practically here, but this Visual Studio ID is now configured with Selenium automation tool. So my code will be run by that Selenium automation tool. Okay. So how to run? So here I'll select this. After passing the code to the Selenium automation code, we can write like this. Okay. We can run like this. The Selenium automation tool will run this code, and you will see when I run the Selenium automation code here, you will see that the script will be running. Just see, the script will be running. It will open the Chrome browser in a while. Automatically, guys, I'm running the script here. So let's see whether script is running or not. Yeah, it's running, guys. The script is running. Let's wait for some more time. So you see it started. You see automatically the Chrome browser got launched. It got maximized. It has browsed the application. Okay, so you see, I didn't do anything here. I didn't open the browser and all. Okay, all the things are done by the automation tool only. As you can see here, these are the 3 lines of code I have written. Though you don't know what is Selenium automation at this point of time, you may or may not know, but just see here what's happening is this particular statement is opening the Chrome browser. This statement is maximizing the Chrome browser. All the instructions are written by me in the programming, in a programmatical way, and this particular statement is browsing the application URL in the open browser. Okay, so like this, I have to give the instructions using some I have to write some instructions in the form of code, and this code need to be passed to the Selenium automation tool, which is configured in this IDE. And when I run this particular code using Selenium automation code, which is configured in the Selenium this Visual Studio IDE, then my script is running like this. Automatically browser is opening, and this is what is called as automation testing. Okay, this is what is called as automation testing. Here automation tool is performing the testing. I'm not performing the operations. Automatically the automation testing tool is based on the instructions or automation code written by the software testers. Automation testing tool is opening the browser, maximizing the browser, browsing the application URL, and many other instructions can be given. And this is how the automation testing will be performed by the automation testing tool on behalf of a tester, and this is called as automation testing. Okay, so hope guys you got the answer for what is automation testing in this session. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 134. That is, what is the advantage of using any bug tracking tool? Let me answer. By using any bug tracking tool, we get different benefits and advantages. Let me explain them one by one. The main advantage or benefit of using the bug tracking tools in the project is the bug tracking tools automate the manual process of reporting defects. Assume that in a project, the software testers doesn't have any bug tracking tool. So what they have to do, where they have to report the defects? They have to report the defects in some kind of files like Microsoft Word. Okay, some Word documents or Excel files they have to use to report the defects. Okay, they have to report the defects manually in the Word document or any Excel files or any other type of files. Okay. So, but if you have a tool, what is the benefit? It automates the manual process of reporting the defects. Okay. So the tool will give you a lot of benefits, which will make your process of reporting the defects easily, right? The tool automates a lot of processes that are involved in manual way of reporting the defects. In manual way of reporting the defects, guys, if you have to really report a defect into a Excel file or Word document, right, you have to create your own table. You have to create different headings and different sections. You have to organize the elements and all. Okay. If you want to put a screenshot, again, it is a difficult activity. A lot of things will be involved if you have to create your own template for reporting the defects using some Word documents or Excel files. But if you use any bug tracking tool, all this will be provided automatically, right? So automatic way of, you just need to select the option from the drop down. Such kind of things will come in the tool, which doesn't come in the Excel files or Word documents, right? So for example, if you want to set a severity level for a bug, okay, in the Word document or Excel file, how do? You have to create a field and then write you have to create a section for that and you have to draft it, you have to format it. But all those headache is not required in the bug tracking tools, because tools generally automate the processes. Okay, manual processes. Fine. So, and using these bug tracking tools, the defect reporting will become easy. Okay. So you don't need to focus on formatting and organizing the defect details. Okay. If you have to report a single defect, right, it will be a lot of headache without bug tracking tools, because you have to create all the structure again and then you have to remove that and again add the titles and all those stuff. That is very difficult. So defect reporting will become easy, and also you'll get all the options. Okay, the UI wise beautifully designed and all options which makes your job easy will be there in the bug tracking tools, compared to the manual process where you create or report the defects into a Word document or Excel file. Okay, which is very difficult process. Now tracking is very easy. Tracking, for example, if you have 10 defects, you can track easily in a Word document or Excel file. But in a defect tracking tool, even though you have hundreds of defects, you can filter them. You will be provided with a lot of filters. Okay, filter by severity, filter by defect ID, filter by typing some text and figuring out some matching text, and then which will result in the number of defects which are matching with that search text. All these things are possible with the help of bug tracking tool. Tracking is very easy. How many defects are closed? You can track the defects based on the defect status and all those stuff. Okay. Then on the top of that, on the top of tracking the defects, there is other advantages are better collaboration and communication over defects. Okay. Here we get better collaboration. That is, developers and testers can collaborate very well over tool. Okay. So they can communicate, they can put comments, they can change the statuses, and the once the tester reports the defect, then developer will work on the defect. And during this process of testing or developing, right, they do a lot of conversation over the tool itself. Okay, they don't have to come and meet and talk. Okay, or they don't have to set up a meeting to discuss over the defects. All the communication will happen in the tool itself. Okay, so they will chat like chatting in a WhatsApp or something. Over the tool they will chat. Okay, there will be comment section, and a lot of other things are possible, guys. Okay, so comments and sharing of information is possible, right? They can comment and they can share information, like they can help each other, they can collaborate each other properly. The discussion happens fruitful way using the tool. Then auto notifications, guys. Okay, so communication, a lot of importance is given for communication. This commenting also comes into communication, and also notifications. Whenever a tester reports a defect, automatically the developers will get notified. Whenever developers fixes a defect, testers get notified. Okay, not only developers and testers, other people involved in the project also gets notified automatically over emails. Okay, that is possible with the help of bug tracking tool. Then defect status can be updated in a normal Word document or Excel file. If you are reporting the defects, it's not easy to update the defect status, right? Once the developers have fixed the defects, they cannot change the status from one state to another state. Here we have different defect status as per the defect life cycle or bug life cycle. We have new state, assigned state of the defect, rejected state, deferred state, in progress, fix. All the statuses of defect can be updated only when you use a tool. Without that, it is not that much possible. Okay. Then different type of reports can be generated along with metrics. You don't have to spend a lot of time in creating different reports. Okay. The bug tracking tools, most of the bug tracking tools comes with auto generation of reports, where just with a few mouse clicks, it will generate a report for you, which will give you all the analytics of the defects related to defects, like which functionality has how many defects, how many um, this severity type of defects are there, which severity type of defects are there. Okay, so what is the current status, how the defect trend is going on, all these analytics kind of reports can be generated with the help of bug tracking tools. Okay, which will take a lot of time if you have to do it manually, right? To generate this to create this kind of reports using this manual process. If you want to create reports, that is not so easy, but tools will do it on a click. Okay, just say generate, it will generate for you. Okay, select the proper option and say generate, it will generate the required reports with the required analytics and metrics in fraction of seconds. Okay, and many other benefits are possible with the help of bug tracking tools, guys. I don't want to answer this question in a vague manner, like these are the benefits of using the bug tracking tool. So with my experience, what I have observed, right? So what are the with my real time experience where I have worked, right? I observed these are the benefits I felt. Okay, where tools, any purpose of any tool is to automate the process. Okay, automate the manual process. Okay, so what is the use of using a calculator? The calculator will make your calculation easy. You can also do it manually, right? One, if you say 100 plus 360, what is the answer? You can do it manually. Okay, you can say 460, you can say. But if you use a calculator, what is the use of calculator? It will automate the manual calculation process, right? The calculator will automate the manual calculation process. You don't have to put a pen and paper and then calculate. Okay, by using calculator, it automates. Similarly, the tools will automate the defect reporting process. Bug tracking tools will automate. So everything will be automated. You just need to enter title into the title section in the bug tracking tool, and all everything is automated for you, and you just need to say create, and bug will be created in the all this automation process is there. With any tool, automation will be done. Bug tracking tools will automate the process of reporting the defects. And easy way of, okay, if you don't use any bug tracking tool, it will be very difficult for you to report the defects, share these defects with the developers, and communication will be a bit difficult, right? But bug tracking tools make that particular process easy. Reporting process, communication process, collaboration process. You will be notified. Okay, you don't have to send an email separately to the developers or testers to say that this is the status of the defect, and every day you don't have to maintain that. Def- defect reporting to defect tracking tools or bug tracking tools will do that. Tracking, again, tracking, I told you, and status updation is possible, reports is possible. This kind of benefits you will get with the bug tracking tools, guys. Okay, these are the benefits. So if you answer this kind of realistic way, if you answer this question right, then the interviewer will be satisfied. Otherwise, you write, if you give bookish answers, okay, if you search on Google about the same question, you will get a lot of answers, but those are not that much. Okay, the interviewers can easily understand that you don't have the exposure to reporting, defect reporting, and all. Okay, so if you can answer this way, okay, if you can give this kind of benefits, okay, then you will be good. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.
Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 135. That is, what is positive testing? Let me answer. Testing performed to verify the working of the application for expected conditions by using valid inputs is known as positive testing. To understand positive testing in a better way, we have to compare positive testing with negative testing. In case of positive testing, we verify or test the working of the application for expected conditions by using valid inputs. But in case of negative testing, we verify the working of the application for unexpected conditions. Here expected conditions, here unexpected conditions, we are going to verify. Okay, by using valid inputs here, by using invalid inputs in case of negative testing. So hope guys you understood what exactly is positive testing, okay, when I compare that with the negative testing, right? So let me give a small demo of what is positive and negative so that you can understand even more better. So I'll take you to one sample application. So let's say I'll take you to the login functionality of this application. For example, if I have to do positive testing on this login functionality, how do I do? I have to verify the working of the application for expected conditions. What is expected? What the user will do when he or she comes to this login page? Generally, users will provide the valid credentials, right? To log into the application, okay? The expected condition is valid credentials they will provide and try to log in. So if they are able to log in, or whether the user is able to log into the application or not with expected valid credentials, is something we test according to the positive testing. As part of positive testing, we test the login functionality like this. But what about negative testing? If I again go back to the login functionality, so as part of negative testing, what we'll do, we'll try to test with unexpected conditions. Okay, the user, we are not expecting that user will do something like this. Okay, such kind of testing is negative testing, guys. Okay, so here user may be giving valid email address, but user may give invalid password. Okay, these unexpected by the user. Okay, no, we don't expect that user generally gives this invalid password. Okay, so so in that case, how the application is working? Application should not allow the user to log in because the provided password is wrong. Okay, is an invalid. Similarly, even though the password is correct, the user may enter invalid email address. Okay, if I enter some random email address and try to log in, this is also another expected condition where the application should not allow the user to log in. Okay, then sometimes users will be very crazy where, okay, they don't provide any credentials and still try to log in to see if the application is allowing or not. Okay, that is too much invalid. Okay, so it's like unexpected conditions, all these are unexpected. So application may not be expecting this kind of behavior from the user where the user will try to enter invalid email address, invalid password with don't give any credentials to log in. All these are unexpected conditions. Testing such kind of unexpected conditions is called as negative testing. Okay, by using invalid inputs, if you are testing the verifying the application for unexpected conditions, that is negative testing. But if you are verifying the working of the application for expected conditions by providing the valid inputs while testing, is called as positive testing. So hope you got some idea with this example. Now let's understand more about this positive and negative testings. Okay, so we have to perform. So during testing, guys, do we have to perform only positive testing or negative testing? What is required? As software tester, we have to perform positive or negative. We have to perform both, guys. Okay, as part of software testing, we have to perform both positive testing and negative testing. And also there are other things you have to consider while performing the positive and negative testing. You have to know about positive and negative testing. That is, negative testing will be performed after positive testing is completed. First, generally, whenever a software tester is performing the testing, first the software tester will perform the positive testing. Okay, that is how the application is working for expected conditions using valid inputs. The software tester will first test. After that cases are completed, then only the tester will go for the negative testing, where the tester will check the working of the application for any unexpected conditions by using invalid inputs. Okay, first negative, first positive testing. After that, negative testing. Okay, then so negative testing uncovers the defects which are not covered by positive testing. Okay. So negative testing uncovers the defects which are not covered by positive testing. Sometimes positive testing will work very fine. It doesn't mean that the application functionality is working well. So when you perform negative testing after the positive testing is completed and positive testing has not resulted in any defects in the software, okay, but negative testing may result some defects in the software. Okay, so that's why negative testing need to be performed after the positive testing to uncover the defects which are not covered by the positive testing. And also it increases the test coverage. Okay, when you perform both positive and negative testing as part of software testing, the test coverage will be increased. Otherwise, it is partial testing only, have not done the testing completely. Then negative testing takes more time than the positive testing. You see, valid inputs will be limited, but invalid inputs will be many. Okay, that's the reason. Okay, expected conditions will be limited, but unexpected conditions may be many. Okay, they will be less. Expected conditions will be less. Unexpected conditions will be many. That's the reason negative testing takes more time than the positive testing. So these are all the things that I want to explain as part of the positive testing and the difference between positive and negative testing, and what are things you have to know as part of positive and negative testing. So I wanted to cover that. So that is done, guys. Okay. So hope guys you understood what is positive testing now and how to answer this if you come across this particular question in the interviews. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 136. That is, explain about usability testing. Let me answer. Testing how easy or friendly the application is for the users to use is nothing but usability testing. So what is the advantage of performing the usability testing and why we have to test whether the application is easy or friendly to use? So the advantage of performing the usability testing is we can identify the functionalities in the software application where the user gets stuck. Okay, what are the difficulties being faced by the users while using the application? Okay, are there any difficult functionalities in the application which are causing the users to get confused or users to get stuck while using the application? We can identify. That's what is the advantage, guys. Okay, so there is a checklist I have prepared here. Okay, so let's go through the checklist. Okay, list of different items that we'll be generally testing as part of usability testing. Okay, so this is a checklist that generally while performing the usability testing, we have to perform checking on the application. Okay, first thing is text present on application should be easy to understand. Okay, so if you go to any application, let's say, let's go to this sample application. You see there will be a lot of text, right? If I take you to this login page, you see there's some text here. Are you able to understand this text? Is this particular text written in an easy language or not? Or any complex terminologies used in this text? We have to identify that. Okay, not only this particular text, any text, the text that you see on the buttons or the label text or heading text, all the text that is there on this application should be easy to understand. Okay, it should not be complex. The complex terminology should not be used. Instead, the text present or shown on the application pages should be easy to understand. The user should not go and search on Google to find the meaning of such kind of words written on the application. Rather, it would be better if the terminology used is easy to understand directly by the users. Okay. So then next one, next item that we generally check as part of usability testing is users should be able to find and access the components whenever required. Okay. So for example, if you go to this application, okay, let's say you went to this application and you want to search for a product, and if you are not able to find the search box field, that's a problem. Okay, so it should be easy for the users to find the functionalities whatever they actually need. Okay, suppose in at this situation I want to search for a product, but if I'm because of the design or whatever that is, okay, because of the way the application has been developed or the poor design or UX user experience is there, because of that if I'm not able to find this search box field, that is a problem. Okay, so users should be able to easily find the required functionalities. Okay, for example, the users want to go to cart, how to go there? Okay, they should find some functionalities. Okay, it should be very easy for the users to guess where the functionalities will be there and should be accessible and all. Okay, so that's what we are going to test next. Okay, there's another checking. Users should be able to find and access the components whenever required. Okay, it should be easy to find the required at any point of time. The required functionalities the functionalities that are required for the user to perform some operation, right, should be able to easily guess and find them and should be able to access them. Okay, that's what is another checklist. The next one, users should be able to understand the purpose of using the software. If I'm using the software, I don't know what is the purpose. Okay, despite of using all this functionality of the software, if the user is not getting a purpose of using it, okay, so why we generally use this kind of applications to purchase something online, right? It is an e-commerce application. Anyone can understand by looking at this application, anyone can understand that it's an e-commerce application, that different products are being sold by different sellers, and we can purchase them online. As an end users, we can purchase these products online. Okay, so if you are not getting some that sort of purpose by looking at this application or while using the application, there's some problem with the usability that we have to report. Okay, so this is the third check. Then we have another item in the checklist, that is proper help messages should be displayed wherever required. Okay, the proper help messages should be displayed. So these help messages will make the job of the users easy. Okay, while using the application, users should not get stuck or confused on what to do next. Okay, but with the help of the help messages, we are making their journey easy or user friendly, okay, to use the application. So a few examples I'm going to give you is the first one is a placeholder, guys, placeholders inside the form fields. If I take you to this register page, you see there are a lot of fields here in the register account. So here label is there, but despite of the label, you see in the inside the text box field in a gray out format, you see the first name text is there. Okay, this is placeholder. Whatever the text that you see inside the text box field by default, but when you start typing, the placeholder text will go. Okay, here if I want to type my name Arun, okay, like this, okay, the placeholder text is going. But if I remove that again,
This is a helper text. Okay, so we are helping as much as possible to make the usage of the end users. Okay, some people may think that what is the use of placeholder, but there may be some people who need to be educated that your first name should be entered in this field. Okay, you have to enter the first name in this field. To make that possible, we have to add this placeholder, which is a helper text indirectly. And not only the placeholder text in the form fields, but also proper warning message should be displayed when user makes a mistake. For example, guys, if the user is making any mistake here, the user is entering some email address and unexpectedly user has entered a wrong password. Okay, so user thought that it is a correct only, but when he entered, but he or she ultimately entered a wrong password and click on the login button, a proper warning message is coming. Okay, this warning message is helping the user in understanding that, okay, the user has provided some wrong email address or password here. Okay, so that kind of proper warning message should be there wherever required, so that user should understand what is a mistake they have done. Okay, that warning message will point out the mistakes made by the user and correct them in providing the proper details or using in a proper way. Okay, using the application in a proper way. Then tool tips are provided wherever required, and we have to check whether these tool tips are really helpful for the user or not. Okay, we should see whether the application is providing the tool tips wherever required, and on the top of that, are these tool tips really helping the user in using the application, in making the application easy to use for the user or not. We have to check. For example, guys, if I take you to this homepage or something, you see there are some products displayed here, and you see add to cart is explained here. Okay, the add to cart icon is there and beside the text is there, but what about these symbols? Some love symbol is there, and some uh, uh, different direction arrow symbols are there. Okay, these symbols, if I don't if we don't provide the tooltip here, can anyone understand what is this symbol all about? No, right? Here you see add to wish list. Now users can understand, okay, if I select this option, this item will be added to my wish list. Okay, and if the users hover the mouse on this two directional arrows, okay, which is going in different direction, you see compare this product is coming. That means this option will help the user in comparing this product with other product, like that users can understand. Tool tips should be there wherever required, and also they should be useful for the users. They should guide the users properly. They should explain the functionality of the application to the end users to make their usage of the application easy. Okay, that's what this kind of proper help messages should be there, displayed wherever required, like placeholders, proper warning message, tool tips, and many other things will be there, guys. These are the important ones. Okay, then look and feel of the application should make the user comfortable in using the application. When you use an application, it should feel good. Okay, the user should not get confused by look and feel. Okay, so you see this application looks good, well good, right? If I go to the login page, I can see, you see, if I want to log in, and if I don't have the credentials to log in, I can create an account. Okay, the application is, the layout and look and feel of this application is very good. Okay, so like that, it should be, look and feel of the application should make the user comfortable in using the application. It should not disturb the user. Okay, you should not get confused because of the look and feel. So is a design, okay, all these things we are going to check as part of this checklist item, that is design neat? Okay, is whatever the design that is done for this login page is neat or not? Okay, it looks good or not? Okay, that's on one check. Is it clean or not? Neat and clean both are same, right? Clean, it should not be clutter. Okay, cluttery kind of thing, lot of information provided in a single page which will confuse the users. Okay, so the users should not feel that should not get frightened up by seeing a lot of functionalities in a single page. Okay, should be simple, neat, clean. Okay, kind of without any clutter. Should be clean, consistent, guys. Okay, you say design should be consistent. If whether you go to the login page or whether you go to register page or any other page on this application, you will see the similarities. Okay, you will see the same breadcrumb is there in the register account page. You see the breadcrumb for navigation is also there in the login page. Breadcrumb also adds the navigation point of view in case of user friendliness. Okay, usability testing point of view, the breadcrumbs should be there. Okay, that can be another checklist you can add here, guys. Okay, so proper I can add like this, proper breadcrumbs are provided. Okay, breadcrumbs help you in navigating better. For example, here if I go to any other page, like forgot password page, and if I want to come back to the home page, if I click on this, am I getting back or not? Navigation. Okay, so proper navigation. So breadcrumbs support the proper navigation, guys. Okay, whatever that you are seeing here on the pages, okay, this part is a breadcrumb and will help in navigating easily through other pages. Okay, so a user should not get confused like how to go to the home page from this page. Okay, so with the help of the breadcrumb, the user will click on the home icon on the breadcrumb and should be taken to the home page. That's fine. So then consistency is what I talked about, look and feel, and pleasant. It should be pleasant, okay? So it should not be disturbing. The visuals or UI or UX of this particular pages should be pleasant. It should users should feel cool and they should feel like they want to use application. Okay, they want to use application more. Such kind of pleasantness should be there. All these things should be tested. Okay, so at least to be tried to make the application reach that level so that users will like it. Okay, so that's what is a usability testing, guys. Okay, so navigation to every component of the application should be easy. On the top of this look and feel, navigation should be easy, guys. Okay, for example, the user want to purchase some product, the user should not get confused anywhere or stuck anywhere. To purchase or place an order from this website, the user has to go through many functionalities, right? For example, here the user first has to log in. Okay, so whether user is able to log in or not, let's see. So after login to the application, user is taken to this page, and here the next item that user thinks to purchase an item is, after logging in, the user thinks that, okay, I need to search for a product. Okay, so user is able to search. After searching the product, search results are coming. Okay, search results page is connected now, and user want to check the details of this product. So user will click on these options and will be taken to the product display page. This is a product display page. User went there. After that, user want to take different decisions. Okay, whether user want to purchase right now or right, add to the wish list. Okay, want to purchase it later or compare this product with any other product. See, all functionalities are interconnected, and wherever necessary, the navigations are properly provided, details and all those things are properly provided. If user says add to cart and user doesn't know what to do next now, okay, you see a proper message is coming, highlighting message is coming saying that successfully I've added to your shopping cart and link is there. So user is hinted indirectly that you can go to shopping cart. Okay, you see, that's how we have to make the journey of the user bit user friendly, or we have to make the application easy for the user to use. Okay, after going here, you see, um, update numbers and all, you see our proper tool tips are there wherever necessary, and a lot of functionalities are there here which are supporting the user in placing an order. Okay, so all the simple thing is that navigation to every component of the application should be easy. The next step should be fine. After adding the item to cart, if the user doesn't know what to do next, that's a problem, right? Users should know that they have to go to the shopping cart after adding the item to the cart. Users should know that they should go to the shopping cart. Okay, so an example I gave you already just now. So navigation part should be easy and should be driving the user in using the application to do the activities that the user generally want to perform. Then uh, as part of usability testing checklist, guys, there's one more item, that is, can we make anything more easier user friendly? If you come across an functional application functionality where you feel like, okay, where as an end user, you as an end user, if you you'll be a tester, but if you have to be in the shoes of the end user and see that this functionality can be more easier, can be made more easier user friendly for the user, like that, if you think, you may get some ideas, right? Suggestions that you can give to make this application more user friendly for the user. An example I'll give you, guys. Okay, there may be some situation where, for example, let's say there is a net banking software. So you see, in a if you already know that in any bank account, okay, in a bank account, for example, just give me a second. So let's say there is a you opened a bank account. The bank may provide you one account, single account, or you can have you can hold multiple accounts in the same bank. Okay, and I'm taking a vague example here. Multiple accounts. Okay, single accounts or multiple accounts in the same bank. Single account or multiple accounts. So let's talk about the multiple account. What the This is net banking. NB I am writing net banking software. So what this net banking software people have done is, for the people who have multiple accounts, they have provided a drop down field. They have provided drop down field from where the user can select this drop down field, and all the list of accounts, multiple accounts the user is holding in this particular bank will be displayed here, and on which account the user want to perform operation, that account will be selected by the users, and can do the operation. This is fine for the multiple accounts. But what if for single account user also, if a particular account holder is having only one account in this bank and still a drop down field is shown, is it really required? There's no problem in having a drop down field because only one option. When the single account holder also selects this drop down field, only one account number will be displayed and still the single account user can select it. But the problem here is it really required? Okay, can we avoid it? Can we avoid it or remove it for the user who is having only the account holder is only having single account by directly displaying the account details here without asking the user to select an account number from the user? Such kind of thinking need to be done, because if this is really done for multiple accounts, definitely the drop down field is required, but for single account user, is drop down really required? Not required. If you remove that, that will make the that will increase or improve the easiness of using the application. So such kind of things also can be checked as part of usability testing. Can every functionality we have to ask a question, can we make this functionality even more easy or user friendly than that is currently right now? If there is a scope or possibility, as I explained in this example, then we can suggest that as part of usability testing. We can suggest that. Okay, and yeah, a lot of other things, other checklists will be there, guys, for usability testing, for performing usability testing. So you should not see too much white spaces. Okay, so again, look and feel will go bad if you use too much white spaces. Logo should is logo taking to the home page or not? For example, every application will have a logo. You see, I'm on some page. If I click on the logo, I should be taken to the home page. Okay, so navigation wise, the logo should be taken to the home page. So that also can be checked, and proper breadcrumbs are provided. I just now showed you, right, what are breadcrumbs and all. For every page, there will be a breadcrumb, no matter where you are. For example, if you go to my account and if you want, you see this is a breadcrumb. If you go to edit account information, if I want to go to account page, I can click on that and come back. Okay, the navigation wise breadcrumb will help you to go wherever you are. Even though you are on any page, directly you can go to the required, either from this edit account information page, you can either go to account page or home page also. Okay? Up to you. It makes more easy navigation, more easy and user friendly. Okay, and many more things are there possible, guys. Okay, so usability testing can be done even more in a detailed manner. These are the important ones. Whatever the checklist I covered right in this session is an important one. So with this, guys, hope you got an idea of what exactly is usability testing. Okay, testing how easy or friendly the application is for the users to use. Okay, with an intention of identifying the functionalities in the software application which are making the usage of the application difficult for the users. Okay, because of the difficulties, users may get stuck or confused while using the application. Removing such kind of difficulties and making the application more easy and user friendly to use is nothing but usability testing, and this is the example checklist. So hope, guys, you got the answer for this question now. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 137. That is, what is negative testing? Let me answer. Testing performed to verify the working of the application for unexpected conditions by using invalid inputs is known as negative testing. To understand this negative testing even more better, let me compare the negative testing with the positive testing. Coming to the positive testing, under positive testing, we'll check the working of the application for expected conditions by using valid inputs. But in negative testing, we'll check the working of the application for unexpected conditions. In case of positive testing, it is expected conditions. But in case of negative testing, it is unexpected conditions by using invalid. Here valid inputs, here invalid inputs. Okay. Here expected conditions, here unexpected conditions. Hope, guys, you got a better idea about what is negative testing now. Okay, let me give a small demo of this negative testing. So for that, I'll open an application. I'll take you directly to one page, that is a login page. So if you are testing this particular functionality in a negative way, how do you test? You will not provide any valid credentials here. Unexpected conditions. User may not perform this kind of operations. Okay, generally. Okay, such kind of things we have to perform testing. That's what we are calling it as unexpected conditions. Working of the application for unexpected conditions. You see what will happen if the user unexpectedly enters some invalid email address but valid password. Okay, valid password. So it should not allow, the application should not allow the user to log in. Similarly, if the user unexpectedly enters a valid email address but invalid password and tries to log in, still the application should not allow the user to log in. Okay, in some another unexpected conditions where the user will try to log in without providing any credentials. Okay, so that is a crazy scenario, you can say. Generally users don't do that. Such kind of unexpected conditions, okay, under which you are testing the application, the working of the application, right, by giving invalid inputs, that is called as negative testing. But in positive testing, but in a reverse way, that is positive testing, which is an opposite of the negative testing. You see here, whatever the user generally does in a proper way, that we are testing in a positive manner. Okay, that is called as positive testing. Here, if the user enters the valid email address, valid password, and tries to log in, if the user is able to log in or not, that is positive testing. But in negative testing, we are going to test the functionality, application functionality for different unexpected conditions by using invalid, by providing different type of invalid inputs to see how the application is behaving. Okay, that is negative testing. Okay, so as part of normal software testing, do we have to perform positive testing or negative testing? The answer is both. We have to perform both. Positive testing and negative testing need to be performed as part of software testing. Whenever you are testing an application, okay, you should not focus only on positive testing, or you should not focus only on the negative. We have to focus on both positive and negative, then only it will complete the software testing. Okay, you will cover the good software testing. So there are other things that I need to talk about this positive and negative testing. You see, first positive testing is performed, then negative testing is performed. So negative testing comes after the positive testing. Once the positive scenarios, okay, positive test cases are tested, how the user is going to application in a normal way by giving valid credentials is tested. After testing with the valid credentials and all in a proper way, how the user is going to use the application, after this is working fine, then only we'll go for the negative testing. Okay, where we'll try to give invalid credentials, invalid username, invalid password without giving credentials, like many other test cases which fall into the negative testing bracket. Okay, so first positive testing is performed, then only the negative testing will be followed. Then you see, negative testing uncovers the defects which are not covered by positive testing. Not all the defects will come from positive testing. Okay, after positive testing is completed, when you do negative testing, you may get more defects. Okay, so negative testing hence will uncover the defects which are not covered by the positive testing, which are not detected by the positive testing. And also, by doing both positive and negative testing, we can increase the test coverage. Only positive testing is a partial testing only. It will not cover the entire testing. But when you do both positive and negative testing, it will increase the test coverage and it will take you to the direction of completeness. Then finally, negative testing takes more time than positive testing. In case of, for example, in this example only, guys, when you have to perform positive testing, only one scenario you are getting where very less number of scenarios you will get where you see valid credentials. That's it. Okay. But in case of negative testing, you will get lot of unexpected conditions you have to test. What will happen if user enters invalid email address, valid password? That is one unexpected condition. What if the user enters valid email address but invalid password? And what if the user enters invalid email address, invalid password? What if the user doesn't enter any credentials and try to log in? Like that, many unexpected conditions we have to test. That's why negative testing takes more time than the positive testing. So guys, hope with this explanation, now you got an understanding what exactly is negative testing. So you'll be able, hoping that you'll be able to answer this question if you get this in the interview. That is what is negative testing. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 138. That is, what are different defect attributes? Let me answer. While we are reporting defects in different defect tracking tools or test management tools, we came across different defect attributes that have listed down here. Let me explain each and every defect attribute for you. First one is defect ID. Okay, it's one of the defect attribute. So defect ID will contain a unique number. Okay, it will be auto-generated by the tool most probably. Once you report a defect in any defect management or defect tracking tool, okay, after you submit the defect, the tool will generate automatically a unique number. Okay, the unique number can be used to identify the defect later. This is what is defect ID. Then we have the defect summary or title. So which is a brief description, okay, in just few lines of few words, you have to describe the defect, okay, in just few words, that is in a single line or something, you have to describe the defect, that is defect summary. Then we have defect status. What is the status of the defect, okay? What is the current status of the defect? When the software testers report a defect, the status of the defect will be generally in new state in some of the tools. And then if the uh, team doesn't accept the defect that is reported by the developer, then it will be moved to the rejected state, okay, due to several reasons. Or if it is accepted, and if it is accepted, it will be assigned to a developer. Then it will be deferred state if the defect can be fixed later. Then in progress state, if the defect has started fix, if the developer has started fixing the defect, and he may change the state from assigned to in progress. And once the developer fixes the defect, he'll change it to fixed state so that the software testing team can test it and verify whether the defect has been really fixed or not. Once the testing team verifies whether the defect has been really fixed by developers or not. If they really found that the defect is really fixed, they will move it to the closed state. If not, they will move to the, again, they will reassign back to the developers, and maybe the status will be in progress state later. Okay, these are the different status of the defect, guys. Okay, the current status of the defect will be mentioned in the defect status and will be changed by the testers and developers as per the current status of the defect. Then we have steps to reproduce. Steps to reproduce. Detailed description of the defect in the form of steps, like that software tester will be writing the steps to reproduce in a step-by-step manner. Like first, what we have to do to reproduce the defect. What is the second step? What the user has to do to reproduce this particular defect in the step-by-step format. The software tester will be writing the steps to reproduce. Detailed steps for reproducing the defect, and this steps to reproduce can be used by developer to reproduce the defect in her or machine. Okay, and then we have the expected result. So after following these steps, what actual result the application should result in? But what is actual result? But what is actually happening? This is the reason why the defect has been reproduced. After following these steps, okay, instead of getting the expected result, we are getting some other result. That some other result will mention in the actual result. Okay, since there is a difference between the expected and actual, the defect has been reported. Then additional information. Apart from whatever the information we have provided while reporting the defect, like defect summary, steps to reproduce expected result, actual result, right? If you want to mention more information about the defect, like that may help the developer in okay, fixing the defect in a better way or something. If you have any other additional information about the defect, you can provide it here. Okay. So then attachments, we have another section like attachments where we can attach the defect report. Sometimes we can attach the videos as a proof and all. Okay. Then assign to. So whoever the defect is assigned to at this moment. Okay. Sometimes when the software tester reports the defect first, it will be new state, and it may be assigned to some people, and okay, assigned to the developer, respective developer. So then if the software tester developer has fixed the defect, then the uh, the developer may assign it back to the tester. Okay, assign to will be changed by both developers and testers. Okay, according to the need to whom it has to be assigned to at that point of time. Okay, who need to take the ownership of this defect next? Based on that, assigned to will be decided. Then version, the version of the software in which the defect is found by the testers. Okay, that version number we will mention. Then functional area. So in which functional area, login functionality or logout functionality or search functionality, like that, the functional area in which the defect is found in the software. Okay, that we have to mention. Fix it in build. Once the developer fixes the defect, in which version of the software the defect has been fixed will be mentioned by the developer in this field. Then we have the severity. Okay, how severe it is, like it is a critical severity or high severity. What is the impact of the defect on the application? Okay, so how much severe the defect is, and priority, how much urgent it is to fix the defect. Okay, is an urgent uh, based on the urgency of fixing the defect. Okay, how much fast in what time we have to fix this defect, based on that. Okay, based on the urgency levels, we'll set the priority. Then reported by, who has reported the defect, that is which software tester. Okay, we have to automatically the tool will take this reported by whenever you are using some defect tracking tools, right? Because you, without logging into the tool, you will not be able to report, right? So the tool will identify that you are reporting, and automatically it will update this field. You don't have to mention separately. and there are many other fields, guys. Okay, these are the major ones, major defect attributes, but there are other things like test environment and many other, okay, many other attributes will be there. Test environment is one such kind of thing where you have to mention in which environment you have found this particular defect. Is this particular defect specific to any particular environment, or sometimes if it's not specific to any environment, you have to mention all environments. Okay, so these what are the different defect attributes, guys. So hope, guys, you got the answer for this question, and you'll be able to answer if you get this kind of question in the interviews. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 139. That is, what is retesting? Let me answer. Testing performed to verify whether the defects reported earlier are fixed by developer is known as retesting. So whatever the software testers have reported the defects earlier, if the developers are stating that these particular defects are fixed by them in the new version of the software, so what the testing team will do? Testing team will take the new version of the software and perform retesting to see whether the defects reported by them earlier on the older versions of build are now fixed by developers in the latest version of the software as stated by developers or not. Okay, that is what is called as retesting. There is one more name for retesting, guys. Okay, there is one more name for retesting, that is confirmation testing. Okay, so we can also call retesting as confirmation testing, but mostly we'll call that as retesting only. Okay, so hope, guys, you got the answer for this question, and you'll be able to answer this in the interviews. That's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 140. That is, explain V model. Let me answer. V model is one of the SDLC models. There are different SDLC models like waterfall model, then we have prototyping model, iterative incremental model, spiral model, V model, agile model, RAD model, and Big Bang model. These are the different SDLC models we have, and V model is one of the SDLC models. So what exactly is this V model? V model is similar to waterfall model, but has some differences. Okay, it's similar to V model is similar to waterfall model, but with few differences. So let me explain more about how waterfall model and V model are different. How V model is different from waterfall model. Okay, let me show you a diagram first, how the V SDLC model looks like. This is how a V SDLC model looks like. It looks in the form of a V shape only. Okay, so these are all the same phases that waterfall model has, but the major difference you can observe here is testing is introduced from the beginning phases only. If you talk about the waterfall model, if you if you know this waterfall model, in the waterfall model, the testing will come only after the development phase, right? First, requirements gathering and analysis phase will be there in the waterfall model, followed by we have the design phase, then we have the implementation, that is coding phase. After that phase only testing will come. Testing will not start from the beginning of the waterfall model, but in terms of in case of V model, testing is introduced from the beginning itself. All this red color, okay, red color activities are nothing but testing. Okay, all the red color shapes are nothing but the testing. That means testing is starting from the starting of this model, and here requirements are freezed, guys. Okay, so in the beginning only, similar to waterfall model, requirements are freezed here. Okay, in between the requirements will not be introduced and all. So requirements will be gathered and analyzed in the beginning itself, beginning of the project itself, but not during the project. So let me explain more about this V model now. So you see how the testing can be done from the beginning. You see, without the application is developed. Okay, after the coding only we can start testing, right, in general. But how testing can be done before the coding is completed? Yes, testing can be done in different forms where we can review the different activities here. You see on the left side of this V model, all these activities doesn't have any code or application ready. Okay, so in BRS, what will be there in BRS? Requirements will be gathered. Okay, BRS is nothing but the requirement document, right? So here requirements will be gathered and analyzed. But How the testing will be performed here without running any code. It's a static testing, guys, where the code is not run, but a type of testing known as a review will be done. Okay, these documents will be reviewed in different ways. There are different type of reviews that can be performed on this BRS document to see whether the requirements specified in that particular document are proper or not. Okay, are there any ambiguities in this document, or are there any mistakes in this document? We are going to test. We can test the documents. We can, without running the code or without testing the application, we can check the requirement document and find out the mistakes way before. And once the BRS document is properly tested, then SRS document will be created. Okay, technicals with technical specifications and all, the technical team will come up with a SRS document. Okay, so this SRS also can be reviewed. This document also can be reviewed. We will go through the document and find out the mistakes and identify the mistakes in the documents and all. Then low level, high level designs, we can also review the low level and high level designs without running the code, right? All this forms into the static testing. Okay, reviews fall into the static testing. And here during the coding phase also, the code can be reviewed. Without running the code, we can review the code, we can go through the code and find out the mistakes in the code. Okay, how the way the developers have written, we can find out the mistakes. Generally developers also will do the same review process. Okay, but we call that as testing. Anyhow, we will review the code. Okay, without running the code, we'll verify the code. Okay, there are some tools in the market which can review the code and give us some suggestions. Okay, here simple, guys, in the V model, the testing will start from the beginning. So here static testing will be performed before the coding is completed in the form of reviews. So we'll review the documents, designs, and the code that has been written without running the code. Okay, all this will be reviewed. That's the reason the testing can be performed from the beginning itself. Okay, by performing this different type of reviews on these documents and code without running the code. Okay, once the code is ready, all while the code is being developed, or some portion of the code is ready, then developers will perform the unit testing and integration testing. Okay, individual units. Okay, the entire code will be broken down into individual units where which cannot be broken further. Okay, such kind of small units they will break into, and that individual one by one unit they will test. Okay, individually the unit pieces of code will be tested as part of unit testing by developers. And after the unit testing is completed, developers will go for integration testing, well, where they will group the logically groupable units into different groups and test them as a group. That is integration testing. Okay, all the units will be combined logically. The logically groupable units will be combined together and tested to see whether they are getting integrated properly, I mean working together properly or not. Okay, so there are different type of approaches we follow in integration testing, like top down integration testing. Our developers will follow top down integration testing, bottom up integration testing, sandwich integration testing, and so on. Okay, big bang integration testing and so on. Okay, so then after this integration testing and unit testing are performed by developers, then here in the V model, as you can see, then system testing will be performed. Software testers will be performing the system testing, where they will be testing the entire system as a whole. Entire application they will be tested. The developers will be giving the application URL or exe file of the application to install and test. So entire application will be tested as a whole as part of system testing. Then we have, once the system testing is completed and all the defects, like whether the application has been developed by developer according to the given requirements or not, is generally okay verified by testers. Here the main focus of system testing is to see whether the developed application is according to given requirements or not. That is the main focus. But at some like not only that, whether it is according to the user needs and expectations also will be there, but less focus will be given to user needs and expectations. But once the system testing is completed, which is focusing on whether the developed application is developed according to the requirements, then it will be released for UAT. Okay, then it will be related to UAT, where alpha testing, beta testing, all this kind of testings will be performed. Okay, by the customers at the developer side, and by the real end users in case of beta testing and all. In UAT, different type of UAT will be performed, like alpha and beta. So as part of that, the customers will be performing this mainly. Okay, the testing, where the main focus of the testing of UAT will be on the end users needs and expectations, whether the developed application is meeting the end users needs and expectations or not. Okay, based on the feedback received from the users, the testing will be performed. Okay, here more focus is on user needs and expectations before releasing the software into the market. After UAT, after UAT is there, and after meeting the user needs and expectation, then the software will be released into the market. Okay, so this is what is a V model, guys. Here testing will start from the beginning. Okay, so the main thing that we have to understand about the V model when compared to other SDLC models or waterfall model is Here testing will start from the beginning of the phases only. That is what V model is famous for. Okay, V model is known for. Okay, so hope guys you understood what is V model and how to answer this V model if you get this question in the interviews. That's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 141. That is, what is ad hoc testing? Let me answer. Testing performed randomly on the application without using any formal or structured process is known as ad hoc testing. In ad hoc testing, the testing will be done in a random way on the application. And also there is no formal process or structured process followed while performing this ad hoc testing. In ad hoc testing, there is no need for any requirement documents. There is no need for test planning documents. There is no need for using any test case for testing because there is no formal or structured process followed here. Okay, that's why there is no planning and we don't have to use test cases. If you are using test cases means you are following a structured process, right? Your testing is driven by the test cases. But here it is a random testing performed without using any formal or structured process means there is no test cases required. There is no need to do any test planning, okay, or create any test plan or something to perform testing. And also in this ad hoc testing which is done randomly, we don't test by looking at the requirements. Okay, we don't have to verify the application functionality to see whether that application functionality is matching the requirements or not. It's not required. So all these things are not required as part of ad hoc testing. Here in ad hoc testing, it is performed randomly and there is no formal or structured process followed. Okay, that's what you can say. Let me give an example case, okay, for ad hoc testing. So let's say in normal testing, when you are using any test cases or if you are following some requirements, okay, let's say the client has given you a requirement where whether you are able to place an order or not is a requirement, okay. Let me go to an example website. So here the client has given a requirement for this application where to check whether the end user is able to place an order or not. Okay. So if I'm doing a process oriented or structured oriented testing by looking at the requirements and by following the test cases, I'll be doing like this. Okay. I'll be searching for a product. I'll be going to the product display page. I'll be adding the product to the cart. I'll go to the shopping cart. Then I'll check the details. I'll just check out and I will log into this. I'll log into one of the accounts and then after that I'll click on continue. I'll place the order. I'll check this process of you see a proper positive scenario. I'm checking whether the user is able to place an order or not. I'm checking. So this is happy pass scenario, right? Simply I'm able to place the order according to the requirement. If I'm writing the test cases and following a structured process by looking at the test cases which are following the requirements and performing testing, I'm getting the results like order is placing and the test case will pass. This is not ad hoc testing. But what is ad hoc testing? So let me give an example for the ad hoc testing now. Okay, let me give an example for ad hoc testing. So I will not only show you an example, guys. I'll show you a defect also. Okay, as a bonus, I'm going to show you a defect that I can find by doing an ad hoc testing on this application. Okay, so the same scenario where the according to the requirement have to place an order, right? Whether the user is able to place an order or not, we have to check, right? So if I have to perform ad hoc testing on this scenario, how do I perform? I'll simply search for HP here, go to this page, okay, go to this product display page, add to cart, shopping cart. You see one item is there. You can see that there is one item here. What if I press the back button here, browser back button here? What happening? The item is going off. This is a defect, right? Again, if I refresh the page, it's there. Okay. So if I go to the shopping cart, if I go to the shopping cart and click on the browser back button, okay. So what was happening at the time? 0 items was coming. Let me add one more item. Now after adding the item, go to the shopping cart. Now click on the back button. You see, instead of 2 items, 1 item is there. There is one bug here, right? Immediately after you add an item to the cart and go to the shopping cart and click on the browser back button, you are getting this. You are not getting 2 items, you are getting 1 item. Okay. So this kind of thing, this is only possible if you do ad hoc testing, guys. This kind of scenarios cannot be, you cannot identify this kind of defects or perform this kind of scenarios or testing cases when you create the test cases or follow blindly the requirements and all. Okay, we have to do some ad hoc testing which will cover the other paths. that happy paths are positive general paths that formal testing will do, right? Apart from that, if you want to do some more testing, then we have to go for the adapt testing, which is a random testing, guys. So we'll just on the path we decided what will happen. You got an idea, like after you go to the shopping cart after adding an item to the cart, you just got an idea what will happen if I click on the browser back button. Here we are making the testing randomized, and by doing something that we generally don't do, and we are identifying the defects also. Okay, this is what is adapt testing, guys. So hope guys you got an idea what is how adapt testing is performed, okay, and how it is different from the general testing that we perform. So there are types of adapt testing, guys. Okay, so under adapt testing there are different types, like buddy testing is there, pair testing is there, monkey testing is there. These are the three types of adapt testing. All these are random testings only. Buddy testing is random testing, pair testing is a random testing, monkey testing is also a random testing. Okay, I'll be answering this buddy testing, pair testing, monkey testing maybe in the other interview questions followed by this series. Okay, so maybe in the next few questions of this same interview question series, I may be answering about buddy, pair, and monkey. Okay, you just follow there. For now, the different type of ad hoc testing we have are buddy testing, pair testing, and monkey testing. Okay, and also when do we perform ad hoc testing? When do the software testers perform the ad hoc testing? What is the right time? Okay, so generally ad hoc testing need to be performed on stable builds. Don't perform the ad hoc testing on the unstable builds. Okay, so once the application build becomes stable, when formal testing is completed on that application, okay, generally as software testers we perform testing, and over a period of cycles the application that we are testing will go through a lot of versions and become stable over a period of time. Once an application reaches a kind of state where it looks like very stable, right, then that is the right time to perform ad hoc testing, because that time, right, by doing ad hoc testing we'll try to find out different paths where the defects which are not identified during the normal formal testing can be identified by performing some ad hoc testing, which involves random testing categories. Like just now I showed you an example, right? Such kind of defects may make encounter which cannot be found by the formal testing. Okay, so here, when there is less time, other situation when you have to perform ad hoc testing is when there is less time for detailed testing. Okay, so if you blindly follow the test cases and you follow some checklist and perform testing in a formal way, and there is very less time given, so the testing will not be done, right? So you have very less time. So in that case, in that kind of critical situation where you have to complete your testing, but you cannot complete using some formal testing process like using test cases and all, you cannot complete. In that case, one idea is to use ad hoc testing, so which where we have to perform the testing randomly and focus on the important functionalities and randomly test them here and there to see whether they are stable or not, whether are there any defects or not. We'll find it. Okay, without any plan or process, we'll perform ad hoc testing when we have less time. That's another situation. And another thing is when you are free. Okay, let's say you completed all the testing and you don't know what to do now. Okay, you completed all testing all the test cases, and you are getting a lot of time now. Okay, so you're completely free at that time. After formal testing is completed, if you are still free, then you can adopt the ad hoc testing. Okay, ad hoc testing should be performed on stable builds, and after the formal testing is completed, if you have some more time, then you can perform ad hoc testing. Or there may be some situations where very less time is to less time is given for the testers to finish up the testing. Okay, and you cannot follow a formal process. That much time is not there for following the formal process. In that situation, if you want to utilize that time, less time, then we can also adapt for the ad hoc testing. We can do some random testing and identify something. Okay, in that less time. So this is what is ad hoc testing, guys. In simple words, ad hoc testing is performed randomly, guys. Okay, if someone asks you what is ad hoc testing in the interviews or wherever, if someone asks you what is ad hoc testing, you have to simply answer that testing performed randomly on the applications is known as ad hoc testing. And in ad hoc testing, there will not be any formal process or structured process. Okay, followed. And in ad hoc testing, all these things are not required. We generally don't look at the requirements while performing the testing in ad hoc testing. We don't do any test planning while performing the ad hoc testing. We don't follow any test cases while performing the ad hoc testing, because it is a completely random without any formal process or structured process. Okay. So this is what is the answer for this question, guys. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 142. That is, what is buddy testing? Let me answer. Buddy testing is a random testing which falls into one of the ad hoc testing types. Under ad hoc testing, there are different types like buddy testing, pair testing, and monkey testing. So buddy testing is one of the ad hoc testing types where random testing is performed. Now, what exactly is buddy testing and how it is performed? In buddy testing, the testing will be performed by two buddies. As buddy is there, right, in the word. So the testing here in the buddy testing will be performed by two buddies on same module. At the same time on same module, two buddies will be performing the testing. Why two buddies on same module at same time are performing the testing? To speed up the work due to lack of time. There may be some situations in the project where we don't have much time, okay, and we have to complete the work faster. Then this kind of buddy testing approach will be followed, where random testing will be performed by two buddies on same module at the same time to speed up the work. Here one of the buddy will be from the development team and other buddy will be from the testing team. Okay, out of these two buddies who are testing the same module at the same time to speed up the work, right, due to lack of time, there one of the buddy will be a development team, from the development team other buddy will from the testing team. So what is the advantage of this kind of buddy testing approach? The advantages are faster development and testing. Okay. So whenever there is a lack of time in our project to complete the work, to speed up the work, to make the work faster, to do the work faster, or to make the work a rapid pace. Okay, to complete the work in a rapid pace. In that case, for the faster development and testing, the two buddies, one buddy from the development team, other buddy from the testing team, will be performing this buddy testing so that faster development and testing will happen. How the faster development and testing will happen here? Due to several reasons, guys. Okay, you see, while while these two buddies are working on the same module of the application, so what happens is while tester is creating better test cases with the help of the developer, because developer will be quickly sharing the knowledge to the tester and tester can start early, okay, early creation of the test cases and better creation of the test cases, and because of this the work will become faster for the tester, right? Tester don't have to wait so much of time. Developer will help the tester in building the test cases or creating the test cases by sharing his knowledge on the application. Okay, and any doubts or any ambiguities regarding the test cases, right, development team, the buddy from the development team will help the tester, okay, and help in developing the better test cases. With the help of the developer, that is one of the buddy, the tester will create or develop better test cases in a faster way. Same time, because of the testing mindset, you see, the tester will do some testing and developer will come to know. Okay, the other buddy, the developer will come to know what are the changes to be done. So here the changes will be done with the help of the tester. Developer will change the code changes or design changes very quickly. Okay, so that's what is the advantage here. Both developer and buddy who are acting like two buddies will work together on the same module, help each other in testing and developing the application faster, that particular application module faster. Okay, here there is no need of raising the defects, right? Tester will immediately inform the development team that developer buddy that there is a bug. Okay, without raising, the developer will fix the bug there itself. Okay, if there is no raising of the defect, there is no need of fixing the defect, right, or bug, right? So the time taken for reporting the defect and fixing the defect and informing the testing team to retest and all, everything will be reduced, guys, here, because they are testing together, they are working together. Okay, they are working together to make the development testing to become faster. Okay, faster development and testing, this is the advantage, guys. Okay, and mostly it is used when you have lack of time. Okay, when there is less time and you have to complete the development and testing faster, then we generally go for that buddy testing, where one of the buddy will be a developer, other buddy will be a tester, and they will be helping each other so that the developer buddy with the help of tester will do the changes, code changes or design changes quickly, while tester buddy with the help of the developer buddy, by taking his knowledge or not, or whatever the internal knowledge of the application, because he has some coding knowledge, right? So with that knowledge and all, coding of the application knowledge and all, with that knowledge tester will create the test cases faster. Okay, so and as they are intact working together, there is no need of reporting the defects or mentioning that I have fixed the defects and all those stuff. Okay, so things will happen so faster. And when it is performed, when this buddy testing will be performed, buddy testing will be performed after unit testing is completed, guys. Okay, once the development team, that is a developer buddy, completes the unit testing, then only the buddy testing will start, where developer and one buddy, that is developer, other buddy, that is tester, will be working together on the same module at the same time to speed up the work when there is lack of time in the project. So in kind of uncertain conditions or situations in the project where the time is very limited and you have to do the work faster, this kind of approaches are followed. Okay, the company management team, what they will do is they will decide two buddies. One will be developer buddy, other will be the tester buddy, and ask them to do the work faster. Okay, so we cannot follow a formal process or structured process here. Do random testing and do the work faster. Okay, discuss together and try to complete the work faster. Such kind of situations, buddy testing is performed. That's why buddy testing is a random testing which falls into the ad hoc testing type category. Okay. So apart from buddy, we also under ad hoc testing types, we have pair and monkey. Okay. As I already explained. So hope guys you got the answer for this question. That is what is buddy testing in this session. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.
Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 143. That is, what is pair testing? Let me answer. Pair testing is a random testing which falls into one of the ad hoc testing types. Under ad hoc testing, we have different testing types like buddy testing, pair testing, and monkey testing. As I mentioned, pair testing falls into this ad hoc testing types where random testing is performed. In pair testing, two testers having different knowledge levels test the same feature at same time and same place. Okay, in pair testing, two software testers having different knowledge levels test the same feature at same time and same place. That is same machine or something. Okay, so it's like combined studies, guys. Okay, so just imagine, guys. Let's say you are studying by yourself. Okay, you only have some portion of knowledge. Okay, and while you're studying that particular portion of the subject or something, you will be producing better results. But when you come to the other chapters where you are not good at, then you will be a bit slow, right? Now let's say you have one friend. That friend is not good at whatever the subjects you are good at, but he is good at the other subjects you are not good at. Now let's say instead of you two guys separately studying and preparing for an exam or something, okay, if you do combined studies where you two guys come together, sit together, and discuss all this stuff, okay, learn all these subjects with together help, okay, helping each other. What happens? The subjects that you don't know will be shared by the other friend or someone, and you will help your friend in the subjects he is weak at. Okay, so like that, ultimately you two people by sitting together will generate better results, right? This is what happens in the pair testing also, but here instead of those two people studying, here two testers, okay, two testers who are having different knowledge levels. There's the same feature at the same time and same place to get better results. Okay, by doing this pair testing, those two testers having different knowledge levels will exchange the ideas during this okay, during this process. We'll discuss, okay, not only discuss about the ideas and all, they'll discuss everything. Whatever the work they are doing, they will discuss, okay? Exchange the ideas, they will do a lot of discussions and brainstorming, you can say. They will note down, okay, while one person is right, doing something, reading or explaining something, other person will make a note, or okay, such kind of activities can be done to fasten up the work. They will collaborate and share knowledge within each other. This is what happens in pair testing. So what are the advantages we get as part of the pair testing if the testing is done in the form of two people, two testers working together having different knowledge? Faster testing is possible. Okay, as two people are focusing, two minds are focusing, the faster testing will happen. And also, you see, this is more helpful. Pair testing is more helpful. Let's say there is one new beginner joined the team. Okay, is a fresher who is very new to testing. Okay, instead of giving him a lot of training and all those stuff, right, and making him work independently, let's say you attach one, okay, as a test lead or someone who is a bigger role, you just attach one senior tester to the junior tester and ask them to work together. Okay, what happens during the process? The senior tester will share the knowledge quickly to the junior tester and help him complete the work. So with this, right, the the junior or the fresher or the beginner who just joined the team will come up to the speed in testing very faster. Okay, he will understand the things very bit faster. Okay,
So collaboration of different knowledge levels, okay, senior with junior, or maybe more knowledgeable person with a knowledgeable person, when they work together, right? The collaboration will be there and knowledge sharing will happen, and outcome will be good, brainstorming will be good. Okay, more accuracy work will be there because they brainstorm and generate the accurate work. Better outcome will work, better work will come, like a better test cases will be created, better bug reports with good details will be reported, and so on. The work will become better and accurate. Okay, these are the advantages, guys. These are the advantages of the pair testing: faster, better, accurate work, along with the knowledge sharing and collaboration, and quickly bring the beginners to come up to the speed in the projects. Also, this pair testing will help. So in the last session, I answered another interview question on what is buddy testing. Though this buddy testing and pair testing look similar, okay? Though this buddy testing and pair testing looks similar, where in buddy testing also two people will be testing. In pair testing also, two people will pair up and perform testing. But what is the difference? Though most of the things are same, the purpose is same. But what is the difference is, okay, that I'm going to explain in the next session. Okay, the next session I'm going to answer another interview question. That is where I'm going to explain the difference between the buddy testing and pair testing. Okay, so at a high level, guys, in buddy testing there will be one from the development team, one buddy from the development team, one buddy from the testing team. But in pair testing, two people will be from the testing team only, but they should have the different knowledge levels. Okay, so then only we'll get the results, right? A senior and junior, or okay, a high knowledgeable person with a low knowledgeable person, or high with the next level knowledgeable person, whatever it is, from the same testing team will be doing here, from different, okay, developer with tester and all. Okay, here from the same. At a high level, this is difference. I'll explain more about this buddy testing versus pay testing in the next session as part of the interview questions. Okay, I'll be covering that in detail in the next session. Fine. So hope, guys, you got the answer for this interview question. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 144. That is, what is the difference between buddy testing and pair testing? Let me answer. Both buddy testing and pair testing are ad hoc testing types. Okay. Under ad hoc testing, there are different types. That is buddy testing, pair testing, and monkey testing. In all these types of ad hoc testing, the testing will be performed randomly without following any formal process or structure. Okay. So unstructured way, the testing will be performed without any formal process or plan. The testing will be done in a random way in case of this buddy testing or paid testing or monkey testing. Okay. But the names buddy testing and paid testing look similar, right? But what is the difference? What is the exact difference between this buddy testing and pair testing? Buddy means two buddies. Pair means two people of, okay, two pair of people working together as part of testing. But though they look similar and feel same, but they are not same. Okay, there is a difference between buddy testing and pair testing that I'm going to explain now. The difference between the buddy testing and pair testing is, in case of buddy testing, one buddy is a developer and other buddy is a tester. Okay, so in case of buddy testing, the testing will be performed by a developer buddy and a testing tester buddy together. Okay. So what is the advantage here as part of buddy testing? Why the developer and tester has to work together? The advantage here is to complete the things faster, to complete the work faster. So when there is less time, okay, let's say this developer and tester belong to the same project, and due to some situations in the project, the work has to be completed faster. Okay, there is very less time to give the deliverables. In that case, what the developer and tester buddy will do, since there is less time, this developer buddy and tester buddy will plan to work together to speed up their work. Okay, by mutual collaboration and help. So how the work will get speed up in this case? Because even developer and tester will sit together, you know, they will developer may share the knowledge to the tester, and tester may share his or her insights to the developer, right? So like these bugs may appear. Okay, so make sure that you write the code in a better way, like that. Okay, so they have a mutual collaboration and help, where developer with the help of the tester will modify the code in a faster way. Okay, he will change the design, code design, and code changes very faster way with the given insights of the tester. Similar way, tester will get faster knowledge from the developer and will be able to create test cases, or we can perform testing faster. Okay, so in this buddy testing, uh, the developer buddy and tester buddy will collaborate and speed up their work. Okay, when there is less time in the project and the work has to be completed, then developer buddy and tester buddy will work together with mutual collaboration and help. They will work together and complete the work faster. And in this case, right, the tester doesn't have to report the bugs or defects. Since the tester doesn't report the bugs, developer buddy may not have to, right, take time to make them as fixed. Okay, change the status and all the process will be reduced a bit, and the work will be completed faster since they are working together. Okay, they are trying to produce a outcome in less time. Okay, by not following the process in a random way, they will be working, and they will be getting the outcome with mutual collaboration. They'll get the benefit, this kind of benefit out. Okay, that is what is buddy testing. But in case of pair testing, in case of pair testing, here two tester, okay, two testers will be working together. Here a developer and tester, right? Here pair testing will be performed by two testers having different knowledge levels. Okay, one tester will be having higher knowledge level than the other tester. Why the two testers have to pair up and start working together? You see, you take the example of the combined studies. Okay, let's say the person A has some in a particular subject. Okay, there is an exam coming in 1 or 2 days. There is an exam, and one person A has some knowledge of a few chapters, while the person B has the knowledge of the remaining chapters. So if these two people pair up, person A and person B pair up, okay, and do the studies combinedly, what will happen? They can share the knowledge in the areas they are not aware of, and they can, right, be prepared for the exam faster, right? Quicker way, and also in a more better way, accurate way. They can learn in a better way, right? Same thing can be applied to the pair testing when two software testers having different knowledge levels, okay, meet up, okay, pair up and perform testing. What will happen? There will be different advantages, guys. Faster knowledge sharing and better outcome. Okay, faster knowledge sharing will happen between each tester, and they will do a lot of brainstorming, and they will try to produce better outcome. Okay, better ideas will be generated, better brainstorming will be done, discussions will be done, and faster way, faster knowledge sharing will happen, and better outcome, better results will come out of that. So this kind of pair testing is generally used when a new joinee joins the testing team, and that joinee will be paired up with a senior tester by the test lead or someone, and they will be working together so that the knowledge sharing will become faster, and the the time that will be taken for this new journey to come to the speed will reduce. Okay, with the help of pair testing. So the buddy testing has its own advantages. Okay, and pair testing has its own advantages. So this is what is the difference between buddy testing and pair testing. So hope guys you got the answer for this question in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 145. That is, what is confirmation testing? Let me answer. Confirmation testing is nothing but retesting. Both retesting and confirmation testing are same, where testing performed by software testers to verify whether the defects reported earlier by them are fixed by developers or not is known as retesting or confirmation testing. Let's say the software testers have reported some defects, and these defects are fixed by developers in some version of the software. Then software testers will perform retesting to cross-check whether the earlier reported defects by them are fixed by developers or not. This is called as confirmation testing or retesting. So hope you got the answer for this question. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 146. That is, what is the difference between HLD and LLD? Let me answer. So, what is the difference between HLD and LLD? First of all, the technical team will receive the client requirements. After receiving this client requirements, the technical team will prepare this HLD and LLD before developing the software. So what does this HLD contain? What does this LLD contain? Let me explain. First of all, HLD stands for high level design and is created or prepared by solution architect in different forms like flow diagrams, flow charts, and other diagrammatical formats. So solution architect will prepare this HLD, that is high level design, where the solution architect will include the design for system architecture, the software architecture, the software that has to be developed. The architecture for the software will be designed as part of this high level design. So it's a higher level representation of the software, guys, okay, which includes all the different layers and all how the communication is happening between the layers. Such kind of higher level system architecture will be represented in this high level design by this solution architect. So database design also will be there, and also the description of several things like systems to be used for building the software, the platforms to be used for building the software, the services to be used while building the software, and relationship between different modules and components. Everything will be represented in this high level design at a high level using the different diagrams by solution architect. Okay. So this is what is a higher level design. Now coming to the low level design. Low level design is prepared by designer or developer. So as the name speaks, low level design here, as part of the low level design, the user interface for components will be designed. Okay, so you can see how the screens will look like, the user screens will look like here. In this high level design, only the high level architecture, like which component is talking to which component, which system is talking to which system, how the database is connected to the different platforms and all, that kind of higher level thing will be represented in high level design. But coming to low level design, a detailed description of this higher level design will be done in the form of user interface. We'll get a kind of clarity here, like how the screens are going to look like, and also the actual logic implementation of the components also will be there here, like which classes are we are going to use, which methods we are going to use for building this particular components of the software. Everything will be provided or represented in this low level design, pseudo code and such kind of things will be there in the low level design, guys. In high level design, only the higher layer higher layer representation where communication between different systems, services, platforms, modules will be there. But in low level design, a detailed design will be there, where user interface for the components, how the user interface is going to look for this particular thing, and how the components are going to be developed, like which classes we are going to use, which methods we are going to use. All such kind of things will be represented in the lower level design, low level design, and pseudo code and all those things will be there. So this is what at a high level, what is high level design and low level design. So hope guys you got the answer for this question. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 147. That is, what is monkey testing? Let me answer. Monkey testing is one of the ad hoc testing types. Under ad hoc testing, we have different types like body testing, pair testing, and monkey testing. So monkey testing is one of the ad hoc testing types where testing is performed in a random way. So what exactly is this monkey testing? In monkey testing, random testing will be performed by providing random inputs. Okay, we'll be simply testing in a random way by providing random inputs to check the behavior of the application. Okay, by doing this random testing by providing random inputs, we will verify the behavior, how the behavior of the application is impacting because of this random testing or providing random inputs while testing. Is the application crashing or not because of this random testing or random inputs? That will be the focus point while testing. And here no test cases, no boundaries will be set, guys. Okay, when you are performing the monkey testing, there are no boundaries set, no predefined test cases, no strategy to be followed. Okay, you don't have to go in a particular strategy. Whatever you feel at that point of time, whatever the feeling you get, just test it in a random way with by providing random inputs to see how the behavior of the application is getting impacted because of your random testing, and to see whether the application is crashing or not because of your random testing by providing random inputs. Here it's all based on mood based case. Okay, there are no boundaries, complete freedom is provided to you. Okay, you can behave like a monkey and perform testing whatever you feel at that point of time. Whatever the feeling you have at that point of time, you can clear it out by performing this monkey testing. Okay, and it is a gut based uh, gut gut feeling based testing, where you know, right, what if you feel like, okay, I want to test like this. Okay, complete freedom is given to you. Just go there and attack it and then test it. Okay, That's how the monkey testing can be done. So hope guys you got the answer for what is monkey testing in this session. That's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 148. That is, what is Gorilla testing? Let me answer. In Gorilla testing, we test the same module repeatedly. That is, we test the same functionality again and again towards its breaking point. What is the advantage of performing this Gorilla testing where you test the same functionality or same module repeatedly, that is again and again towards its breaking point? What is the advantage? If the application functionality is still working properly or working correctly despite of testing that particular functionality repeatedly, that is again and again towards its breaking point, then we can gain utmost confidence that the application functionality is stable. That's what is the advantage of the Gorilla testing. So hope guys you got the answer for what is Gorilla testing in this session. That's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 149. That is, what is fuzz testing? Let me answer. In fuzz testing, the testing will be performed by putting random or invalid data known as fuzz into the software system with an intention of detecting the coding errors and security loopholes in the system. So in this statement, fuzz means the random or invalid data. Okay, whatever the random or invalid data that we are using for testing or performing the fuzz testing, right? That random or invalid data is known as fuzz. And next thing is here to generate this fuzz. Okay, to generate this random or invalid data known as fuzz, we use automated systems. Okay, automation or semi-automation we use to generate or to perform this fuzz testing. So a tool will be there. Okay, a set of tools will be there. Like here, an example of the tools we have, we can use for fuzz testing or bubsuit. We can use bubsuit tool. Okay, which will generate the fuzz, that is random or invalid data, which can be used for detecting the coding errors and security loopholes in the system while performing the fuzz testing. Okay, and apart from bubsuit, we also have another example as OAS, WS Fuzzer, and many other tools are there in the market for performing the fuzz testing. And as you already have understood, so why we have to perform fuzz testing? By providing random or invalid data called fuzz into the software system. Why we are doing all this fuzz testing? So with an intention of identifying the coding errors, crashes, and security loopholes in the system, we perform fuzz testing. This is what is fuzz testing, guys. Just to conclude, the testing performed by putting random or invalid data known as fuzz into the software system with an intention of detecting or identifying the coding errors, crashes, and security loopholes in the system is known as fuzz testing. So hope guys you got the answer for what is fuzz testing. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 150. That is, what is the difference between authentication and authorization? Let me answer. So what is the difference between authentication and authorization? Coming to authentication, it's a process of identifying someone. Okay. The process of identifying someone or a user is known as authentication. Coming to authorization, it's the process of verifying what user can access, what level of access the user have is known as authorization. So let me give an example. I'll take a sample application in that what is authentication and what is authorization. I'll explain with examples. Okay. So coming to the authentication, so by providing credentials to log into application is nothing but it falls into authentication. With these credentials, with this user credentials, we are identifying the user or someone, and then only we are allowing the user to log into the application, right? That's why it is falling into the authentication. For example, if I take you to this application, tutorialsindia.com/demo application, if I take you to the login page, here, if I give some valid credentials, okay, valid username and valid password here, and click on the login button, okay, so let me give the password again, login, you see, so if the user is logged in, okay, on providing the valid credentials and clicking on the login button, the user got logged in means the system is identifying the user, and this is called as authentication. But it doesn't mean that user can do anything. Okay, though the system is allowing the user to log into the application by authenticating, it doesn't mean that user can do anything. So here authorization steps in. Okay, what user is authorized? Whatever the user that got logged into the system, what the user is authorized to do that. User is authorized to search for a product. Okay, you see this particular logged in user, is able to search for the products, and also this particular logged in user can also place the orders. But is there any possibility where this particular logged in user can change this image? Is it possible for this user to change this image? It's not possible. So authorization level is not there for updating the images. So the user can go through the details of this particular product details, okay, and what is the price and all, but he or she doesn't have the permission levels or access levels for updating these images or updating this price of the product, okay, or modifying any other details here. It's not possible, right? It's not there. So that is what is authorization. What user is authorized to do on the application is called as authorization. Coming to authentication, just by giving the credentials, the user is getting authenticated by the system. But after getting authenticated, user only has the access to only has some access level to do something like searching, placing an order and all, but the user cannot do everything. Okay. So what level of access the user has is known as authorization. Okay. So hope guys you understood what is the difference between authentication and authorization in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.